And hello everyone, welcome to your Lua crash course. So this course will contain everything about Lua. We'll learn Lua and then later on we'll learn a little bit of Love2D and then we'll build a few games with Lua. But let's not get ahead of ourselves. What exactly is Lua? Lua is a high-level procedural programming language designed in 1993, primarily to be embedded into other applications. If most of this flew over your head, it's perfectly fine. Most things you'll have to take in here is that Lua is a procedural programming language, meaning that things like object orientation doesn't really exist in Lua, but you can simulate it. These days, it is mainly used in games, so you'll usually see it being used with Love2D or Roblox, or it will be used with games built in C or C++ as a little bit of extra used on the side. Now, where exactly was Lua used? Well, it was used in Adobe Photoshop Lightroom, Apache the HTTP server, the awesome window manager, Roblox, Angry Birds, The Sims 2, Mafia 2, World of Warcraft, and Fable 3. As you can see, a lot of these are games because Lua is very popular to be used with games because of how easy it is to embed Lua in your game. Well, what text editor should you use if you want to code along? Well, it can be absolutely anything, from a Notepad all the way down to IntelliJ IDEA. I will be using VSCode during this whole course, mainly because that is what I have grown to love and learn. But if you have no experience in any of these, I would recommend using Notepad, but if you want something a bit more powerful, then definitely go Sublime Text. So just go to the Lua website, so lua.org. Then here you have a little download option. Click on that. Then you want to just ignore all of this because compiling on Windows, gross, who wants to do that? And this is a Linux only thing if I'm correct. So we can actually just go to here. If you don't have the time or inclination to compile Lua yourself, like any normal Windows user, get a binary or try the live demo. We want to get the binary. Binary is just basically the executable. Now don't be fooled by all of this. You don't download it from here. You go to this download page right here. They make it a massive pain to actually get what you want. It's very interesting. Then here you have a bunch of options to choose from. I would like to go with 5.3.6 because 5.4.2 has a lot of changes and stuff that just sucks. So here we have a bunch of things we can choose from. This is Linux. This is Windows 32-bit. Windows 64-bit. If you're on Windows, you probably have 64-bit. And take note, this will also work on Windows 11. Just because I'm using Windows 10 doesn't mean it won't work on Windows 11. And then we have Mac, which I seem to not be able to download. And then we have more Linux. Or that's the source. This is Linux. Now we want the 64-bit zip file. So if we click that, it will start downloading our files. We just say save file. And I believe it's done. We can now open up our file manager and we can go to downloads, and you can see we have a Lua 5.3.6. We can right click and extract the file. If you don't have this option, I recommend you go install WinRAR or some sort of file extracting software. I like using WinRAR because it just works. I'm going to extract to Lua 5.3.6, but if you just said extract here, it would have been perfectly fine. Now in here we have a bunch of options. Or not a bunch of options, this is just the executables. This is the most important file here. This allows us to actually run our Lua code, which we'll do in a second. Now what we need to do is we can go back here and we can rename this. You can rename it to anything you want, but I'll just call it Lua because that's simple, you know that's Lua. Now I'm going to copy this, so you can right click and we can say copy. And I'm going to go to my local C drive. Now you can just paste it in here if you want, but I do prefer going to program files right there and then just saying paste because it's a program. So we want to paste it here. There we go. Now next thing we can do is we can open up the command prompt. So you can click here, search command prompt, and it actually, why did I go to this page? Anyways, once you search command prompt, you should see this. Now first try to type Lua. If you don't get anything, that's perfectly fine. Try to type Lua 5.3. Doesn't work. Okay, if you do get this, then that means it has not yet been added to path. One way to fix this is by rebooting. Another way to fix this is by going to settings, which can I search here? I can, okay. Going to settings, and it's searching here environment variables. So here, edit the system environment variables. And in here, you can just say environment variables down here. Then you don't have to worry about this too much. You can go down here to path. You can say edit. And these are the locations where all the environment variables is. As you can see, my program files x86 is here, but not my normal program files. Or at least some of these x86s are here. So what I'm going to do is I'm going to say new, and I'm going to browse, because the thing is, it's a very difficult way to get there. So I'm going to just browse to where it is, and here program files, we saved it in there, and there's Lua. Now if we say OK, as you can see, it added it here for us. So it added it to the program files, now, or the environment variables. Now if we were to say OK, I just need to put a folder there because it's going to scan the folder. You don't have to worry about the executables. You say OK, and you close that. Then now also, if you do want to, you could always rename this to Lua and just remove the 5.3. I don't know if that will still work, but I'm pretty sure it will. You then have to exit out of the command prompt and just open it up again. Okay, please open here. And to look like a hacker, you can say color 02. Cool, now that we look like a hacker, we can clear the terminal, or CLS, and we can say Lua 5.3. This will allow you to code Lua. If you see this, you did it correctly. Also, if you didn't download Lua 5.3, you will have a different number here, depending on the version you downloaded it. And that just executes the program. Now we can say print test to make sure this works. If it works, then you're good to go. Next up, you probably want to actually try and run a file in Lua, or a Lua file itself. I'm going to create a new folder. I'm going to call it Lua for my Lua programs. Here I'm going to say new text document, and make sure you can see this .txt there. We want to change that. So we're going to say main.lua and remove that .txt if it was there, and just say yes, and you should see this. You can then edit it with Notepad if they give you the option to do it. So let's open it with, and let's see here, more apps, Notepad, there we go. And yeah, we didn't need to always open it up with that. Then here we can of course just say print I am cool. Save this file by clicking file and save, or just Control S. And you can close Notepad. And now here you can just shift right click, and you can say open PowerShell window here. There's multiple ways to do this, but this is usually the easiest. Then you'll see this. You can then just say Lua 5.3, and in the file, so then right there, main.lua, we can then say main.lua. There you go, I am cool. If, however, this did not work, then you can just open up your command prompt again, bring it over here, whoa. And now we need to navigate to this folder. One way you can do this is you can just right click here and copy address. Now you can just say cd for change directory and right click. If you right click, then it will paste it here. Press enter, and now you're inside of this folder. Now you can say Lua 5.3 and main.lua. There you go, I am cool. First, you open up VS Code. This is a VS Code specific tutorial, so you search VS Code. If you don't have it installed, you do need to go and download it. Okay, then once you have your Visual Studio Code open, you want to go to File, and in Open Folder, not Open File, but Open Folder. Once you say that, you can go to your folder where your Lua program is in, so that main.lua file, or whatever you call that file. And here we go. I have a main.lua file which just says print I am cool. That's all it does. It's just this file right here. And I can show you that this file exists by going to my documents and to that folder I just opened. There we go, main.lua. Cool. Now that you have this here, you can just go to terminal, new terminal, and here we have a terminal. If you have Lua already installed, you can just say Lua 5 free and then main.lua. I am cool. As easy as that, you have just executed your Lua code. We just need a couple of things, so we can open up Chrome. Any browser of your choice, Safari would work perfectly fine as well. Then you want to search for Homebrew. Now Homebrew is what we're going to be using, and it would be at brew.sh. And we'll be using this to install Lua onto our system. So here you can just copy that where it says install Homebrew. We copy that there. Then we open up our terminal. Alright, so we paste that here. That would be Command and V, or alternatively right click paste. Now this will take quite a while. I've already run this on my system, so I will not be running this again. So in my case, I'm going to cancel this, but you should run it on your side. Now you'll have Homebrew installed. You might need to reboot your system for Homebrew to work correctly. But once you have Homebrew installed, you can just say brew, search, and Lua. If this command does not work for you, then keep in mind Homebrew might not have been installed correctly. So make sure, maybe just run through the installation again. Alright, so we searched for it. This might take a while, especially if you're searching for Lua the first time. For me, it took a solid minute, and I did it before the tutorial. So for you, it might take around the same time. Now here you can see there's a bunch of different Luas you can get. For example, let's say I want to get Lua 5.3. If you want to get a different version of Lua, feel free to do it. So here you can just say brew, install Lua at 5.3. Or alternatively, you can see I also have Lua installed, the regular, just normal Lua. You can also install that, so just Lua, but I'm going to specifically choose 5.3. Alright, now after waiting about a year, Lua should be installed. And now, if we go Lua and press tab, you'll notice I have a couple of Lua. So I have Lua 5.4, regular Lua, and I should have a 5.3 here. Ah, seems not. Oh, here we go. If you need to have Lua first in your path, run. So if you might need to add this to your path for Lua 5.3 to work. So to add it to your path, you can simply just copy this. Just right click, we say copy, we right click again, we say paste. We just run that. And now we can close out our terminal and open up a new terminal because we added it to path. So we need to refresh it a little bit. And now here we can just say Lua, press tab. You'll notice we have Lua 5.3. So if you don't have it immediately, you might need to add it to path first via that command we just did. And also 5.4, that's the latest one we currently have on Mac if I'm not mistaken. So now that we have that, I'm going to open up my code editor. This could be whatever text editor you want. I prefer VSCode because it is simpler and easier for me to understand. You might prefer something different. Let's open up our Finder. We can go to our let's go to our code folder. So here I have a specific code folder I'm using. I'm going to create a new folder called My Lua. Inside this folder, I'm going to create a new file. Oh, I can't. That is classic macOS. That is not an issue. So we're just going to take this folder, drag it into VS Code. You'll notice it's refreshing, and now we get this here. So you'll notice if we go up here, that's the Explorer, we have a My Lua. So that is the folder itself. Now we can actually show you right here. I'm going to click this button right here, but you can also double tap and say new file. But I'm going to click this one here, and I'm going to call it main.lua. If we go in here, you'll notice we now have a main.lua file in here. So whatever you see here is exactly what's happening inside of this folder. If I rename this to test.lua, then this will also be renamed to test.lua. So everything here is just what is inside of the folder, so don't be scared about that. I'm going to rename this to main.lua. Make sure it has the .lua extension, so you can have your full Lua support in VS Code. Then I'm going to say print hello world. Take note of the quotes, take note of the brackets, take note of the spelling of print. These are very important. If you don't have them correct, then unfortunately your code will not run. Next up, you need to save your code, either via Command and S or File, Save. Once you have saved your code, and you'll know if your code isn't saved because if you go like this, you'll notice I have a dot here. That means it is not saved. And if I were to just Ctrl S, you'll notice the dot is gone. Alright, next up, we're going to go to Terminal, New Terminal. Take note, this terminal here is the exact same terminal we have here. It is the complete same one. There's no difference between the two. So here, all it does is it opens up inside of this folder we dragged and dropped. So my Lua. This is the folder we are inside of. So that's the only difference between that terminal that we have here and this one here. This one here opens up inside of this folder. So if I say ls, I should be able to see main.lua. If you cannot see main.lua, you might be in the wrong folder. Now I'm going to say Lua main, and I'm going to press tab so it auto-completes, but main.lua. Make sure the spelling here is the same as this file's spelling. If the spelling is not correct, it will not run. You might need to specify a version like 5.3. So if you don't have a regular Lua like this, which if we do this, we get hello world, you might need to specify the version you downloaded, so 5.3. And that will run perfectly fine as well. If you get hello world, then you have successfully written your first Lua program and you have successfully installed Lua. If you are on Linux, then it's fairly simple. If you're on a Debian/Ubuntu based distro, this would be things like Linux Mint, Pop! OS, Ubuntu, Debian, anything that falls into like those categories, it's not just limited to those, will be Debian or Ubuntu based. In that case, what you can do is you can go to Applications and just find the terminal. I'm using Pop! OS, but this again should work on any Ubuntu based distro. Once you're here, you just say sudo apt update, and this will just update your repository so you have the latest apps when you download. Now I get a bunch of errors here. You should not see this. Only reason I get these errors is because this is my play distro. This is what I use to just test things and ruin everything. Cool. Now once you've done that, you can just say sudo apt cache search Lua. Now you should see a ton of things here, but if we were to just increase the size here, then we can go up here, search for Lua. I'm just going to filter by Lua, just so we don't get anything that's not directly related to Lua. Here we go. Alright, so we can choose from here. You can choose one of these. So Lua 5.1 would be Lua version 5.1. And then here would be the latest, Lua version 5.4. Depending on what you want, you can choose any of these. You can even download all of them if you want. I'm going to say I want Lua version 5.3 as an example. Then I can say sudo apt install Lua 5.3. If you want a different version of Lua as well, you can add it here. So Lua 5.4. 4, for example. So now I will get Lua 5.3 and 5.4. When I do this, it will start installing Lua. Now I have Lua version 5.3 and 5.4 on my system. When I type Lua and press tab 2 times, you'll see I get Lua 5.3 and 5.4 here. If I say Lua 5.3, press enter, now I'm in the Lua console, so the Lua interpreter. If I put Lua code here, print X, it will work. Similar, if I were to, let's just echo print hello world into test.lua. So now I have a file here called test.lua. If I want to run this, I need to say Lua 5. Let's go 5.4 this time, but you could use 5.3 here or 5.2 of whichever version you used. And you could say test.lua. And now you'll see it does execute that file. Now that is if you're on an Ubuntu based distro. Now I'll also just be answering a couple of questions that was asked to me from the free code camp video that was uploaded. Now one of the most common questions that I have received is what extensions am I using for Lua? Now simply if you go to VSCode, and I'll increase the size here so everyone can see. We search up Lua, then just install the first one. This is the one I'm using. It is by Sumneko, and it is pretty much perfect for all the needs I may have. And then other than that, one of the other most common questions was, why am I using Lua 5.3? There is no reason why I'm using 5.3. You can use any version of Lua you want, as long as it falls within Lua 5. So 5.4 is fine, 5.2, 5.1, 5.5 if that is released. You can use those. As long as it is with Lua 5, there shouldn't be any breaking changes or big differences between this tutorial and the version of Lua. I'm going to open up my file manager and I'm going to go to documents. I have a special folder called trash where I put all of the things that once I format my PC, I don't care about it. You will probably have a code folder similar to what I have here where I put all of my other code. But for me, I'm going to put it in trash. I'm going to create a new folder and call it Lua. In here, I want to create a new file called main.lua. If you're on Windows, make sure that this actually ends in main.lua and not main.lua.txt. Windows will oftentimes append that extension to the file name, which you do not want. Once you have done this, you can open up your code editor in this folder. Since I use VSCode, I'll quickly open it up here. Here we go. Now everything you see here is what will appear here. So this main.lua, that is here. If this right here says main.lua.txt, then Windows did you in and they try to add a .txt extension at the end. You can just go here and then rename it and remove that .txt. I'm going to close this file manager here because I don't need it open anymore. Alright. Now first off, I would like to resize everything just so everyone can see. Great. To run my Lua code, I will use this terminal right here. But take note that this terminal is the exact same terminal as this terminal right here. The two are exactly the same. The only difference is this terminal is inside of VSCode, while this terminal is not inside of VSCode. That's the only difference. They both run the same thing. If you're on Windows or Mac, you don't have to open up a terminal on the side. You can just go terminal, new terminal, and you'll have a terminal to use. Alright, now that we have that out of the way, I'm just going to get my setup ready. And here we go. And this is why I like having this terminal here. It just looks so much neater and we have a lot more space to work with. Next up, I'm going to close my file manager because I don't need to see this Lua file because I'm already in it. So let's start with the basics. Make sure you have Lua installed by going Lua -- version. And actually, if you get this, then you know Lua is installed. But if you go Lua -v, then you should also see this. If you just type normal Lua, then you'll be able to do something like print any type of text, and you should see this. To exit, you can press Ctrl and D, Ctrl and Z, or Ctrl and C. Alright, so I have Lua installed, as you could see there. So let's get started. First, I would like to tell you about comments in Lua. Oftentimes, if you're following along, you want to leave yourself a little note to explain what is going on. And this can be a comment. A comment is not read by the computer. So when you run this Lua code, a comment will be skipped. So if we go -- and anything that starts with 2 dashes is considered a comment. So this is a comment. This is also a comment. You're not limited to the amount of comments you want or have. You can just do as many as you want. But that is also a single line comment. It basically means that once I go to the next line, I'm typing regular code. You'll notice that here we have green text, and here the text is not green. That is because this text right here is not a comment. So this is a single line comment. Every time you want to add one, you'll have to add the 2 dashes to say it's the next line. You also have a multi-line comment. If you plan on having a comment that's a few lines long, such as a description of something, then you can say -- and in 2 brackets like this. This right here is a multi-line comment. And then make sure there's no space between your dashes and your brackets here. There we go. Now this can range multiple lines. So multi-line comment. It is amazing because now everything that's between these is part of the comment, meaning if you put any code in here, it will not execute. Same here, if I put any code in here, it will not execute. This one is just 1 line, whilst this one can span multiple lines. Alright. Next up, let me actually show you how to print something to the screen. To print something to the screen, it's actually simple. You just use the print command, and I will print something to the screen. Hello world. So print, and then in brackets, we have quotation marks, and then a piece of text we want to print to the screen. The quotation marks and the brackets are both important here, so do not leave either of those out. If you save your file, and you run your file with Lua main.lua, and take note, I'm in the same folder as this file. I am in this folder. If I say terminal, new terminal, you'll notice it's in document /Lua. And that is where I currently am. I know there's a Lua file in here because if I say dir, I can see a main.lua. Alright. If you say Lua and then your file name, you'll get hello world, because that's what we're printing out here. You can have as many print statements as you want. Yet again, you're not limited to anything. So let's try hello Jeff. And here we'll now have a hello Jeff. And here's an example of where you could add comments. Here we could say print to the screen. And here we can say we'll print hello world. You'll notice my single line comment doesn't have to be on its own line. It can be after a command, for example, print. So here we're saying print and then we're putting a comment after it. This comment will not be read. If we were to remove those, the comment will be read and we will get an error, such as this. As you can see here, it doesn't know what that is. So if we make this, then it can continue. Take note that comments will also stop code from executing. So if I were to make this code a comment, it will not be read. So when we run this, it's just going to say hello world and no longer hello Jeff, because hello Jeff is now a comment. To split your print up into multiple words, or to add multiple things to your print statement, we can add a comma. I am cool. This comma here will add these two together. However, take note that this comma will add a tab between the two. So when we run this, we'll get hello world and then a massive tab, I am cool. If you want to add these two together without getting a tab, then you could use two dots. And these two dots means concatenate. Concatenate just means add two pieces of text together. If we save this, we get one long piece of text. If we add a space here, then there will be a space between the two pieces of text. What exactly is a data type? Well, a data type is very easy to understand. For example, when I say 5, what is 5? 5 is a number or an integer. This is a data type. 5 is the data type of number. And that is how data types works. They're very simple. So we have nil. Nil means nothing, empty, null, undefined. So if something is nil, it doesn't exist or it's empty. We then have a number, which would be something like 1, 2, negative 99, 9.87. These are all numbers. We then have string, and string is just a fancy word for text. So anything in double quotes or single quotes. These are all text. We then have Boolean. This is yes or no, also known as true or false. So true or false. If something is true, you can think of it as yes. If something is false, you can think of it as no. So when someone says, is it true that you were 5? Well, that would be yes, because it is true that you were 5. Or when you make a statement and it can be either true or false. I have been to jail. That is false. I have never been to jail. So nope, that is not true. And then you have tables. Tables is the equivalence of arrays in Lua, or lists if you're coming from Python. Tables are out of the scope of this video, so we'll be leaving them for a different video on their own. Okay, so those are data types. They're the basic ones you'll mostly be working with if you're using Lua. Now, let's get an example of a variable. A variable is something that can contain something else. It's giving a name to something so you can reuse it later. For example, local name. This is how you create a variable. By specifying local and then the variable name. This can be anything from x to name to example, like that. One way I like to teach is by using a little bit of math. For example, we have x. Now, of course, if we were to print x here, and this will just display what is inside of this variable, we'll get nil. We can also set x equal to nil, and this will be nil. You can also set x on a different line than when you created it. So here's x, and we can do that. That also works. We'll still get nil though. So let's say x is 3. Now, if you remember the basics of algebra, you can usually say something like x plus 8 is equal to 11. Now, you remember maybe in high school where you had to convert this to figure out what x is. But in this scenario, we are actually getting x. We know what x is. We are providing x. So we know we'll get 11 here. So we run this, we get 11. So x here is just a placeholder for this number 3 here. So if we do this, we'll get the same output. but this time we're just storing it in X, because now we can reuse it wherever we want. So if we run it, we'll get 11. If we change X here to, let's say, 8, then X will be changed everywhere to that 8. And we'll get to showing you more examples in a second. But you do get two types of variables. You get the local scope variable, which means it is not allowed to be used outside of this file. And when we get to it, outside functions. That is a local variable. It's not allowed to be used outside of its scope. So in this scenario, it's scoped to this file. If we create another file, we cannot use this variable from that file. But then you get your global scope variable, which could be something like global variable. And this could be 10. This global variable, as you can see, it does not start with local. It is because it is globally allowed to be used. So this global variable is allowed to be used outside of this file. So if we create another Lua file and we try to use this variable, which we'll get to in a future tutorial, we are able to use this variable. However, it is definitely good practice to go _g dot whenever you create a global variable. This is just to specify this is a global variable. It's not necessary to have this. It is completely optional, but it is kind of recommended to have an _g just to give that extra specification. We're talking about a global scope variable. Now, if a lot of this is flying over your head, don't get too concerned. We'll be practicing this a bit in future tutorials as well. Now let's look a little bit more at variables, just variables in general. We can have a floating point variable, and a floating point variable is something like 3.1415, whatnot. We can have an integer type variable. Both of these are considered numbers, and this would be a free. We can have strings, so single or double quotes, and in any piece of text. This can include these dashes that are usually used for comments. And we can also do booleans, so true or false. Booleans are a little bit out of the scope of this video, so we'll definitely get back to them in the future. As for strings, as I said, you can either do single quotes or you can do double quotes, but you can also do 2 brackets, and this will allow for multi-line strings. Take note, these strings are taken up very literal, so if we were to print F here, then we'll get a very literal representation of what we had. So if you don't want it to have a tab and a new line, you might want to just do this. And now you'll notice if we were to run this, it will look completely different. And the last thing I want to show you about variables before we move on to an example of them is how you can assign multiple variables at a time. For example, let's go local 1, 2, 3. Alright, so we have 3 variables here, separated by commas. Now we can just go 1, 2, 3. So now 1 is assigned to this 1 here. 2 is assigned to this 2 here. And 3 is assigned to this false here. So they're following the same pattern. And this is how we can assign multiple variables at the same time. Now let's use an example where we actually use a variable. For example, let's go here and say local name is equal to Steve. Then print hello, my name is, and remember to concatenate, we can use 2 dots and then whatever we want to add. In this case, we can say name. We can say name because name is a placeholder for this Steve here. So saying this is exactly the same as saying this. Let's go here. I have a cool name and then Steve. And here we have a little bit of an example. If we were to run this, we'll get hello, my name is Steve, which is here specified as name. Then here I have a cool name, comma, Steve. I have a cool name, comma, and then the name variable. If you wanted to, you could do this. Well, this is perfectly fine as well. It will give you the same results. But think of it this way. Let's say this was a piece of text that was probably like 100,000 lines of code, right? And now you want to change the name from Steve to Mike. Now you have to go Mike, and you'll have to change it on multiple places. So first Mike, and then you have to go Mike, and you have to do this 100,000 times. Immediately you can see where the benefit of using a variable would be better. Because if we use a variable like this, then if we change it at one place to Mike, Mike can also work, then it will change everywhere. And take note, once you have assigned a variable, you can reassign it. So if I go here and say name is equal to Steve, then now name will be equal to Steve. So it's first Mike or Mike and then Steve. So take note, you can reassign a variable if you ever wanted to. In this tutorial, we'll be talking about strings, aka text, anything in single or double quotes. So as we've learned from previous tutorial, local x is equal to str. This is a string. This will be taken as a piece of text and we can use it. The same with single quotes, str. This is also a string. This will also be taken up as a string. And then last but not least, these double brackets. These are kind of like literal strings. Whatever you put in here will really be displayed. So if I put a tab here, this tab will be displayed. If I were to print this and run it, then as you can see, it literally takes those tabs and new lines. So those are the three ways you'd usually be making a string. Let's continue to actually using a string. So let's say we have a piece of text here. Hello world. This is just a string. Normal string, doesn't do anything. To get the length of the string, we can put a hashtag here. And a hashtag in Lua basically means return the length of something. So if we go here, we'll get 11 because there's 11 characters in here. We could also put the hashtag here. This will also get us the length of the string. Because remember, x here is just a placeholder for this string here. So this right here, that x, is the same as me doing this. And of course, for concatenation, you can just say 2 dots and then what you want to add. Let's say an exclamation mark, and now there will be an exclamation mark. Let's say you maybe have a number, so local num is equal to 20, and you want to convert this number into a string, a piece of text, because there is a difference between numbers and strings. Well, to do that, it's fairly simple. Let's say local str is equal to toString, and this will convert this num to a string. Now if we print num and then also string, you won't really see any difference. Both of them will say 20. But if we print out the type of these, and we can do that by saying type, and then just like that. So now type and then the variable, and that will give you the type of this variable. If we were to run this, we'll get number and then string. So you'll see both of them have different types because one is now a string while the other is a number. Now with strings, you have the cool thing of escape characters. So here with print, we have a bunch of escape characters we can use. For example, hello, \n. \n means a new line, so go to the next line. World. \t, this means give it a tab, the same as saying a comma here and then putting something new there. But this is just in one string. I am. And in \v, take note, \v may not work on Windows. I have heard some comments say that when they use \v, they get like a symbol instead of a vertical tab. A vertical tab is just when you tab down instead of tab left. And I'll show you that in a second. But \v gives you a vertical tab. Almost 19. 2 backslashes will give you a backslash. And a backslash escapes a character. So you'll need 2 backslashes to get 1 backslash. And then here, we're going to say 20. So it's kind of 19/20. And now, let's say I wanted to put double quotes in this string. There are 2 ways we can go about this. The first way is I can replace these double quotes with single quotes. And now I can use double quotes. Yours. This works perfectly fine. But sometimes you cannot do that. Sometimes that will not solve your problem. In those cases, if you try and do this, you'll actually get an error. So to keep these these double quotes inside of your string, we can use a backslash, and these will escape the double quotes. And the same will be done for single quotes. So if you backslash a single quote, it will also be escaped. And these are just a few of them. There are a ton of these escape characters, but I'm not going to go through every single one of them. If we were to print this, we get hello, new line because \n, world, then a tab, not a space. This is a space. This is a tab. Then we get a tab because \t, I am, and then a vertical tab. This might not work on Windows, but it just basically tabs down instead of left to right. Almost 19/20 years. And in our quotes. Take note, forward slashes are not the same as backslashes, so backslashes will need 2, while a forward slash only needs 1. Next up, let's say we have a local string, and this string just contains hello world with an exclamation mark. Now if you print it, we'll get hello world. But there are a few things we can do with this string which is pretty cool. First off, we can say print, and then we can go string, and this will use the string functions we have inside of Lua. There's a lot. I'm not going to cover all of them, but I will be covering the ones you might like to use the most. .lower, and this will convert the string to lowercase. And you say str here. You can do the same, and then for upper, so uppercase. And then you also have one for ling, and this will get the length of a string. It's the same as if you were to say, instead of string.ling, you were to just go hashtag. Hashtag you can see as a shortened version of this. This will return the length of the string, this will convert the string to uppercase, and this will convert the string to lowercase. Let's see what we get. So we get our normal hello world, then a hello world that's just lowercase, a hello world in all caps, and then the length of this string. So let's start with mathematical operators. There's a lot of them. For example, 5 plus 5. We all know what this does. This will add 2 numbers together. I'm going to add a few here because we have quite a lot. We then have minus, which will of course subtract. And this could go into the negative values. You're not limited to just positive numbers. We have times, which is represented by an asterisk and not an actual X. So an asterisk. We have divide, which is a forward slash, not a backward slash, but a forward slash. And let's say we give 19 divided by 5. You have to the power of, so this would be 5 to the power of 2. And then we have modulo. And I'll explain this one after I've explained the rest. So let's go 17. Right, if we run this, here we go. So we start with 10 because 5 plus 5, it's 10. 5 minus 15 will give you negative 10. 5 times 5 is 25. 19 divided by 5, that will give you 3.8. Then 5 to the power of 2 will give you 25. And then 17 modulo 5 will give you 2. Now, all of them are pretty simple to understand. We have all learned these in school, except for modulo. You did learn this in school, just not quite the same. In a very basic sense, modulo is what is left over. Not literally, but it is what is left over. For example, if I say 17 divided by 5, well, that will be 5, then 10, then 15, right? So if we were to say 17 minus 15, we'll get 2, because 2 is what's left over if you were to divide these two. To give an example, let's just go here and say 17 divided by 5. One gives us 3.4 and the other gives us 2. Because 17 divided by 5 will give us how many times 17 can be divided by 5. 17 modulo 5 does the opposite. It gives us how much is left over once the 2 has been divided. So not this 0.4 here, but the actual value. Because if 5, 10, 15, and then 20, 20 cannot go into 17, so we'll have to stick with 15 because that's the lowest value we can get if we were to do this. And of course, 15 minus 17, or actually other way around, of course, 17 minus 15 will give us 2. And this is the remainder, that's what's left over. So it's almost the opposite of division. You don't have to worry too much about it. We will be using this a little bit more in the future, but you can get more used to it as time goes on. One thing I remember that people in my class always had trouble with was the order of execution in math. And order of execution can be a difficult topic because you might not remember what order what should be executed in. For example, 5 plus 2 times 10. Now, I'm relatively okay with math, so I would immediately notice that this 2 times 10, that should be done first. And then after this has been done, we'll get this 5 plus 2. But not everyone will notice this immediately, because that is just normal. Not everyone is made the same. So some may see this and think, oh, it's 5 plus 2, that's 7, 7 times 10, that will give you 70. But in actuality, it will give you 25. Because 2 times 10, that's 20. And in 20 plus 5 is 25. Now, if you're one of those that can't always remember in which order this happens, or if you just want to change the order in which this happens, then I have a solution for you. Brackets. Brackets is what we can use to specify when what should be executed. So here we could say it's first 5 plus 2, then we times it by 10. Because brackets will take priority over everything else and it will be done first. Now we will get 70. Because now it's first doing this, then it will add this. And it's perfectly fine to do it over something that is going to do first. I sometimes do this as well to make myself remember this is what will happen first. As you can see, now we'll get 25. And you can of course add more things. So now if we go times 7, then we'll first execute this. Then it will execute this. And then it will execute this. But if you want to change that, you could do this. Now it will first do this right here. Then it will do this right here. And then it will do this. So the order of execution is up to you. You can change it depending on what you want. And now I can look at a few things inside the math library. Print math.py. This will print out the value of pi. Very useful in some cases of 3.14159.265 and so on. We have math.min, which will give you the minimum value of something. So let's say 10, 5, 189. The minimum value here would be 5. That's the lowest value of all of the values passed in. If we run that, we'll get 5. If we change this to negative 10, for example, then now we'll get -10 because that's the lowest value. You can also do max. Max will do the opposite and return the largest value. So now we'll get 100. Then you have rounding, which can be very useful. So you have math.ceil, and this will round up. So 20.9, and we actually give a few here, 20.1. So these two both will go up. They will round upwards. If we run this, we'll get 21. They will not round down. Ceil is, in a sense, the ceiling. The ceiling is always above you. So if you look up, then that's what it will round. It will round towards the ceiling, upwards. Then you have the floor. The floor will do the opposite because the floor is below you. It's down, so it will round down. That will give us 20. So this is a way to force rounding to a specific point where it's either down or up. And last but not least, let's talk about random numbers. Print math.random. Simple as that, you'll get a random number. Run it, run it, run it. That's cool. You can do multiple. So that's pretty neat. But sometimes you want your randomness to be more random. To do that, you can pass in a seed. So math.random seed, and we can pass in os.time, and this will ensure that our random values we get here is always random. They will never be repeated continuously. So now if we run this, we'll get more random values. We did get a few that repeat here, but that's just sometimes if you roll to raw random, you'll get the same thing. And this only updates once every second. You can specify up until where it should go. So if we say 10 here, then it will random to 10. So 2, 10, 4, 2, 7, 7, few sevens there. So we'll continuously random towards 1 and 10. So between those two. You can specify another value here, for example 50. Now it will be between 10 and 50. So it will not go underneath 10, and it will not go higher than 50. So your program can make decisions. That is absolutely epic. You can make your program make these decisions by using an if statement, like asking a question. If something is true, then do something else. So in this case, if true, take note that's a boolean, then, and here we can just print, this was true. So one of the most basic data types is used with one of the most complex type of statements. That is pretty epic. If we run this, this was true. Now the cool thing here is, this code will only run while this here is true. If I make this false, then this code will no longer be ran. So it skips it. This makes everything way more powerful. For example, let's say local x is equal to 2. And if x, and then this is a cool symbol, is more than, and let's say 5, then print x is more than 5. Run it, and x is not more than 5. So this will not run. But if we were to say x is 9, because x is more than 5, we'll get something out of it. We also have the opposite symbol, so less than. So we have more than and less than, where you can figure out more than, we'll try and get the one that's the biggest. So if this one is bigger than this one, it's because it will try and eat the largest one. So this is a mouth, and it's trying to eat the largest one. If this is bigger than this, then it will be true. This is smaller than, because now we'll try and eat this one and hope that this one is bigger. So this will see if x is less than 5. Run it, it skips the code, but if we were to make x 2 again, then we'll get x is more. That should actually be less than 5. But you still get the point. There's a lot more comparison operators, which I'll get a little bit more into, but not every one of them. So we have the and, or, not, and I'll get into a lot of these. More than, less than, more or equal, less or equal, not equal. Yeah. Take note, in other languages you'd usually have a not equal like this. In Lua it's not with an exclamation mark. And then you have two equal symbols to say equal. So these are all you can use in here. And they're very powerful to use. For example, if x is less than 5 and x is more or equal to 2, so we're checking if x is more or the number 2. So 2, 3, and up. And this is if x is less than 5. This does not mean including 5. If x is 5, this will be false, because this only checks if x is less than 5. If you say less or equal to, then if x is 5, this will be true. So take note. Then here we can say x is between 4 and 2, both included. So this will see if x is less or equal to 4 or less than 5. This will check if x is more or equal to 2, or in other words, more than 1. It doesn't matter which one you use, more than equal, or less than equal. It more depends on what you prefer. I prefer just doing more than or less than, but occasionally when I'm a bit more tired, I would usually go for more or equal and less or equal. And if we run this, it works. If I make x 5, then it doesn't work. But if I say less or equal to 5, which will now include 5, then it will run it. This and here just says both of these should be true. So if this is true and this is false, it will not execute. So if I were to say true and false, then it won't execute. But if I say true and true, it will execute. Or we'll do the opposite. Or we'll see if one of these are true. If one of them are true, it will run. So it will run. It won't run. Or it will run, my bad. And if both of them are false, it won't run. There we go. And then a not will just basically invert something. So something that is not false is true. So it's kind of like speaking. If something is not false, it is true. If it's not true, it is false. So not false or false. And this will make this one true. And here again, brackets becomes an important part here. For example, if we were to do this, then it will say if not, and then whatever comes from this. False or false, this will be false. So if not false, if true then. So take note, brackets do play a role here. If I also make this one true, then it won't work. If I were to remove these brackets, then it won't work either, because true is now false. If I were to make this true, it will work. But if I wrap these in brackets, it will not work, because true and true, or true will return true. And this will result in a true here, so if not true. Brackets can make everything a bit more complex, but also make what you can do a lot cooler. So let me show you an example of where an if statement could be useful. Let's say local age is equal to 15. So this person is 15. If age is more or equal to 18, then let's say they want to go into a bar. So we say print, you may enter. They may enter the bar if they're 18 years or older. And here, if this works, it will run. They're not 18 or older, so if we say 20, then you may enter. Now, what if we want to give them something else? For example, if they're, let's say 17, we want to tell them to scram. They are not welcome here. So print, you are not welcome, be gone. But you might already notice what will happen here. If I run it, we'll get both. We could go if, and then age is less than 18, and then throw this in there. This is perfectly fine, so now we have two if statements, and it will work. If we go here and say 17, then you're not welcome, be gone. But there's a cleaner way to do this. We can go else. Else is when this here does not execute, so when this is false. Now we can just move this up there, and there we go. We run it, you're not welcome, be gone. If we change this to 18, then we'll run the top one. Let's say it's this bar is near a children's tourist attraction. So kids that are under the age of 12 might want to go to that attraction. So we could go here and say, else if age is less than 13, so everyone that is not a teenager yet, print the water slides are down the road. Cool. So now we're checking. If the user's age that's trying to enter is more or equal to 18, they're allowed to enter the bar. If their age is under 13, we tell them that the water slides are down the road. Otherwise, they are not welcome and they should be gone, because then we know they're teens and they're trying to sneak in to get a quick drink. Run this, you may not enter, or you may enter. If we change this to 17, then they're not welcome. If we change this to 10, then the water slides are down the road. We can of course do more. For example, local birthday is equal to false. Now let's say it's their birthday. We can go if birthday, then print you get a free drink on us. So now, if it's their birthday, they'll get a free drink. So you can use an if statement within another if statement. If we run this, let's just maybe make this 18. We'll get you may enter. If we make their birthday true, then you get a free drink on us. And there's a ton of things you can do more with if statements, but most of these you can just get by trial and error and by practicing what we've just learned. And last but not least, we can also do something like this. Local name, and let's say if local age here is more than 18. So if age is more than 18. And Mike or Jeff. So if the age is more than 18, then their name will be Mike. Otherwise Jeff. And we can imprint name. This is a cool one-liner where everything can be done in one line. So now we get Mike because their age is more than 18. If we change this to 15, then we'll get Jeff. So in this one line, you can set a variable using an if statement. You can of course also set a variable in a normal if statement. So true, and then name is equal to Luke. This right here is also valid, so print name. So this will also work. However, this is in one line, so it might be more comfortable. But if you prefer writing it out like this, then that's perfectly fine as well. However, take note, if you were to say local name here, it will recreate this name variable, and it will be scoped between this. So it will be scoped here, meaning we can't use this name here. So if we were to print out name here, we'll get Jeff. If we remove this local, then it will try and access this name here. and we get Luke. So take note, when you declare a variable, you're using local. So local, and this will declare a new variable. And it will locally scope it, so it's only allowed in its current scope. Loops is a way to repeat code so it continuously happens. So continuously runs until you tell it to stop. In Lua, there are 3 common loops we can use. The most common would probably be the for loop. And this is basically for a number until a number run the code. So for I, and this is just declaring a variable in this scope. If for I becomes 1, so we're starting at 1. Up until 10, so we're going up until the number 10. And then we can just say then, or not then, but do. And here we can say print I. This will count from 1 to 10 and print it out. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From 1 to 10, it will just loop and loop and loop and change this I variable here. You can say how many steps it should take. For example, 1 is by default, so it takes 1 step, 1, 2, 3, up until 10. You can say 2, and now we'll take 2 steps. There we go. You can even make it go into the negative value, so -2. But this here would cause an infinite loop, so we'll have to go 10 to 1. So it's going to flip the 2. So it's I is going to start at 10 until it reaches 1 or less, and then it will stop. Now as you can see, it goes downwards because we said -2. Cool. So that's a basic for loop. You also have a while loop. So while something is true, we want to do something else. This here is called an infinite loop. Since true here never becomes false, so if I say print Mike, it will forever print out the word Mike until I quit the program with Control-C. So this will infinitely loop until either the program crashes or your PC does. You can use break to break out of a loop, so bloop, it only goes once. Here we could do something like local count is equal to 0. And then if the count is more than 10, then we can break. And of course here at the top we can say count is equal to itself, count plus 1. Cool. So now we will break out of the loop without having to make this here false. So now we can say that, and I will print out Mike 10 times. Cool. You could also do this. Put that there. While count, and instead of more than 10, we can say less than 10. So while count is less than the number 10, run this loop. Now if we run it, until count is at least 10, it will run this code. Alright, and then last but not least is the repeat loop. So one thing I want to show you is, let's say count is equal to 10. If we do this, the while loop will never run because this here is never true. The repeat loops runs at least once. It's a while loop, but it runs at least once. So repeat until, and we can just take this right here, put it here, and then take this and put it here. It's the same as a while loop, but it will run at least once. In other languages, this would be called a do while. And my bad, it goes up until, so we should say up until count is more than 10. Or in this case, let's say 5, just to show you. So until this is true. So it will repeat this until this is true. So unlike with a while loop, it will not be while true, this will be while false. If we run it, we'll get Mike at least once. So we'll run at least once before it quits. User input is relatively easy. Let's say we go here and say print, what is your name? And then the user can input something. So we can say local ans for answer, but you can call this variable whatever you want. And we can say io.read. And this will get input from the user and then store it inside of this variable. Then here we can print ans. We can maybe go name colon, and there we go. If we were to run this Lua file, what is your name? I will say Mike, and there we go, name Mike. Another cool thing you might be interested in knowing is how to get input on the same line as your output. Because sometimes you don't want an output and then an input on the next line. It just kind of looks ugly and sometimes is confusing. To get input on the same line, instead of print, you can use io.write. This is the same as print, but it does not have a new line at the end. So here we can say, enter your name, and it will enter, and it will ask for the input on the same line as this output. Now here we can say Nick, and the name is Nick. And of course then you can do things such as if answer is equal to Nick, and then you can like give special outputs depending on what the user inputs. But I think we all already know that. So if you're coming from another programming language, tables are usually considered lists, arrays, sets, dictionaries, objects, records, queues. A bunch of these things can all fit into the idea of a table. A table can be all of these. If you have no idea what I just said, then you don't have to worry about that. So let's create our first table. I'm going to say local tbl, and if I at any point say list or array, just know I'm referring to a table. And this table will be used with these right here, so these brackets. Anything that goes in here is part of the table. This can contain any types and any amount of items. So this, and we can put a 2 and a 9.9 and a true. All of these, they are allowed. Booleans, numbers, strings, even other tables. So we can go here and say, okay, cool. This is all allowed. If we were to try and print out table, then take note that you might not get what you expect. Usually when you print out something like this, you expect to receive that back. But in this case, we will receive a memory address. But if you want to get the items inside of a table, you could use a for loop. So for I is, oh, that's all caps, for I is equal to 1 to hashtag TBL do. And hashtag is just a short version of number of items in this table. Like if you have a string or a piece of text and you do this hashtag with it, as you might remember, we receive the length of that string. The same concept exists for tables. And in here we can say table and then pass in I. If we do this, we'll get each item inside of the table. A this, 2, 9.9, true, and then another table, because this is a table here. So we'll have to for through that as well if we want to see the items in it. Now you might be wondering, how does this work? How can we do that? Well, if we go look here and we say print TBL at index 1, and this is called an index, and we run it, we'll get this. This right here is the first index. So if we were to go like this, we'll get index 1, which is this, index 2, index 3, index 4, index 5. And the more you add, of course, the more indexes there will be. So it starts from 1, and currently it has up until 5. If we go 5, then we'll get a table. If we say 5, 1, then we'll get OK, because here we're saying, okay, go to this 5th index here. And then in this 5th index, return the item at index 1 of it. So this would be 1. And this here would be index 2 of this table. We'll cover this a little bit more in a second, but this is just as an example. If I were to say 4, we'll get true. If I were to give a value that doesn't exist, like 9, we'll get nil. Nil just means empty, doesn't exist, nothing. Now usually, you'd actually create a table with the same data types. It's not too often that you'll see tables using different data types, unless you use it in a sense of an object, which we'll get to a little bit later. But when you just use it as an array, so a way to store multiple values inside of one variable, then you'll usually just use the same data type, so just numbers or just text. For example, let's say we have local x. Well, let's actually start at A. A, B, C, D, E. And you can imagine this going up until Z. And we could say we're storing 1, 2, 3, 4, 5. Now you might already be seeing how this is not really very practical. Because it's fine to have a bunch of variables lying around that are storing their own values, but all of these values are related in some way. But they're stored in their own variables. Which there's nothing wrong with this method. It's just there's a more comfortable way to do this, where we could go local alpha nums. And this will get all of the alphabetical numbers, which we would have usually done by doing A, and then A is equal to 1, B is equal to 2, C, and whatnot. But here we can create a table with 1, 2, 3, 4, 5. This is the same, but instead of having to use a specific variable, so print A, we have already grouped them together, and we can just say print alpha nums at index 1. This will give us the same value because A and 1 is the same thing. If you wanted, you could also put variables in here. You're not limited to just values, because variables on the end of the day are just values. So this will still work perfectly fine. If I say index 2 where B lies, then we get 2. If I were to remove this, then this will no longer work. So we'll get nil because B has never been defined. Now let's go here and say we have 1, 3, 5, 7, 9. And we can just call this local nums. Then let's say we want to add another value into this table here. Let me just also for each item. So 1 to the amount of nums. And here we can print nums at index I. If we run this, we'll get 1, 3, 5, 7, 9. Now let's say I want to add one thing in here before we run that. We can say table.insert, and this will insert an item into a table. So first we specify the table, in this case nums. Then you can either specify what you want to put in here or where you want to put it in. If you don't specify where, it's just going to put it at the end. So if I say 19 here and I stop here, it will insert 19 at the end. So here, if we run it, we get 19. But if I instead in the middle put 2, then we'll insert 19 at position 2 here. So if I run this, we'll get 119 free. So this here allows you to get a position you want to put it in. Without it, it will just append it to the end of this table. You can of course also remove, and here you pass in the position, not the value, but the position. So if I say 1, 1 will no longer exist. If I say 4, 4 will no longer exist, because 4 was 7. There's also a nice special way you can loop through these tables, which is other than this normal for loop. Instead of using hashtag nums, you can use pairs. So here we go, pairs, and you pass in nums. Now you can get K and V. So for K and in V in pairs num, if we were to print out K, we'll get these values. So 1 to 5. This would be the index. So in this case, we could say index, and V would be value. So index, we can actually just do index and then value, and it will do work the same. So index 1 has 1, index 2 has 3, index 3 has 5. So this is a nice way you can for through a table in case you don't want to for through the numbers. Maybe you want the index as well as the value. Well, you can get both, but in pairs it's split. It's up to you which you prefer doing. Now let's talk about multi-dimensional tables, also known as multi-dimensional arrays. This is a table inside of another table. For example, here we can create another table, 1, 8, 3. Okay, let's create a few more. This can have 4, this can have 7, this can have 5, this can have 2, and then last we can have 6 and 9. Now if we were to print out nums, we'll get our table location in the RAM. If we were to print out num at index 1, we'll get the location of the table in that table. If we specify another value in here, then we'll get the first index of the first item here. If we say 2, we'll get 8. If we change this here to 2, then we'll get 2 because this is index 1 of the first table. This is index 2 of the first table, and this is index 3. So this would be the first table. Now inside of it, you have index 1 of the first table in the first table, or the first item in the first table, and then index 2 and index 3, and then index 3, 2, 1, and then 1, 2, 3. If you were to pass in something like hashtag nums, you'll get the amount of tables in this first table. So if I were to copy this a few times, we'll get 5. But if you specify an index here, for example, 1, you'll get the length of the items here, 3. So this is 3, this is 5. We can add more here, so now it will have a different length. If you want to display all of the values inside of this, then you can also use a for loop. So here you can go for I becomes 1 to the num, or to the amount of tables in nums, and then for this time j, because we can't redeclare I, that won't be a good idea. For j becomes 1 to the amount of items inside of I, because I is a table, so we'll get the amount of items in I. So this would be I, and each item inside of I would be, or each value here would be j. So this is I, this is j. So here we could print nums, so nums, and then at index I, and index I will give us the table. So we specify the next index, which would be j. Now, and my bad, this here is a number. It's not a table. We have to say nums at index I. My bad, because I is a number. Just like j is a number, it's not the actual value. If we run this, as you can see, we get 183, which is the first items. And then we get 426, which is the second. And then 759, which is the last. So if you're having a bit of trouble with this, just note nums at index and in the first index, which we can call x, would be the first item, or the second item, whatever x is here. If you add another one here, it will try and access the item inside of this item. So x, which is this, and we'll try to access y inside of it. So let's say 8. If you have a table inside a table inside a table, you could also add your z. So if I were to have a table here as well, and we can go 2, 4, 5, and we can have a few more, then I could do this, where I have 3 attached to each other to access each item in a table. But take note, tables can become incredibly complex, incredibly fast. So I always recommend to, when you use a table, not add too many items into the table. As in, don't add 3 or 4 tables inside of one table here. So this right here is already very complex. If I were to go here and I were to add another table here, so now I were to add another table of more values, then it will be more complex, because now it's no longer x, y, and z. It has started to go into complexity where x should now be shifted to something else. I'm just going to move this here to the front. And we can just put an A here for now. So I would say always follow the X, Y, Z rule. This is the complexity rule where you don't have more than 3 tables inside of one another. If it becomes more than 3, it becomes very difficult to not only manage, but to work with. So I'd always say try and stick with 3 or less tables. So here there are 3 tables. If you were to remove this like that, then there are 3 tables. So this table here, and this table here. So unless you have specifically named items like an object, which we'll be getting to, then never go past the XYZ complexity in a table. Usually just try and keep it as simple as possible. Then you also have 1, 2, 3, if we were to go like that. Now let's say we want to convert this into a piece of text. Well, we can go print table.concat, and this will basically join a table of all of its elements depending on the separator you give it. For example, if we pass in nums2 or nums and we pass in a space, then it will print it out with just spaces between each item. This here is now a string. Take note, this is a piece of text. And you can replace this with anything, so it can be a semicolon, another number, so dash 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 will work, and so on. And then finally, for named items inside of tables, and we'll get more deeper into this, but for named items you can go local tbl, and here we can do something like name is equal to Mike, and then age is equal to 12. Now if we go tbl at index 1 and we print that, then we get nil. But if we go tbl and then name, we get Mike. So this is a named table. Some people also say it as a dictionary or an object. And yeah, those are the basics of tables. Now, a function is a snippet of code that you can execute as if it was a variable. For example, let's go here and say local function say hello, and this will just print hello. Now we can call this by going say hello and then adding 2 brackets at the end, and this will call this function here, which will print hello. So if we run this, we get hello, and of course we can put as many things in here as we want. As you can see, if we were to go print 1 and then 2 as well, and we were to do this, so print it 2 times by calling hello, then we'll get hello 1 2 hello 1 2. So every time you call this function here, it will execute the code inside of it, and you can call it as many times as you want. This is a great way to stop yourself from having to copy paste, copy paste, copy paste. This is a very common practice where programmers will try and reduce the amount of times they have to copy paste a line of code or even a block of code. Variables can save you a line of code. A function can save you a block of code. Now let's say we wanted to make this hello function a bit more complex. So instead of just saying hello, we want to pass in a name. For example, hello Jack. Well, this here isn't very useful because it will always print out the same name. So instead, what we can do is we can pass in an argument, and we can call it name. So this is like a variable that gets passed into this function. Now instead of saying Jack, we can say dot dot name dot dot. There we go. Now if we go here and we say Luke, by passing it in here between these brackets, and this would be name, we'll get hello Luke. If we change this to Jack, we'll get hello Jack. Sometimes you want to give it a default value. So if you don't pass in a name, you want the name to be a default value. Well, to do that, we can say local name is equal to name or Jack. So what's happening here is we're declaring a new name variable, and then we're basically overwriting what this is going to be on the end of the day. So we're saying this name is equal to itself, or if there's nothing in here, if this is a false value such as nil, then make it Jack. So it will default to Jack. So if we have 3 here, the first has nothing inside of it, the second has Mike, and the third has Sally. Then if we run this, we get hello Jack, hello Mike, hello Sally. Without that there, if we did this, we'd get an error because you cannot concatenate a nil value, because this name here would be nil if we didn't pass in anything in here. Now let's go a bit more complex and do sum. And this will get the sum of 2 things. Let's say we get num1 and num2. Then here we can just return the value. But how does one return a value here? Because we could print out what it is, so print num1 and num1 plus num2. And we could call this sum 10. And just to show you, you could also go local x is equal to 20. You could also pass a variable in here, so x. So it will be 10 plus 20. If we run this, we get 30. But what if we want to work with the value that this returns, that this would give us? So we wanted to store local answer is equal to sum, and then print the answer is, and then ons. What if we wanted to do something like this? Well, we'll get a problem here because we cannot concatenate a nil value. This here is nil because sum just prints out this value here. To return a value, we can use return, and this will return this value. You could either do it like this, or you could go local result is equal to that and then return the result. Now anything here with return will be returned from this function, and nothing after this return will be executed, which we'll explore in a second. If we run this now, we get the answer is 30 because this here now returns this result, which can be either in its own variable or like that. But take note, we can go here and say print func start and in func end. You'll notice we get some red squiggly lines. End of file expected after return. That is because after return, we are not allowed to put anything there anymore. Because after return, nothing will execute. So if we run this, it will just throw us an error because nothing should be after return. Once you return, the function stops executing. But this doesn't limit you as much as you think it would. If we say, let's go here and say local val num1 plus num2. If val is more than 10, then return val. If val is less than 100, then return negative val. Otherwise, we could just return val times 2. So this is just an example where just because we have a return doesn't mean it will stop everything else from executing, because this return will only run if the value is more than 10. And this code here will never really work as expected, so let's make that equal to 10. There we go. So this will only execute if the value is equal to 10. This will only execute if the value is less than 100, but not equal to 10 because this will stop execution first. So if we say 1 plus 2, then that will give us negative 3 because it is less than 100, so it will give us this. If we say 8 plus 2, it will give us 10 because the value is 10. If we were to say here 101, so 101 plus 2, that will give us 206 because it's the value times 2. Let's first try to create a file. That is pretty simple, so let me just also open up my file viewer here so we can see if any files appear. io.output, and here we can pass in a file we want to create. So my file.txt. This will create a file, my file.txt. If I open the containing folder, you'll see there's a my file.txt now. If I were to delete it from here, you'll notice it also deletes it from here. This here is the same as this here. Anyhow, so if we create this file, then that will happen. But take note, it will empty the file if it already exists. So if I go and put some text here, let's actually have it here on the side of the screen, and I decide I want to execute this, as you can see, it empties the file. So you should take note here, it will create the file, but if it already exists, it will empty the file. Now this output can be used also with writing to a file. So io.write. And here you can put some text you want in the file. Hello world. And we just have to io.close whenever we use any of these, because you don't want the file to be open and then later on try to work with it again. Or if another program tries to work with it, but yours already has it open, it will cause issues. So you should always close the file after working with it. Now, if we were to run this, we can actually show this here at the side again. We run it, we get hello world. If we run it again, we'll get the same output because this anyways rewrites this file. It will empty it if there's nothing inside of it, or even if there is something inside of it. Now that's the first way you can write to a file. Now the first way to read from a file, we go io.input this time. So instead of output, we are using input and then the file. So myfile.txt. Then we can of course io.close. And here we can say local file data is equal to io.read, and then we can just say asterisk all. This will read everything inside of this file. And we can of course print file data. We run it, we get hello world. We can add some more like x2, x3, I am cool. If we save that and we run it here, we'll get hello world, x2, x3, I am cool. So we first take the file we want to read and say it's an input file because we want to take input from that file. Then we read it with the asterisk all, which means read everything inside of this file. And we can print the data that we read, and then we can close the file. Or we could close the file and then print the data, whichever you prefer. So that's the first way to read and write a file. Now the second method is what you'll most likely see being used. So let's first try and write to a file. That will be local, and we can say what variable we want to save this file in. So file io.open. The file name, so myfile.txt, and then what you want to do. So here we could specify all of these. So read, write, append, read and write, write and read, I think, append and everything else, read byte, write byte, append byte, and so on and so forth. But we're mainly going to be focusing on these here. So first we'll have write. Now W just means write, so we'll write data to a file. So here we can then say if file is not equal to nil, so if the file we're trying to open exists, then, so if the file we're trying to open can be opened, then we want to go file, write, and we can just say hello there, and that will write to the file. And then of course file, close. Else, if we could not open this file, we could just print could not open the file. Now if we were to run this, we'll get hello there. If we were to delete this file and then run it, it will generate the file and enter hello there. So this method is usually the preferred method above io.output as well as io.input, because we'll learn how to read right now. Now there are multiple ways you can read from a file. One way you can do it is going file and then read, and here we can just specify asterisk all, and this will read everything. So if we go here and say x2, x3, goodbye, and we read it, of course we should maybe print out what we get, so print, then we get hello there, x2, x3, goodbye. You also have asterisk line, which will only read one line. So if we go here, hello there. If we then do it a few times, for each time we do this, it will read a new line. So hello there, x2, x3. So if you want to read line by line, this is a good way to go about it, by using this asterisk line. Otherwise, you can just go asterisk all, and that will read everything. And then last but not least, let's take a look on how to append to a file. Now, when you write to a file, you will overwrite everything that's already inside of the file. So if I were to go here, W, and then say write, and change this to goodbye, then it will overwrite everything. And also doesn't help if you print it. But it will overwrite everything and add our goodbye. But what if we wanted to add something to the end of this file? Then we could use A, which means append. So then we can say appended text. If we run this, we'll get appended text. If you wanted to go to the next line, you could use a \n here, which means new line. Appended text 2. Now it's appended text 2 on the second line. So that's how to append. Now, the term module in Lua refers to a Lua file that returns a single table when it is called. So it returns a table or an array or an object, as some might understand it. So it's basically any file that's not this main file that returns something on the end of the day. And then you also have a package. A package is a collection of modules. So if I say I'm going to go and install a Lua package, that means I'm going to install a few modules that will allow me to make my coding in Lua easier. For example, the Luna CJSON package, because that's a package of modules I am going to use in my program to read JSON. All right, so let's get an example in here. I'm going to create a new Lua file, call it custom.lua. You can call it whatever you want. Then here, I'm going to go and say mod is equal to a table. So I'm saying this is a table here. We can then go here and say function mod.sum, and here we could say x, y, and in return x plus y. So we're putting the sum as part of this mod here. You could also go sum is equal to function and then say x plus y. This is just as valid if we just say return, because these two mean the same thing if we were to put an x and y here. So this would be the same thing. And of course we can have our mod here with, let's maybe say hello. And then here we can maybe get a name. And then we could say print hello name. Now these are just very basic examples. You can put any function you want here. I'm just making very basic functions here as an example to show you. Then we return mod, because this mod will now be used outside of this file. So here in main.lua, we can now use this module. Local mod is equal to require, and then we pass in the name here. So custom.lua, or just custom, because it will automatically add the .lua when searching for it. This will import this module for us and store all of the things being exported inside of this right here, so that variable. We can then go print mod.sum 10.5 or mod.sayhello Mike. If we run now, we get 15 and hello Mike. All of them are made inside of this module here. This is a way to keep one file from going like to 10,000 lines of code, because you could split it up. So one file could have 1,000, another could have 2,000, another could have 500, and it could just make the process of reading this main file much easier, since we're importing the stuff we need from outside. But that's the basics of modules. It's just another file that's returning a table. And this table contains a bunch of functions or variables that we can use here once we import it with require. What exactly is OOP? OOP is object-oriented programming. It is when you think of your code as objects. For example, you have a car, that's an object. A car could have wheels. A car could drive. A car could do this. You have a pet. You could have a cat pet. You could be able to feed your pet. You could be able to give your pet a name, because a pet is just an object. You could have a cup. A cup is just an object that you could fill with water. That's the whole idea behind OOP. Everything in your code is an object. Some people love OOP, some people hate it. I personally love OOP when doing game development, but prefer using procedural programming, basically what we've been doing up until now, with normal programs. Now in Lua, there are multiple ways to do OOP. There's not just one, not just two, there's more. I'm going to show you one way to do it, but if you don't like this method, you could go and search for a different method that you might like more. There's one that uses meta tables, but I find that method to be very confusing to understand and a bit difficult to use. So instead, I like to use functions and simulate OOP with them. And I'll show you an example. Let's create an object, local function pet. This is your pet. Now your pet could be a dog or a cat, but this is a pet. It is what you use when you go, Charlie, come here, I have a treat for you. You're calling your pet. And we will return a table, because a table is the best way to get an object. If you maybe come from Python or from JavaScript, then dictionaries or objects, it would be the same concept. And here we could do something like name is equal to Charlie. Then here we could go and say local pet, or even cat, is equal to pet. And then we could print cat.name. Anything inside of this return is public and can be used with this object. Now if we were to run this, we get Charlie, because this is just a table. But we disguise it as a function, which generates an object for us. This is nice because now I could have two pets, one that's a dog. And now I could go dog.name. Both of them will be Charlie, so this pet is a bit flawed. Let's allow us to change the name. So name. We'd say name is equal to name or Charlie. So if they don't enter a name, it will default to Charlie. Here we could say Jack. So my pet is called Jack. Now my cat is Charlie, my dog is Jack. On the end of the day, these are just a bunch of tables. But we can create or generate tables for us by calling functions. So that's pretty neat. Now take note, if something is not in this return, it won't be returned for us to use. So if I go age is equal to 10, I cannot use this age here. I could use it here, so I could go days alive is equal to age times 365. There we go. Now here, I can't go cat age and then dog days alive. Only dog will return a value because age is not returned. Only the things in returned is returned. Also, we can just go local here. So if I were to run this, we'll get nil and 3650. That is because age is not returned, so we don't know what it is. This can be seen as a private property of your object. So something you can use only in your object and it cannot be used outside of it. And this here could be seen as a public property that can be used and called outside of this object. You then also have two types of functions. You have the speak, and this function is just a normal function. And we can just say print, and let's just go meow. Even if it's a dog, let's just say it meows. Then you also have another function, which we could call feed. So if you want to feed this pet, that can be a function that takes in self, and we'll discuss it in a second. And for now, right now, we don't have to do anything here. We can just say print. Okay, so here we have a basic class with two types of functions. This first function here can be called with this dot syntax, so speak. And it doesn't return anything, so we don't have to print it. But you take note, this second function, so we go feed here, will not work because it takes in self. And self is what you use to specify this object. This right here. This is the self. It is this table. Self is referring to this table. It's referring to itself. But this won't work. So if we run this, we'll get meow and eating. But we go self dot name and we try and run it now, we'll get an error because self is a nil value. So once we want to use self here, which allows us to reference anything inside of this table, we cannot use this dot syntax anymore. We have to use colon. Colon basically passes dog into itself in a sense. So this first value here is going to be this here. So if we go here and we run this, we get eating and then Jack. So these are the two functions you'll usually get. I usually just say make all of them include self, even if you're not using self, because then all of your functions will require a colon and you'll never have to wonder, is this function not working because it needs a dot or a colon? It will always need a colon. So I always say include self even if you're not using self. And in self here can be used to access any value inside of this right here. So I can go self speak. And now we can speak. We run this, we get meow eating Jack and then meow. That is the basics of these types of functions. But usually just stick with self and you won't have to memorize what the other does. Now let's say you want a type of pet that isn't in its own a pet. Or it is a pet object, but it's more specific than that. This is called inheritance. So let's say I want another type of object. So local function dog, right? Dog takes a name. But now we go return. And we're like, okay, I want all of these inside of dog as well. So we copy, we paste. We now have all of the same things. But now we want to add a few new things. We want to add breed, which is equal to Doberman. And we have loyalty because dogs can be very loyal. And we'll make that equal to 0. So now we have a dog that has all the same items as this pet object here. And we can go local Doberman is equal to dog Jesse. And now we can say Doberman dot breed. And now we can get the breed of this Doberman. And let's, while we're at it, get Doberman dot name. If we now run this, we'll get Jesse, which is a Doberman. Cool. But now we decide here inside of our pet, we want to add another item. We want to add status. And status will be something like hungry. Now, since we want dog to have everything pet has, we now have to remember, and this could be like a ton of objects that could have the same types of items in pet. But now we have to remember, we have to copy this and we have to go paste it here as well. We have to remember that. And a lot of times you'll have 5 or even more objects that will be inheriting from this object. So it will have all of the same items. So you will have to remember all of the objects that's using this object so you can go and copy paste all of these here. This isn't the way to go. Instead, you should use inheritance. Inheritance is when you inherit all of the different types of properties in one object and you use it in another. So here we could say local dog is equal to pet, and we pass in this name that gets passed into dog. Cool. Now we return dog. And then instead of creating this object here, we can now just append to this already existing one. So dog dot breed, and we can make that equal to this right here. Dog, and then dot loyalty, like that. And then we can remove this part here. And now we have successfully inherited all of the properties that's being returned here. So we get name, we get status, we get speak, and we get feed. We get all of these here. And now we add 2 more properties onto this property we have, or onto this table we get from this, and return that. Now we'll have both the name and the breed, even though we didn't copy paste any of these here. If we run this, we'll get the same output. And once we change anything here, so anything here, for example, we can add points for some reason and make that equal to 10. I can now, in my dog, I can access points, even though I didn't actually copy paste that data here. We can now also go breed, and we could rather pass in the breed, or Doberman. So now we could actually go here and say poodle. So now we get a poodle instead. If we run this, we get Jesse Poodle. We can overwrite functions that already exist here as well. For here, we say meow. We could go dog.speak, and speak is a function that takes in self. And then instead of saying meow, it says woof. So now when we go poodle speak, it will say woof. This is the power of inheritance. So we can have a bunch of objects that's inheriting from this object. So now we can maybe go here and we can create a cat, which has the same types, but this time it maybe doesn't have a breed because I don't know any cat breeds. It doesn't have loyalty, doesn't have speak, and here say cat, and we can go here and say lazy, and that could be cat.lazy is equal to true. So if the cat is lazy or not. Now this cat has all of the items inside of pet and one more that's lazy. And of course, if you wanted to, you could make cat inherit everything from dog. You just of course have to pass in the breed, which I don't know, IDK. And now cat has all of the items inside of dog and the pet, because dog has everything inside of pet. So cat now has everything inside of pet and dog, because cat is inheriting from dog here. And this is the basics of OOP. You might not quite understand everything here yet, but once we get to the game development section of this course, then you'll quickly start to understand the power of object-oriented programming and how everything here connects with one another. And hello everyone, if you're enjoying this tutorial, please leave a like and subscribe for future tutorials. And hello everyone, welcome back to another tutorial. So in this tutorial, we'll be looking into Love2D. Love2D is basically a framework that you can use to make 2D games in Lua. Now first of all, you need to install Love2D. If you are on Windows, then you can just go and get the installer. If you're on Mac, you can get the zip. And if you're on Ubuntu or Linux, you can just get one of these. Since I am on Arch, I can just do this. I'm going to go to terminal, new terminal, and just pacman-s love. And you just need to sudo that. And that will install Love2D for me. So yeah, as you can see, it's already installed and up to date. So I'm not going to install it, but if you're on Arch, that's how you would install it. Cool, then once you have it installed, then you can just say love, and that should pop up something similar to this. You might not have this exactly same thing here. It highly depends. I have Love version 11.3. If you have a lower or a higher version of Love, you will see something different. I do recommend having the same version of Love as I do, or at least a higher version, because a lot of the features may not exactly work on later or newer versions of Love. So I'd recommend having 11.3, the same as mine. If you ever wonder about anything or whatnot, you can just go to the Love2D website, so love2d.org, and you can click on this wiki here. This wiki will basically give you all you need to know about love. We won't be covering every single thing here, but we will be covering quite a lot of this. For example, let's go to let's go to sound. Let's say you want to play some sound, which we will cover in a later video. As you can see, you have a bunch of things here you can use to work with sound. Let's say we want to go to a window, then here we have a bunch of things you can do with the window. So yeah, there's a bunch of things you can do here. I'm only going to show you the most basic, and we will be building 2 games at the end, just so you have a good idea of what we'll be working with. Okay, now I think we're ready. Let's get started. So first we need to just move this to the right, because I don't like it if it's at the bottom. I do love it if it's at the right side. Now first, let's create a new file. I'm going to call this main.lua. You need to have at least one main.lua file here in order for Love to be able to execute. Otherwise, Love may not know which file to execute. So here it's main.lua, and now I'm just going to close that so we have more space. So we're still inside that file. Now take note, I have a terminal open, but if you're on Windows, I do believe you can just double click that main.lua file and that should run Love2D, but I'm not sure. If you're on Windows, I would actually recommend opening up the command line, same on Mac, opening up the command line and just saying love dot in that directory, because as you can see, I'm in this directory right here. So if I were to just, let's say, open up my folder here, so funner dot, as you can see, there's main.lua. I'm in this folder right here. Now, first thing we need to do is we need to set up a basic project. So to do that, we need to go _g and make sure you do have Love2D installed, otherwise this might not work. .love. This means make this a global variable with the name of love, and we're going to require the module called love. So basically this is normal Lua. We're just importing a module called love. Then next up, we need to create 3 functions. These 3 functions are the basic concepts of running a game. So first we have a function called love. It needs to have love at the start here. Love.load. This is very important. I'm going to be explaining all of this in a second. We can just ignore this for now. I'm going to copy this and I'm going to paste them 2 more times. And I'm going to close that. Then this we can make love.update, and update will take in DT, and I'll explain that in a second. And here we can say love.draw. Okay. So let's explain what these are. Now in every game, you have 3 stages. You have the load, the update, and the drawing stage. Love2D makes this incredibly simple to do the loading, the update, and drawing in the respective functions. One of the reasons I do love Love is because of this right here. Because it's languages like Java, for example, you'll have to actually go through and make these functions yourself and let them work in the background as they should, where Love2D has already configured a lot of this for you. So first, loading is to basically load in data when the application starts up. So when we boot up the game, this will load all of the data we need. So we need to put things in here that we want to load. Then here, with update, this basically runs once every 60 frames. This should run once every 60 frames. So this is 60 frames per second. Love2D is kind of locked to 60 frames per second. It can go lower if the game requires a lot of resources. But it's kind of locked to 60 frames per second. So once you start this up, you'll get 60 frames a second. DT is basically delta time. It's the time between this frame and the last. Currently, you don't have to worry too much about this. It's mostly just math, so don't worry too much about DT. We'll get deeper into that later. But basically, this is every frame. Imagine that. It's a frame. So you have 60 frames a second. This will be every frame. It's the time between this frame and the last. Love.draw. Oh wait, and we're still here. And this will just also update everything. So let's say we have a player. If we want the player to move, the player will be moved inside of this update function here. So this will move the player. Then we have draw, and this will draw everything to the screen. So first we move the player, and then we draw the player at its new location. Or we the player gets hit, and then we update a heart getting destroyed in the game. That's what we draw then. Basically, that's how it works. We'll get deeper into these things as the tutorials go on, but for right now, it's not too important, but we will get to it. So let's start off with just creating a basic hello world. So we're just going to skip these two for now. We don't have to worry about them. And here we can say love. And you'll notice most of love's important functions start with love. Got graphics. Graphics is what we use to draw something to the screen. So we use graphics. Dot print, and this will just basically print to the screen. It's very simple. It doesn't do too much. And we can just print hello world. Alright. Now if we were to say love and then dot, this means run love in this folder. And it will find that main file and it will run it. You'll see this, but then you'll also see this little pop-up right here. Just saying hello world. There's a little icon, there's some text which we can change later, and here's like the basic functionality you'll have. And yeah, that's the basics. We have created our first application, although it just displays hello world, it's a first game. Now let's do something a bit more intense than just printing something to the screen. Just so I can show you the difference between load, update, and draw. So here, let's create a variable called number. We'll make that equal to 0. Take note, this is a global variable. You can either do it like this, or you can say _g dot number. So that this will load in this number when the game starts. It needs to be global because we need to access it between the other functions. Then this update right here, we need to update that number. So with every frame, we want to update this number. So we can say number, because we're accessing this number right here. If you don't know Lua, I do recommend you go watch that tutorial I made. And we can say number plus 1. This will take this number and it will just add 1 to it. Then here, where we do this, we can just display number. So I'll explain what this does more in a second. Let's quickly run it and see what we get. So right here you see a little number constantly increasing. That is this number right here. So let's just move this to the side. First we set the number. So when the game loads, we set the number to 0. So once this boots up, this will be 0. Then every time, with every frame, this number updates. So this number increases with 1 with every frame. And in this draw right here, this will print the number to the screen. So as you can see, we first set the number, and this only runs once. This load, that only runs once. This update, however, and this draw runs every 60 or every frame. So these two runs every frame. And this prints it every frame. So in this tutorial, we'll be covering the Love2D configuration file. Now this configuration file is basically a file that allows us to configure our application more, to maybe get certain permissions or to add certain features to the application. So let's get started. So we just have a very basic application here. What goes on in here doesn't matter too much because we won't be using this a lot. So first thing we need to do is we need to create this configuration file. So you can just right click, new file, or you can open that folder it is in. For example, as you can see here, there's my main.lua file. Just create a new file and we can call it conf.lua. Like that. And now we have a configuration file. And inside of this configuration file, we can put a function. So function and then love.conf. And inside of it, we can just put t. So t is basically a variable that's going to be passed in for us that will basically contain a bunch of information and stuff we can use. And then of course, this is just for love. And then here we basically say we want to manage the configuration for our application. So there's a lot of things here. For example, t.identity. And we can just make that equal to nil for now. This will allow us to assign a save file. I'm just going to also do this for now. So this will allow us to assign a save file. We can insert the path to that save directory. For example, saves, or let's say data/saves. Like that. And in here we can just create a new folder called data, and instead of that saves. Now we have a folder with the name data, and inside of that folder named save. And there we can see that's the path to it. So that's just basically the saves directory. Not too much there. The next up we have, and of course you can add multiple things here, so I can continue underneath this if I wanted to. T.version. So this is pretty much the version that this game supports of Love. So if I am developing this game using Love version 11, then I can define that Love version 11 should be used. Otherwise, I could specify use Love version 1 or Love version 10. This here is pretty much to specify what version of Love you want this application to run with. Then we also have t.console, and this is basically if a console should be attached to the game, and there should be a true or false value. So false means, which is it by default, there shouldn't be a console attached to the game. This is Windows only, take note of that. If you're on Linux or Mac, this won't really affect anything. But if you're on Windows, you might notice sometimes that there's like a little black box, this command line or CMD that pops up when you open up an application. That's the console. So if this is true, this means that the console should be running in the background, and it will basically be attached to this window. So once you close the window, the console will close as well. Windows only though, so take note of that. Next up, let's say you want to save the files but on an external storage. Like you want to save the files but on an SD card, for example. Then we can say t.external storage, all lowercase and false, or this should be true then. This means you want to save the files, but you want to do it on the SD card and not on the normal phone storage. And I do believe this is Android only, so take note of that. I think this is Android only, so you should also take into consideration about this. You also have t.gamma correct is equal to true. Now this will basically, in a sense, if the system supports it, it will enable gamma correct rendering. I have no idea what that is, but if the system supports it, it will do that. It will probably just enable better gamma or whatever. I think gamma is like lighting or things like that. Let me Google that. Yes, so it is the overall brightness of something. So the more bright it is, the higher the gamma, I guess. And yeah, it's something like that. I don't usually work too much with that. I usually just do the basics in the configuration files. I won't go for gamma correct unless someone specifically like gives an issue about the gamma being wrong or something like that. Then I would enter that. But usually I don't care too much about that. Okay. Next, let's say you play like an online game. And let's say it's like a game like PUBG. On PUBG, you have the option to click a button and then it will hear your voice speak. So you can speak to people on PUBG by clicking the microphone button. We can enable that as well. Now, on Android, we need to basically get a prompt that allows us to hear the user's voice, because you may have noticed if you want to talk to someone on PUBG, the first time you click on that button, it will pop up a prompt asking you if it can use your microphone. That's what we're going to do here. So t.audio.mic equal true. So if it's on Android and you want to enable microphone, then this will basically give them a little pop-up asking, hey, can I use the mic? Cool. Now let's actually configure something we'll be able to see, such as t.window.title. And that should be window. Okay. and we can just make that equal to whatever title we want. For example, cool ball game. Now if we were to love this, we'll get this right here, which says cool ball game. So that's this part right there. So that would be the t.window.title. We also have things like the window icon. You'll notice I have a little folder here with an icon inside of it. It's called gameicon.jpg. Usually you want to save these as ICO because that's an icon file, but I used a .jpg just because. So here I can just specify icon slash game icon.jpg. Now if I were to run that, then you'll notice I have a little icon here now. And that's this icon we got right here. It's a very dark icon. I should have picked something a bit lighter, but as you can see there's a little icon there. So that's to change the icon. If you wanted to do that, then you can by doing this. And you can see it's an icon and then game icon. Take note, this path is kind of relative at the moment, because as you can see here, if I were to move my conf file outside of this folder right here, so if icon was in a different folder, it would not find this icon here. So keep note that the location of where the conf is and where the icon is, that's very important. But we're not going to go too deep into that. That's something completely different you usually have to worry about. You can also set the window width. For example, if we were to do this, and we can also set a height, so let's go like this, and you can say, whoa, go away, width, and here we say height, and then all we need to do is specify the width and the height. For example, let's say the width should be 400 and the height should be 200, which is a very weird aspect ratio, but there you go. So the width is now 400, I believe, pixels, and the height is now 200, I believe, pixels. You can of course make this as big as you want. For example, 1200 by 700, which is almost a 16:9 aspect ratio, as you can see that right there. So now it's a lot bigger. So it just depends how you prefer it. You'll also notice that if I were to just do go here again, that if I want to resize it, I can. So I can't resize it. So even if I wanted to, it just moves it. It doesn't resize it. And this is by default like this because usually you don't want games to just be resized, because that could break the game. But if you do want this to be allowed for your users, you can say t.window.resizable is equal to true. Now the window can be resized. So if I were to bring it over here, now I were to go here, then I can resize the window. So by default it is disabled, and for a good reason. As I say, you usually do not want to enable this because that could cause the game to break. You'll notice in more popular games as well, you can't resize the window because it's dangerous to resize the window. You can also give it a minimum width and a minimum height, which could be better if you have this resizable on. For example, if I can just copy this, and in here, instead of just saying width and height, we can just say min, and I'm going to copy that width there and just paste it here. So now I can set like the minimum width and height it's allowed to be. For example, let's say the minimum height it's allowed to be is 500, whoa, and the minimum width it's allowed to be is, let's say, 1000. Now, even though it's resizable true, it can only be resized to a specific size. So here, if I were to resize it, as you can see, after a while, it doesn't allow me to resize anymore. But I can make it bigger, but I can't make it smaller. So it has like a minimum size it can be resized to if you want to enable the resizable. But as I said before, rather not. You can also remove a window border by saying t.window.borderless is equal to true. This will remove the window border, which I don't always recommend, but it's a good option if you want to allow your users to have that. Okay, so as you can see, it doesn't have anything up here. This should be optional if you want to put it in. You shouldn't force this onto the user because not all users like this. You'll notice with most games you have an option to remove the borders, and there's a good reason why there's an option to remove it. And usually by default it's not removed unless it's by default full screen. You can also enable VSync, so VSync, and this you should specify with a number. I don't quite know what this number means, but you should specify with a number if you want it enabled. And here it is now VSync enable. If you don't know what it is, I think it's vertical sync, and it's to sync sound and the video, but it should be optional because yet again not everyone will benefit from VSync, because it's by default it is aligned as it should be, but usually you don't worry too much about it. Okay, so that should also be optional for the user to change. You shouldn't force it on them again. And here is something that could possibly solve my problems. Display. Tell it on what display to appear. For example, if I say display 1, it might actually, nope, it displays on that one. If I say display 2, which is not my main display, then it does appear here. So now what we can do is, instead of me having to continuously drag it over to show you, I can now go here and I can make full screen. I actually didn't know this display was here. I just realized that it exists. Interesting. As you can see, it's full screen, and I didn't actually think this through because, you know, I can't really exit. But yeah, so that's if you wanted full screen. And I'm going to keep that there because that's actually very useful. I wish I knew that existed much sooner. You can also specify the X and the Y coordinates. So if we were to copy this and go here, then we can like say X, and let's make this 200. I don't know if this is now going to go back to this screen because the displays are kind of linked. Okay, so no, it's here. So the X is now 200, as you can see right there. If I were to make that less, so let's say 100, then it's 100 from the side here. So yeah. Then we also have Y. And let's make this 100 as well. So you can see 100, 100. That's very useful if you want it to be at a specific location, but yet again, you might just want this if you want to save where the user last had the application when they closed it. That could be a good feature, but forcing a location, yet again, not always a good idea, because that location may not exist on the user's monitor, because let's say their monitor is smaller than yours, and you set it to specify be on 500, 500. They might not have a screen, which is very rare, but they might not have a screen that size. So yeah, just keep that as note. This should usually be an optional thing you add. Alright, so next up is something I do not recommend you play around with. It's good to know it exists, but you should not be playing around with this. Unless you know what you're doing, but usually you do not want to play around with it. You can disable and enable modules. By default, all modules are enabled in Love2D, but you can disable them if you don't want them. For example, t.modules and let's say timer is equal to false. By default, this would actually be true because the timer is enabled. Now, this timer right here provides this dt here, which is the time between this frame and the last frame. So if we remove that module dt, so if we make number here dt, and then print that value, dt would be 0. So right there, and I've accidentally removed my one thing I liked. So as you can see there, it's 0. But if we were to, yet again, just remove that from there, and actually let's bring back our window display. I did kind of like that. So if we were to remove that disabling module, then as you can see, dt is a number. So just take note, you can disable modules, which I guess would probably decrease the application size or something. I don't know what it will really benefit in doing, but you can do it if you want to do it. So just take note of that. So usually don't disable anything. That's a good rule of thumb. If you know you're not using something and you know you're not going to use it, then I guess disable it. But usually you don't want to disable anything. Now, if you might have fallen behind or you want to maybe remember some of this, you can always find it here on the Love2D website. So for most part, we're not going to use load or update here. We're mostly just going to use draw. So we can just focus on that. Let's try and draw a rectangle in Lua, which is pretty simple. So it's just love.graphics.rectangle. And here we can specify the type it should be. So you have different ones like line and fill. We'll cover both of these in a second. So let's just say fill for now. And then we can specify the location, and I'm going to explain all of this in a second as well. Now if we were to run this, you'll notice we have a little white square here. And yeah, so let's go look here. What is all of this? First we have the type, fill. So as you can see here, this is like an entire box just white. But if we were to make this, instead of fill, we were to make this line, then now we'll have a outline instead of having a fully filled white square. Then we have our X position, which is 50. So this is the X position. And then our Y position, which is 50. And this is like that. You can remember which one is X and Y by remembering that X is going horizontally and Y is going vertically. And as you know, Y, if we were to put a Y here, it has a thing that goes downwards. So this would kind of represent a Y shape. And that allows you to remember that this section here, up to down, that's Y. So this point right there would be 0Y and 0X. Here would be 50X but 0Y, and here would be 50X, 50Y, and here would be 50Y, 0X. We'll explore this a little bit more in a second. And then here we have the width and the height. So if we were to make this 100, then now the width would 100. So as you can see here, 100. Let's change the X. So let's make this 10 instead. Like that. Now if we were to run this, you'll notice it's only 10 pixels from the side here. As you can see. And then here's the Y. Let's increase the Y. So let's say 500. I don't know if that's actually still on the screen. It is. There we go. So there's 500 pixels. So yeah, that's the basics of just drawing a rectangle. You have your X, you have your Y, you have your width, and you have your height. So you can of course make the height something bigger. So if you wanted to make it a little bit larger, you could. You see there. Now, as I said before, if we were to make this 0 and then run it again, you'll notice that now it's here because the X-axis, if we go back here, is 0. So it's right there. It's against the wall because it's 0. If we were to make this right here 0 and let's say this 10, let's just close this. Then now, as you can see, it's here at the top because that's the Y index of 0, as you can see. Because remember, Y is going down like that. It has like this little Y symbol. I'll see if I can try and edit that in. And of course, if we were to make it 0, 0, then it would be against the wall. As you can see here, 0x, 0y, so it's against the wall. Now, before we continue to, let's say, something different, let's try and change the color. Because currently we only have white. What if we wanted to make it a different color? We can do that by saying love.graphics.setColor, and we can make it, let's say, 100, which would be red, and I'll explain why in a second. So if we were to boot this up, you'll notice a red square now, and not a white square. So this right here uses RGB values. Now, RGB, if you don't know, stands for red, green, blue. And here below we have between 0 and 1. So 0.5 would be fine, for example. So 0.5, that would be halfway. So 0, 0, 0, so if this was all 0, this would be black. Because that means there's no red, there's no green, and there's no blue. it's only black, so none of those colors exist. Whereas if we were to make this 1, 1, 1, then this would mean white, because that means all of the red, all of the green, and all of the blue is in here. Now usually you don't really want to figure out colors like this. Oftentimes you'd want to go to your browser and search up color picker. And you'll find something like this. So let's say we wanted a nice greenish color, so let's go here. And then we go like this. Cool. And you'll notice here we have RGB. We can copy that. And now here, what we can do is we can paste it here. And we can say, divided by 255. And if you do this, then we'll get this greenish color. As you can see right there. We divide it by 255 because by default, usually it's actually 255. So it's a number between 0 and 255. But in Lua, it's a number between 0 and 1. So if we divide it like this, we'll get a value with it. So if we go like this, then we can just say 75 divided by 255. And that gives us 0.29411. So we could have done this, 0.29411. But first of all, this is kind of difficult to read because you can't really tell how much that is. Some people this is pretty simple, but to me it looks a lot more than what it really is. And that's why I just prefer this. So you can choose between using this or this. It will give you the same output. So if we were to run this, we'll still get that same green. If we can just get love to run. As you see there, we get the same green. So yeah. But what if we wanted to make this black? So 0, 0, 0. You'll notice the background is the same color. So if we wanted to make this the same color as the background is now, we wouldn't be able to see it. So how does one change the background color? Well, it's pretty simple. Now you can either do it here, or you can do it on the onload. So you can change it on the onload, or you can change it on the draw. If you change it here, it's going to do that change every time or every frame. It's going to make that background color the color you set it to every time you call this, every time draw is called. So that's every frame. If you do it on onload, it will do it once, and that's only when it loads up. So for extra performance sake, I would recommend doing it here unless it's part of the game to change the background color. Anyways, we can say love.graphics.set background color, and here we have the same option. So I'm just going to say 0.5, 0.5, and let's maybe say 1. And now if you were to run this, you'll get this purplish color, and then with the black box right there. So that's how I can change the background color. Now let's get back to the actual topic of the video. Let's draw another shape. Let's try and draw a circle this time. So let's go love.graphics.circle. As simple as that. I'm going to make the circle line and not fill, but you can make it fill if that's what you want. I'm going to position it at 100, 100, and I'm going to make the size 50. Now take note, this is the radius, so it's not a width and a height, it's a radius. Meaning it's going to be 50 pixels to the left and 50 pixels to the right, 50 pixels to the top, 50 pixels to the bottom. So it's going to be a pretty big circle, as you can see right there. We can actually move it out a bit more. So let's maybe go 200 or 200. That's on the X, and let's make it 500 on the Y. Now if we're done this, as you can see, we get this. So it's a nice circle and whatnot. Now what if we wanted to change the color of this circle? Because we've already set the color, have we not? Well, it's pretty simple. We just copy that line of code and paste it here again. Now we can give it a different color. So let's say 1, 0.7 and 0.1. There we go. Now from this, we get this yellowish color. That's kind of difficult to see, but it is there. So if you want to change the color, you just basically set it here. But take note, this is important that these colors stay the same, because with every frame, it's going to call that again. So if we do this right now, everything's going to be this yellowish color, as you can see. because I commented out this part. So when this code runs again, because it's going to set the color, and then when it runs again, it's going to not set the color again, or it is going to set it again, but here it doesn't change the color back. It just draws, and then it sets the color, but it's already this color, and then it goes here, and it does it again and again. Where with this, every time this runs, it changes the color back to this. This is something that's very important, and you'll notice when we build the games that this does come in handy to know how this works. I do recommend you play with this, because you'll notice if you comment something out, then this might not work. If you maybe move this to a different location, it might not work. So if we put this set color there, it won't work, as you can see there, because the color is set here. But then we come here and we change the color. Then these two execute, and then we set the color to this. And nothing is redrawn after that. If we were to comment this out, then now everything would be yellow again, even though it's at the end, as you can see there. Very good to note that. So let's draw one more shape, and then I want to show you how to just make something move. So here we can maybe draw an arc. I'm going to make it a line once again, and let's say we need X position and Y position. We can maybe keep this, but maybe make this 250. And then here we need an angle 1 and an angle 2. So I'm going to make 0 and 2. And you'll see what happened in a second. My bad, I forgot to add the radius, because we also need a radius. I'm not going to make it that big. Let's make it 20. And now if we're to do this, as you can see, we have a little thing there. Actually, let's make it a bit bigger, because it is kind of small. So let's go maybe 60. I'm pretty sure that, ooh, not 600. 60 should be good enough. As you can see here, we have like a little cheese shape here. Now let's see what happens if we change one of the arcs to, let's say instead of 2, we make it 5. What will happen? As you can see, we get a little Pac-Man. That's pretty cool. You can maybe make a Pac-Man game with this, because it already draws the arc for you. All you need to do is make this change. So let's see, what if we make this 2? What will happen now? Because what does this arc really do? As you can see, it kind of changes where this and that starts and ends. What if we made both of these 5? What will happen then? Nothing. Because now both of them start and end at the same place. If we were to make this 0, and let's make this 5 again, you'll notice this. So if we wanted to make a Pac-Man, we might want to go 1, 6. I'm pretty sure that should be relatively close to Pac-Man. Relatively close, not quite on it, so let's maybe make this 0 again. And as you can see here, we have a little version of Pac-Man. We might want to make the mouth a bit bigger, so maybe we make that 5 and make that 1. As you can see there, now we have a Pac-Man. You can play around with this. This is mostly just kind of playing around to figure out what you want. So you basically give it X, the Y, the radius, and remember the radius is basically from middle to the outer ball. So it's from here to there. That's 60 pixels, that part right there. And that till there, that's also 60 pixels. Now let's try and move Pac-Man. So you'll notice here we have Pac-Man. Let's try and move Pac-Man here forward, because that's what Pac-Man would usually do. It will move forward to eat maybe that little square there. So we can even put that in front of Pac-Man so we can eat it. So let's see here. Let's make this x-axis 600 and 200. I'm pretty sure that should give us what we want. If we go here, you'll notice there's a square for him to eat. If we were to just make it a little bit smaller, so maybe instead of 600, or maybe instead of 100, I mean, we can go to 70 and 70 and run it. So let's see. That's a nice square for it to eat. Okay, now let's make Pac-Man move. So here, I'm going to create a little variable, just a table, basic Lua. So we can say Pac-Man, and we can make Pac-Man equal to nothing. You could, of course, go _g.pacman. That will also make it a global, but it's optional. Both of these are considered global. I'm going to do the _g pacman. I'm going to say pacman dot x is equal to let's say, let's give these x and y values here. So let's say 200, and then pacman.y is equal to 250. Okay, now we have pacman's two locations. So this is basically the same as saying x and then 200 and y and then 250, and that should be an equal symbol. It's basically the same as saying that. We just split it up into multiple lines, so it's optional if you want to do that. I like splitting it up into multiple lines like this. And in here we can just specify the pacman x and pacman y. So now pacman x and then pacman y. Now if we were to run this, everything should still look the same, as you can see there. And let's fill pacman. So let's fill pacman. As you can see now, pacman is nicely filled. Now let's move pacman. So here in update, we can say pacman.x plus equals 1. Let's do that and see what happens. Although that might be a little bit too fast. So let's maybe, and I think this should also be equals pacman.x plus, and then how many. This might be a little fast, we might need to slow it a bit, but let's see. No, it isn't. So as you can see, pacman now moves until it eats this right here. Cool. Now let's make the square disappear once pacman has eaten it. So I'm going to go here and make pacman.eat equal to false. Cool. Now what I'm going to do is I'm going to go here and say _g dot food. I'm just going to say x. I'm not going to create an entire table just for food. I'm going to make it equal to 600. There we go. Now here I'm just going to paste food x here. And now I can say if pacman.x is more equal to food x, and let's maybe add a little bit just so pacman can move a tiny bit before it actually disappears. So make it maybe 20 pixels. So if pacman x is more equal to this value here, then we want to say pacman.eat is equal to true. And then here we can say if not pacman.eat. And still, this is basic Lua. If you do not know what I'm talking about here, you should go watch my tutorial on it. But I'll explain it anyways. So let's first see what happens before I explain it. So here we have a little pacman that's now moving, trying to eat this little square here. Once it gets to it, boop, it disappears because pacman just ate the square. What did we do in this small game program we made? So first we set the color of the background, which doesn't necessarily need to be this. Then we created a pacman table, and that pacman table contained the x of pacman, the y of pacman, and if pacman has eaten. The y in this case isn't that important because we didn't change it. The eat is important because if pacman has eaten, meaning if he has eaten that pallet, that will basically make us not draw it, because if this is true, then this will not execute, because not means if this is not true, then execute. Otherwise, if this was false, it would be if this is not false. As you can see, doesn't work that good. But you could also have swapped it around and say true, and then here you can make false, and then here you could just say if pacman.eat. Or you could have actually given it to this food variable here instead. So instead of doing that, we can just say underscore food eaten, and we could have made this false, and then we could have made food eaten equal to true here. And now if we were to, now we can just say food eaten. This will also work perfectly fine. So yeah, that's the basics of that whole part there. If we run this, you'll notice it still works. Yeah, my bad. And just turns out, because there's a global variable, it doesn't really know that too well. We might, so it thinks we're reassigning or we're kind of creating a new variable, so I'm just going to put underscore g here so it knows we're talking about this variable right here. And this should be not, my bad. Because if it's not eaten, if the food is not eaten, we want to draw that food. So that's what we're doing. So if it's not eaten, we want to draw it. But as soon as it is becoming eaten, then we don't want to draw it because it has been ate or eaten. I don't know how to do that in the previous tense or in past tense. Very weird. And here we just move Pac-Man. Here we check if Pac-Man has accessed that food palette. And in here, we just say if it should be drawn. And in here, we draw Pac-Man. So just Pac-Man. Pac-Man moves, and Pac-Man is about to eat this palette here. Pop, as you can see. But it's a very boring game because we're not doing anything. So why don't we move Pac-Man? Now I'm just going to delete that, and here I'm going to go underscore g dot food, and I'm going to make that equal to an object, and then I'm going to say food dot x, and in here I'm going to say food dot eaten, and now these two are both objects. But just to show you that both of these methods work, let's actually go x is equal to 600 and eaten is equal to false. You can do it like this as well. There's nothing wrong with that. Now here we can say food dot eaten, and here we can also say food dot eaten. The game should still work perfectly fine, and here we should also just say, and here as well, so both of these two places, food.x. Now the game should still work perfectly fine if you run it. If Pac-Man reaches the food palette right here, it should pop, disappear. Let's see. It does. Cool. Now, why didn't we try and move Pac-Man ourselves? Because currently we're just moving it with every update, which is kind of boring. So let's try and move it ourselves. So first, I would like to be able to tell Pac-Man when to move forward. Now, usually Pac-Man would move forward on his own, but I would like to move Pac-Man forward only when I tell Pac-Man to move forward. So let's do that. So here I'm going to say if love dot keyboard dot is down, and I'm going to say the letter A. Then I want to basically move Pac-Man backwards. So Pac-Man, not package, Pac-Man dot x is equal to Pac-Man, Pac-Man dot x minus 1. And that should be dot x. Now I'm going to comment this out just so that doesn't, or let's actually delete it, we don't need it. Now basically we're saying if the A key is pressed, because if it is down, so if it is being held in as down, do this. That's what we're saying. So if the keyboard key is pressed. There are better ways to do this than what we are doing, but for right now I think that's perfectly fine. It's not too complex or anything. Now Pac-Man doesn't move, but as soon as I press the A key, it moves backwards, which we don't really want, but we want to move it the other way around. So let's actually go here and say else if, and we can just copy this, and let's put let's put D there, and D will move Pac-Man to the right. So we want to just copy this and paste. Now we can just make that a plus. Now you'll notice we made Pac-Man here, we added that dot wider, so we want to move Pac-Man up and down as well. So let's actually do that. I'm going to copy this. I'm just going to paste it 2 more times, and I'm going to make this W, and I'm going to make this S. And now we can say Y instead of X, like that. And this should be minus. And let's see what we get. Now we can move Pac-Man any way we want, because we have control over Pac-Man. If we try and eat this pellet, it still gets eaten. But you'll notice if I press A and W at the same time, it doesn't really move up and down at the same time, or up and left at the same time. So how do we get around that problem? Well, we just, instead of saying else if, we just say if. And we just add our end here. As simple as that. So just end, and here we can say end. So we just add our individual if statements here. So instead of saying else if, where only one of those can be executed, we're saying if, meaning all of these can be executed all at once without a problem. So now if I run this, you'll notice I'm able to move up and down at the same time, as you can see right here. And that's something you should take note of, because sometimes in your game you want that to be something you can do, but sometimes it's not. So you should be able to kind of figure out which one you want for your game, so you can know if you should use an if statement or an if-else statement. Cool. Now what if you wanted to rotate Pac-Man? Because I know in the real game he doesn't really rotate that much. He either looks up or he looks down. But what if we wanted to do that? What if we wanted to rotate Pac-Man slowly if we wanted to move around? Because let's say this is the normal Pac-Man. We want to make a Pac-Man that can kind of just do everything. Well, that's not too difficult. So you'll notice here we have two angles, the X angle and the Y angle. Or the X angle, it's just angle 1 and angle 2. Now we need to change this if we want to rotate Pac-Man, because you'll notice if we make this 2 and then this 6, Pac-Man will now be rotated, as you can see, right, like that. So let's try and rotate Pac-Man. So I'm going to go here and say, I'm just going to copy this really. And now I want to, if the user presses down, so that's the down arrow on the keyboard. If they press down, we want to basically take this angle right here, and we actually want to modify it a little bit. We're going to create maybe this Pac-Man right here and say angle, I'm going to just say angle 1 is equal to 1, and then angle 2 is equal to 6, and that's what we have here. So 1 and, actually it's 1 and 5, not 1 and 6, my bad. Like that. I'm just going to attach it to Pac-Man here. So Pac-Man will now have two more properties, angle 1 and angle 2. Like that. Now what we want to do is we want to change the angle 1 and angle 2 here. So I'm going to go like that. And let's do this. And maybe make this angle 2. Now let's just try and see how that works. Now we can't really see anything happening. And actually, you know why this didn't work? It's because we never assigned angles here. My bad, I should have done all of this from the start. So there we have angle 1, and now we can make this angle 2. Now if we were to run again, as you can see, Pac-Man spins. But it's a little fast, you know, because we can't really control where the spin ends. It's too fast for us to actually figure out. So what can we do to make this slower? Well, we can actually just say math.py times dt. And this is where dt comes in real handy, because now we can slow it down a lot. As you can see here, it's a lot slower. Now if we want to basically add more here, we can just say else if I'm just going to copy this and I'm going to paste it here. I'm going to say up. It's going to contain the same code, but now instead of being plus, it's going to be minus, meaning I can now move either up or down. As you can see here, everything still works. Currently, the angle you keep it on won't really change which way it moves if you press W, S, or D, but you could change that if you wanted to. But it's a little bit more of the scope of this video. But yeah, that's some basics on actually moving things in your game using your keyboard. So getting keyboard input. There are multiple ways to get keyboard input, and we're going to discover those ways when we create the games. But for right now, I think this is more than enough to cover what we need. So we have a little character here, and we want to make him run around. Just like that. This is an image, and we basically want to load in an image and make it move. So if you want assets, you can come to www.gameart2d.com and just this link right here. I'll paste it in the description, and you can get it right here. And yeah, let's actually show you what you'll get. So if you go here, you click on free download, then you just wait for it to download. Boom, it's downloaded. Now you can open it up. Then if you extract it, like I did right here, I just extracted it by clicking right and extract to. You will probably have the same option on Windows. If you don't, I just recommend you go to Windows or you just download WinRAR or 7Z or whatnot. Then you'll find a PNG file and you'll find all of these. Well, the thing is, I didn't exactly use these like that. What I use is more something like this. As you can see, it's just one image with a bunch of them in one. This is what I like to call a sprite. These right here, to me, they're images, but they're actually sprites as well. Now you can of course just go online and find a way to like add these together. I believe there is like a sprite option or a sprite website where you can just go and create a sprite from images. Otherwise you can just... Alright, so let's get started. We can just close this browser. Now I'm going to just delete all of this because we don't need it. And all of this as well, which is very long. So we just plop that. And then all of this as well. Cool. Now, first we want to set up some of the core basics we'll need. And also, actually, I noticed I left myself a comment here. So if you want to also make the sprite yourself instead, which could be good practice if you want to make your own sprites, then you can go to this codeshack.io image-sprite sheet generator. And you can just browse images and throw them in here. This is what I used. I completely forgot about it. Anyhow, now here we first need to set up some basic information about the character. Jack, because that's what I like to call my characters. But you can call main character or whatever you prefer. And we're going to make that equal to, and x is equal to 0, and y is equal to 0. So this will be the x and y position of Jack. I'm just going to go _g.jack to specify Jack, or you can go here and you can say quick fix and just disable diagnostics like that. And this is a VSCode thing where basically it won't give you an error if you use a lowercase global like this without specifying _g. Okay, now you'll notice I have a sprites folder in my directory. So if I were to open the containing folder, there's a sprites folder. Inside of the sprites folder is a spritesheet.png. This sprite sheet is just what contains the sprite boy over here, Jack. Now we need to go inside of sprites and we need to access that. So for the character, I'm going to also give him another property called sprite to specify this is its sprite. It will be love.graphics.newImage. And here we can specify sprites, as you can see there. So sprites, and then inside of it we have a spritesheet.png. I'm going to rename that and then just copy the text. So don't actually remember, just copy the text, and I'm going to paste the text here. This will basically get that entire sprite for me. Cool. Now that we have that, we can go here to underneath Jack, and here we need to set the sprite height and the sprite width. So if we were to go back here and we click on this sprite right here, I know, can we see the properties? It doesn't seem like it. If I click here, nope. let's open up my containing folder, properties, and let's say image. As you can see, this is the size of this image. So 5,352 by 569. Nice. Now I'm going to copy that, and I'm going to go here to my main.lua and just paste it there in a comment, because that is the width and the height. So I'm going to create two variables to specify the sprite width and height. So sprite width and then also sprite height. Now, of course, you could have also, if you wanted to, say sprite, and then make sprite equal to a table. So a table within a table. Then you could have said image is equal to this right here. This is perfectly fine as well. And then you could have specified the height and the width in here as well. You could have done this. This is perfectly fine. But I don't want to get too complicated with tables because they can become kind of complicated. So for now, we can just do that. Okay, cool. Now here we can just say it's equal to, and now we can say 5,000, or we can just copy this part here, paste it here, and then just change that into a comma. And now this basically says the sprite width is this, and the sprite height is this. You could have split them up into two lines, but I like to do it in one line just because it's fast. So now that you have that, you can go to the next line and we can finally start working with the sprite in a sense. So we need to specify a quad of the sprite's width. So a quad is basically, let's say right here, this one block here, that would be a quad. This would be the next quad. This would be a next quad. Now, they have to be equal widths apart, otherwise you might get confused and you might have a lot of trouble. So make sure that they are and whatnot. So here we can just specify the quad stuff. So quad width is equal to 669. Nice. And how do I know this? Because I actually measured this beforehand. This is 669 per quad. I don't know how to measure it, but so don't ask me how to do it. I can't remember for the life of me. And then you have your quad height, which will be the same as your sprite height. Why? Because as you can see, all the quads are the same height and they're the height that the entire sprite is. So like that. And you could have also put this in one line, but I wanted to show you, you can do both if you wanted to. Now what we need to do is we need to basically specify for each quad. Now you could have just used a bunch of images like they gave us inside of the folder. Or if you use what I use, you need to do the following. You need to, for every quad, you need to specify. So love.graphics.newQuad. And here you need to specify the location you start at. This will change. The height of it won't change, but the width of it will change. So where it starts in width. So this starts at 0, 0. So meaning it starts right here, right there. And then we want to specify the quad width. Whoa. And then the quad height. And this will just specify the height and width to get it with for the quad. And then we need to specify the entire sprite width and sprite height. Cool. Now for the next one, we need to basically specify the quad width and everything else stays the same. And now we need to do it again and again and again. And you can already see where this is going. You're going to have to do that a ton of times. And it's going to be a bunch of copy paste code, which we want to try and avoid as much as possible. So an alternative way to go about doing this is by creating a quads table like that, and then creating a for loop. So for I, and then we can just remove all of these because we don't need it, is equal to 1, 2, and how many was there? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them. So 1 to 8, do the following. And we want to just copy this, paste it in here. And now we can just say quads at index of I is equal to this. But now what we can do is we can specify the quad width times I minus 1. So it starts at 0, so by default if it's 1 minus 1, this will be 0. So then it is the quad width times 0, which will return 0, because anything times 0 is 0. So just what we had, but now it has times. So now once this is 2, so once I turns into 2, this will become 1. So then it's the quad width, and then we have our quad width times 3, and whatnot. I can actually show you an example of how it would have looked if we didn't do this. It would have looked like that. So let me actually just do there. It would look like this. But instead of it looking like this, we used a for loop to make it shorter. So this quad width part here, as you can see, it starts with 0, then it starts with itself, then it starts with times 2, times 3, times 4. That's what we do here. So quad width times 0, 1, 2, etc. So we just saved ourselves tons of time, because now if we just add another quad to this sprite, we can just update this. As simple as that. Now we want to draw this sprite to the screen. So let's go here to draw. And here we can say love.graphics.draw Jack, because Jack is our character right here. And we want to specify the sprite it should draw. And we want to specify the quad it should draw, so quads, and let's just specify 1 for now. And then we want to say Jack at index X and also Jack at index Y to specify the location of the sprite. Now if we were to run the, this is in Python, this is love. Now if we were to run the program, we get a massive dude right here, but that's a sprite. With every sprite, this will change because the sprites will provide animation. So if we make that sprite 5, we'll get this, where the foot is now moved. So yeah, now that we know we can do this, let's first make Jack smaller, because Jack is very big. So let's say love.graphics.scale, and we scale it to 0.3. This will just make Jack a bit smaller by scaling all of the graphics to 0.3. So now he's about 0.3 his original size. Of course, you could have also just made the sprite smaller by actually, when you make the sprite, making it smaller. But in this case, it's not really that necessary. We can just say scale it and it will be scaled. Next up, we need to work on the animation. And we can create another thing here, and yet again you could have put all of this inside of here. I just want to show you can make them different, but usually you do want to actually keep them in here. But that's not too important for now. Now we can also create an animation option here, and this will be its own table. Yet again, you could have made this into this table here as well, would have worked perfectly fine. Now I want to specify the direction he's going to move in, so if it's left or right. So direction is equal to, and then here we can specify something like right. You also want to specify if he's standing still or not, so idle is equal to true, so that means he's standing still, he's not doing anything. This will allow us to kind of give him a specific position. So let's say that's the idle position. So if he's standing idle, he should look like this. If he's not idle, he should be moving through the frames. Then we can create the frame, and we can make that 1. And we can create a max frames, and that can be 8. So these max frames is basically just the amount of frames we have here. This also means now that we have implemented this max frames here, we can go and say jack.animation.max frames instead. Meaning if the max frames here ever change, we can just not have to worry about it here. We can also change the speed. So if you want it to move faster or slower, and we'll make that, let's say 20 for now. And then we also have a timer, and we can make that 0.1. And this will just determine when the character should change frames. So the lower the timer, the more the character will change frames. Alright, so now that we have all of this, we can start implementing it. So first, here we want to say if and not jack.animation.idle, then basically if he's not idling, then we want to say jack.animation.timer is equal to, and this is a very long thing to type, so I'm just going to copy that, and boom, and now here we can say plus dt, and this will just basically be our timer. It will determine when the frame should be changed. And here we can then say if the timer is more than 0.2, then the timer will be set to 0.1 again. And here we can basically specify the character everything. So let's first specify just the iteration, so we can just see the character move. So if, and I'm just going to say frame is more than the max frames, then we want to change this frame back to 1. So let's go like that and just say frame is equal to 1. Now that we have this in place, we can go above this line of code and we can say frame, and we can just make that equal to itself plus 1. So this will basically change frame every time the timer hits 0.2. And then once this frame is higher than 1, or higher than 8, which is the max amount here, we're going to change it back to 1. And it's going to start over. Now, instead of saying quads here, we can just say, and frame. There we go. So now we just specify the frame it's on, instead of an actual number. Meaning if we run now, we're supposed to be getting a moving body. And that's because this is if it's not idle. And currently, our character is very much idle. So let's just for now set the idle to false. So you can just see him move around. As you can see, we get a moving body. We can't really yet do anything because we haven't given them any way to do anything. Now that we have that, what we can do is we can implement key presses. So in the previous video, I did show you how to do key presses. So let's quickly implement that. So if it's not idle, then actually we don't even need to use this if statement. We can just say if love.keyboard.is down, and we specify let's say D. If we specify D, the idle should become false. So we can just specify this idle, and we can make that equal to false because this is being held down, meaning it should move. And then we can say else, let's go else if here, and we can copy this, paste it here, and we can make this equal to A, and we'll do the same thing. So both of these will do exactly the same thing for right now. And then here we can just say true, and if none of them are like that, we can just say else, copy this and make it equal to true again, like that. So now if we run this, we can make him move by specifying or by pressing A and D. But you'll notice he doesn't go back to the idle frame. That is because we need to set the idle frame. So when this doesn't get clicked, we should set the idle frame. So basically here we can say frame is equal to, and we can just specify 1. Because if we're not going to press it, we can just say 1, because then by default it will be that 1. As you can see, he now goes back to his idled frame. Pretty simple. So yeah, so if none of these two buttons are clicked, then we're just going to set him to idle and set his frame to 1. We can maybe go here, and here we say the direction is right. So we can get the direction, and here we can say Ctrl C and just change this to direction, and we can make this equal to right. And here we can make it equal to left. Now I can use this direction here to specify where the character should be moving to. So if the direction, go like that, is right. So if the direction is equal to right, then we want to change the character's go to. So we can say Jack dot x, because we want to change the x position of Jack, is equal to Jack dot x plus, and we can say just paste that, or damn it, Jack dot animation dot speed. So basically it'll move further to one side depending on, well, don't do that, depending on the speed we put here. Cool. Now we want to check if it's left as well. So here we can say else, and we just copy this if statement, paste it here, but now we can make this if it's left, and we can say minus, like that. Now if we were to run this, you'll notice we can move forward and we can move backwards. That's pretty neat. If we want them to move forward or backwards faster or slower, then here we can make that 30. That will make it move forward or backwards faster, as you can see here. So the more you make this, the more you increase this, the faster he'll move. So as you can see now he's running. I don't really have enough frames to cover him running that fast. Interesting. Also, I forgot to mention, if you're seeing a very bad frame rate on your end, just take that I am filming at 15 frames per second, so you might see bad frames compared to what I see. Anyhow, now that we have that, we can start making the character switch which way it's looking towards, because currently the character just runs forward backwards. Like, it's not normal to run backwards like that. So we need to make the character start looking forward. So I'm just going to turn down the speed here to something like 20 again. Now here we can basically just get the direction. So I'm going to just copy this if else statement. And now we can just draw the character. And we just actually do an else here, we don't need the rest. Now we can just draw the character to the location we want it to. So if it's right, we can just draw him as normal. But if it's left, we have to do a little extra to make him turn, because currently he doesn't turn. So we have to flip him, because here he's only facing one way. So we need to kind of flip him around to make him face the other way. So right here, after you specify the Y position, you can specify 0, -1, 1, quad width, and 0. Now you might be wondering, what are all of these numbers? So this first 0 here, this specifies the radius, or the radians, not the radius. This will make the character, maybe let's say, flip himself. So instead of looking like that, he's facing upwards or facing downwards. That's this part right here, that's the radians. This part right here is the scale factor to the x-axis and the scale factor to the y-axis. So this will make him flip other way around. This right here is the offset, as well as this. This is just to make him not look weird while we're moving around. And I'll show you more in a second. So as you can see, we can now face two ways. So let's start with the first part. If we go here and we make that 20, for example, 20 radians, not radius, but radians. Actually, yeah, as you can see, it goes crazy. So once we switch him around, he's facing a way different way. I find that very funny, actually. But yeah, that's if we change that, because that will just kind of swap the way he's looking towards. So whenever we don't press D, it's going to flip him around. This is just to keep him looking to a specific location. So if I were to remove that negative, there it's just going to look the same way, no matter which way we turn. Actually, no, he's just gonna disappear. Ah, wait. That actually just moves him to the... Okay, very confusing, but yeah, that just moves him backwards. So I guess my origin offset, I got that wrong probably. Anyways, I can make that back to -1. But you'll anyways notice he didn't turn while I was doing that. So as you can see, it didn't quite turn either. So if you were to make that 1, it's not going to turn. He's going to kind of run the same way looking, just from a different location, as you can see right there. And of course you can play around with it, like making it 0.4, seeing how it turns around now. Could be interesting. See here? Yeah, now he just looks weird. But basically he's being flipped. So he's literally being completely flipped around. You can play around with that to kind of play around with it a bit more to understand how it works. But I'm going to leave it right there. Then here it's the same thing, but just the other way around. So if we were to minus that, now we will do it on y-axis as well. So boom. Yeah. I probably got to bring him down, otherwise we won't be able to see him. But yeah, that will do it on the y-axis as well. And in here we just specify the quad width to kind of get the offset and then the height. So these two aren't too important. We just need to put them there so it knows where to put it. And right now we have created a character that can actually walk around and do as he pleases. And hello everyone, if you're enjoying this tutorial, please leave a like and subscribe for future tutorials. You probably want to see what game we are going to build. So let me just start up everything here and then boom. Now here we go. So this game is called Save the Ball. It's one of the very first games I made when I tried to create a game. So we have things like the FPS counter, which is optional. We have buttons and yeah. Now if we click on play game, we basically get this. We get a little counter here that counts how many points we have. This is based on seconds. So every second will give you a counter or a point. And then if you have enough points, then the next level will start where there appears another ball. Now these balls will get faster and faster with every level you make. For an example, in this case, the first level is 15. And then the second level I believe is 30, yes. And there's another level at 40 I believe, and one at 60, and it just goes on. But it's a very basic game, but it teaches you things like collision detection, how DT works, how to get the FPS, how to draw shapes, all of these things in Love2D. And then you also have your game over screen with your score, and you can say something like replay if you want, and yeah. So that's the basics of the game. Now if you do ever fall behind when trying to play this game, you can always just go to, whoa, my bad. You can always just go to GitHub, and this link will be in the description. If it's not, just send a comment my way and I will remember to put it here. Now in this repository here, YouTube projects on Weebnetsu, you can go here to Lua, and inside of it you'll see a folder called Save the Ball. And in here, you'll have multiple parts. We are on part 1. So everything we're going to do is going to be right here. So if you fall behind or you want to maybe go check, you can come here. And part 5 would be the end result. Okay, cool. So let me just move this back to its original screen. Now here I have an empty folder. I'm going to create a new folder and call it Save the Ball. You can add spaces and whatnot, but I'm going to keep it spaceless. And then in here, I'm going to create a new document or a new file and call it main.lua. Now, what do you need to know before we start with this tutorial? You need to know Love2D. I have a whole course on it with like 5 parts or something that you can watch. If you have not seen those tutorials yet, I do recommend you do, because they are going to be very useful. You don't have to see them, we are going to cover a lot of things from the start, but I do recommend you do, because it will just make things so much easier if you do. And you also need Love2D installed, of course. Now I'm going to open up VSCode in here, but you can open up whatever you want to. I just prefer coding in VSCode. So here's VSCode. I'm going to close this. And here you see there's my main.lua file I created. Cool. Now, let's start by first importing love. So I'm going to say local love is equal to require and love. Now we can create our three functions we need. So function love.load. Now this one will be love.update, and this one will be love.draw. Cool. So as we know, this will load everything we need into the game. This will update the game, and this will draw everything to the screen. Now, we can save this, and we can also open up our terminal, which I'm going to move to the right. And now here we can say love dot. So it does nothing. Love2D here does absolutely nothing. So what I'm going to do, you do not have to do this, but I'm going to do this. If we can just, there we go. I'm going to create a new file, call it conf.lua. You do not need to create this configuration file. I, however, am going to create it because I would like my window to pop up on the second screen, but you do not have to do this because you might not have a second screen. So t.window.display, and we can make that equal to 2. This should open it up on this window. Now we can just run love dot again, and there we go. Cool. Now we can go back here. I'm going to close that conf file because I don't need it open anymore. And yeah. So first, I would like to set the title of the window. So love.window.setTitle, and we can set it to save the ball. Now you could have also put this inside of that conf.lua file. If you saw my tutorial on it, you do know how to put it in there. Although I want to show you the alternative methods of doing these things as well. So I'm going to do it on the onload of this Love2D game. But if you want to, you can do it here as well. Because you can do this Windows display thing, you can also do it in here. You can do the Windows resizing in here, you can do everything you want in here. First thing I want to do is I want us to be able to see the cursor. Because if you might have noticed, or as you may have noticed, if I were to just move this back here, our cursor is a little white dot. That's our mouse. I want to code this into the game right now. So let's do that. Let's code it in. So first thing we'll need is we'll need to get the player location. And that's going to be that little circle. So local player is going to be equal to this. And you could also put this inside of this load. It's optional. Then we need three things. We need the radius. And I'm going to make that equal to 20. We need an X position, and we're going to make that equal to 30. And we need a Y position and make that equal to 30. You could make this equal to 0 as well. It doesn't matter. I just like doing 30 because why not? Cool. Now we need to basically always update that position. So player.x and player.y is equal to the mouse.getPosition. So this right here returns two values. It returns an X and a Y position value. So we're storing the first value we get into this player.x, which is this, and the second value we get in the player.y, which is this. And we're doing it on every update because every time the player moves the cursor, an update will occur. Now you may also notice if I move around, things might look a little bit laggy, but that's just because I record on 15 frames per second because that's just what I'm used to and that's what I edit in. So things may look a bit laggy, but on your end it should not be looking laggy. You should be getting about 30 to 60 frames a second. Alright. Now here with the draw. we want to basically draw the circle. So I'm going to say love.graphics.circle, and I'm going to go fill method player.x, player.y, and also player.radius. This will draw a circle where the player's x and y meets up and give it the radius that we specified up here. Now if we were to run this, we'll get a massive circle. Now this is the in-game circle, because we will have two states that we're going to be using right now. And those two states will determine the size of the player. So I'm going to create a local game, and it's going to be a table with state. Now we have a menu, and we're going to make it equal to true. Now this will be the states we have. So for example, we have a menu state. If it's a menu state, it's going to show the menu. If it's the paused state, it's going to show a paused menu. Now here I'm going to make that paused. I'm going to make that running. And I'm going to make this ended. Now currently, we want all of these to be false. And just this one to be true. That's for the menu state. Now down here, we want to specify when should it do what size. So I'm going to go if game.state, and we declared state up here, and then in square brackets and in quotation marks, I'm going to say if it's the menu state. So like that, and you'll notice right here. So if it's the menu state, then we want to basically do this, and we just want to divide this by 2. So if it's the menu state, then it should be the normal circle size, but just divided by 2. I'm going to create another if statement, but this one will contain a not menu. And there's a reason I don't make this an if-else statement, and you'll see in the future tutorials. So here I'm just going to remove that divided by 2. Now if we were to run the game, we'll see this, a much smaller circle. That's because we're in the menu state, so the circle is half its original size. Now if I were to change the menu to false, and then the running to true, and my bad, these two should be running, not menu. And now that we have that, we can actually just move that, so divide it by 2, and we can just move it to the bottom one. So now the first one is if the game is in its running state, meaning if the game is being played, give us the full circle. Otherwise, in any other state, half the size of that circle. Now if we run it, we get the full circle because it's in a running state. Any other state we switch to, no matter what the state, if we make this false and we make the state of paused to true, then we'll get the smaller version, as you can see here. So any other state will give us the smaller version, but running will give us the big version. Cool, so I'm going to change this back to menu state. Now we need to hide the cursor, because as you can see, the cursor is still there. We don't really want the player to see the cursor because it breaks the immersion a little bit. So to get rid of the cursor, what you can do is here in the load, we can say love.mouse.setVisible, and we can make this equal to false. This will make the mouse invisible. So now, if you run it, there's no longer a mouse. I can still move around, but the mouse itself is gone. Now, one last thing I do want to implement is the FPS counter, because let's say you're getting very bad FPS. You might have coded something wrong or something like that, because the FPS should usually stay at around 60 FPS, maybe falling to 30, but usually it should be 60 FPS, and we need a way to see that. So here at the top, because we don't want the FPS to block anything, so it should be at the top, so it always, if there's something above it, the FPS doesn't go over it. Anyways, we can say love.graphics.print printf, and here we can just say FPS colon and then dot dot, this is to concatenate the string, love.timer.get FPS, and that should be timer, not time. And there we go. Now if we run it, we actually get an error. And I believe we get this error because we should specify our font. So love.graphics.new font, and I'm going to specify 16. And let's specify an X and Y location as well. So let's go 10, 10. So now we have a font size of 16 and its X and Y position is 10 and 10. Now if we run it, we still get an error. And we just also need to specify where it stretches to. So love.graphics.width should work perfectly fine. And this should be get width. As simple as that. Now let's hope for the best. There we go, we get a little FPS. As you can see, it's around 60 FPS, and that's where it's good. Okay, cool. Now just because I have a little screen space, I'm going to just split this up into multiple lines. Like that, okay. So first we display the FPS. Then we set the font size. Then here is the X position, which we can keep 10. Here is the Y position, which I would actually like to go love.graphics.getHeight -10. And this will put it at the bottom of the screen, which is what I want. I want the FPS to be at the bottom of the screen just because it's less distracting. Let's make that 30 just to make it a bit bigger or a bit higher. And in this basically sets how far it should go before wrapping the text. Now if we were to run the code, our FPS is here at the bottom. And that's the very first part of the tutorial. We didn't do a lot, we just basically set the game state, created the player, created the load, the update and the draw functions, where the load sets the window title, it makes the mouse invisible, then we get to the update and it updates the player X and Y positions. Then on draw, it puts the FPS on the screen, and if the game state is running, it draws a circle with the player X and Y position and also the player radius. If the game state is not running, then it does the same as with running, but it divides the player size in two. So, first of all, this right here, this doesn't need to be here. You can actually remove that. It will run perfectly fine because by default Love will import it. But I'm still going to keep this here just to get all of those errors away and whatnot. So yeah, that's up to you before we continue, right? Okay, so in this tutorial we'll be creating the enemy. The enemy that's going to kind of run after us and whatnot. So first I would like to give our game another property. Difficulty. And difficulty is going to be set to 1. Now, the higher the difficulty, the more difficult the game should be. As simple as that. Because the speed of the enemies will be kind of dependent on the difficulty as well. And then we want to create a table called enemies. Now, this table isn't going to be used too much in this tutorial because we're only going to have one enemy. But once we get deeper into it, this table will be containing all our enemies. So all our enemies are going to go in here. We want to basically create our enemy object. Now we could do it in here, but this file is already going to be very big by the end of this tutorial. So we want to create a new file. So right here, we can right click, new file, and say enemy.lua. I'm going to give it a capital case E in its name to signify that this is an object. It's completely optional, it's just how I like to do things. If you have seen my tutorial on OOP, you will probably know there's multiple ways you can do OOP in Lua. And the first way is by using a table. The second way is by using a function and a table. And there are more ways, but I don't like covering the others because they're kind of difficult to understand, in my opinion. So in this case, I'm going to use functions and tables because I find those to be the most easiest to use. So first, we want to import love. So local love is equal to require love. Cool. And we don't need a semicolon. We're going to create a function and we're going to call it enemy. And this is going to be our object for enemy. Now, at the end of this function, we want to say return enemy. And this will basically export this enemy once we import it here. So this will be exported, this function right here. It's just so this massive function won't have to be found or used or whatnot in here. We don't have to see that massive function in here because it will be stored here. So let's start with very basics. We're going to return. And whatever is inside of this right here, this table, is going to be what's returned to us. So first we want to set the level to 1 by default. The radius, I'm going to make that equal to 20. Then the x is going to be equal to, and this is going to be enemy position for in case you didn't know. I'm going to make it, let's say, -10. And the y is going to be equal to -50. So basically, this is where the enemy's start position will be. We want it to be off the screen, and we're going to randomize where they actually come from later. But currently, we want it off the screen because it should kind of just pop into the screen as the level goes on. So more enemies will pop into the screen. Cool. So these are the first few things we'll use. Next up, we need to basically create something to draw the enemy and something to move the enemy. Let's first try and move the enemy because that's probably going to be the most difficult part here, is just moving the enemy. And that's going to be a function inside of this table. So it's a function inside of the table. And it's going to take in 3 items. Self, yet again, in my OOP tutorial, because it's going to take in itself. We also want to get the player, player X and the player Y. You could pass in the entire player in here, but I feel like that would just be kind of a waste of memory on the end of the day because you're going to pass in an entire object where you can just pass in 2 values. So I do recommend passing in these 2 specifically, just the X and the Y. Cool. Now basically we want to make the enemy move to the player. That's all we want to do. Very simple. We just want the enemy to go towards the player. So it will just be basic if statements. So if player at index X, or at X position, minus self.x, and this self is referencing this X right here. So where the enemy currently is. So if this value is more than 0, then self.x is equal to self.x plus self.level. So what we are doing here is basically if the player x minus self.x, if that is more than 0, and we're minusing here because remember x starts basically at this point right here. Alright, so future Steve here, and you know, I realized this wasn't a very great explanation. So let me actually explain it better. Let me just move this to number 3. So here we have basically our example. It's saying if the player at position, the X position of the player, minus the X position of the enemy. So let's quickly go here and just draw it out. Let's say the enemy is a red square. So this is the enemy. And, or actually let's make it a circle, otherwise things might get confusing. Okay, so the enemy is a red circle. And the player is a blue circle. Just draw a nice circle here. There we go. Now, here we're saying if the player at position X, okay, so the X position of the player would be there at the center. that would be the X position from here all the way up until there. That's the X. Because remember, X goes from side to side. That's X. While Y goes up and down. So this would be Y. So just remember that. So this is the X, right? Now we go here, if the player X, and yeah, so if the player X minus self.x, and self.x would be the X of the enemy. So this right here, this would be the enemy X, that's self.x. So this is the enemy, self.x right there. Now if we go here, we see if it is more than 0. Okay, so let's put this in a mathematical perspective. So let's say this right here is 63. The X position of the player is at position 63. And the X position of the enemy is at position 10. Now we are saying player at position X, okay, so it's 63. Whoa, let me just 63, right? Minus self.x, okay, so it's minus 10, because remember self.x is the enemy. So it's 63 minus 10, right? And that will give us 53. So the position between this point and this point is 53. That's basically what's being said here. And then we're saying, if it is more than 0, and we know 53 is more than 0, then we're saying self.x. So this would be the player X, or the enemy X, not the player. The enemy X is self.x. So we're saying self.x is equal to itself. Okay, so self.x, which is 10. Let's make this red because we're talking about enemy. So it's 10 because we're saying self.x. Okay, so it's going to be itself, so that is self.x, plus its level, so plus 1. So we are saying self.x becomes itself plus 1. So now self.x will be 11, because it will now be one step closer to the enemy. Meaning this right here will minus with 1, because 63 minus 11, and remember we got 11 with that quick equation, so that would be 11. So 63 minus 11 is equal to 52. So that will basically close the gap between the enemy and the player. This might be a little bit confusing to work with, like a lot of the math might be in game development. But don't get discouraged, because the more you work with it, the more you'll understand it. So yeah, back to the video. Now we also want to do the other side of X. So let's say the enemy is to the right of the player. So else if, and then player minus self.x is less than 0. So basically, if the player X minus self.x, because remember X becomes more the more you move right. So if the enemy is more right than the player, then this will be a negative value. This will return something negative. So basically, let's say this right here, that's the enemy, and this right here, oh yeah, no, not yellow, we can't see that. Okay, and this right there, that's the player. Now let's say on X, so X here would be equal to 2, and X here would be equal to 5. And remember, this is the enemy. That's why he's red. He is bad. He's the enemy. Bad. So let's just full screen this. So here we're saying if the player minus self.x is less than 0. So if the player, so 2 minus self.x, and remember this is the enemy, so minus 5 is less than 0, then do something. Now 2 minus 5 is negative 3. So this will return true. So if the enemy is to the right of the player, it will return true. And with the top one, if the enemy was to the left of the player, it would return true. If the enemy, it would be the same thing, just other way around. Now here you can just say self.x is equal to self.x minus self.level, because we want to decrease the x position of the enemy. If you're having trouble kind of wrapping your head around this, don't worry. The first time it can be a bit difficult. I had the same problem when I first thought of this, like, wow, my brain can't wrap around this math. But don't worry, it gets easier. And it's going to be the same thing, but for y. So if y, let me just change all of these to y. So if player y minus self.y is more than 0, then self.y becomes the same but plus. It's the same thing, now it's just y. Because if I were to open up drawing, then basically remember y goes down. That's how y goes. So this is the player and this is the enemy. Now let's quickly go check here. So if the player y minus the enemy y is less than 0, so the enemy y, let's say, is equal to 10. Because remember, goes down. So this would be 0. And this would be something like 20 or something. And here, the y would be equal to, let's say, 5. Now, here we're checking if the player y minus self.y is less than 0. So if 5 minus 10 is less than 0, and those two minus will be negative 5. Right? And that is less than 0. Then we're saying, wrong window, self.y becomes itself minus the level. So it will decrease. So now we're saying, okay, move this upwards. So now the y will become 9 because we're moving it upwards. And this is going to run with every update. So it's going to move the enemy closer to the player with every update. So yeah, let's continue to the next part then. Now we want to be able to draw the enemy. So that was going to be another function called draw. It's going to be function taken self, doesn't have to take anything else. And here we first want to set the color. Love.graphics.set color. This is basically just going to set the color of the thing we're going to draw. Now I'm going to choose a very random number in order to figure this out. So I'm just going to say 1, 0.5, and 0.7. Just a random number that popped up into my head. Remember, you could have also gone like 255 divided by 255. And same here, you could have just gone, what's the half of 255? Anyways, the half of 255 divided by 255. So you could have done that as well, but I preferred not to in this case. And then we're going to draw a circle, but you can make the enemy a different shape than a circle. I just find it easier to do it as a circle. So love.graphics.circle, and we're going to fill this circle. We're going to put it at position self.x, self.y, and it's make the size of self.radius. So we're going to draw a circle at it's the x index, the y index, and then we're going to give it this size right here. And we set all of that up here. And then we can say love.graphics.set color. So we're going to reset the color back to white, because that's going to be our default background color. You don't have to set it here, but I prefer setting it here than having to set it here in this draw function over and over and over. It also just prevents a bunch of bugs that could possibly occur. Okay, so that's the most basic version. We'll later on throw in letting jump in from random size, but I think for now that should be fine. So this is the enemy. Now here we have our enemy object, and now we can insert our very first enemy. So here in load, we want to insert our first enemy. Table.insert, and it's just a normal insert method. And I'm going to insert it into the enemies table right there. And we need to import enemy, now that I think about it. So local enemy. And you don't have to give it the same name. I just like using this name, and we're going to say enemy, and it should be capital E. That just means basically import enemy from this file right here. That's what we're saying right here. Cool. Now that we have that, we can go here and we can say at index 1 insert our first enemy, and it should not have a capital E because we gave it a lowercase e as a name, or we should have. There we go. Lowercase e, not capital E. Okay, but you could give it a capital case E name. I just preferred going lowercase. Cool. Now that will insert our first enemy. Now here in update, before we can actually try and use this enemy, we need to basically for I, and yeah, let's just go like that. For I equals 1, and let's also remove all of that, until the number of enemies, and then do. So basically, for every enemy inside of this enemies table, currently we only have 1, but later we'll have more. We want to go enemies, or enemy, or yeah, enemies actually, and then add that index, so index I, colon move. Take note, I'm using a colon here and not a dot. And then here we can just pass in the player dot x and the player dot y. Why am I passing these in? Because here in move we're taking player x and player y. We do not have to pass in self because self gets passed in for us. Cool, so for every enemy, do this. You can also create an update function instead that will, instead of just moving it, it will do all of the updating for the enemy. That could also be something you can rather implement instead of move. But this game is so basic, I'm just going to have a move function and not an update. Cool, now we need to draw the enemy. Let's go here into if the game state is running, right? Then we can go and above the player, because we kind of want the player to overlap with the enemy, or you could do this below, it doesn't really matter that much. And actually I'm just going to copy this because it's going to be the same code, just a different command. So boom, and here I'm just going to say draw. So this will draw every enemy inside of the table. Okay, so let's try and run this and see what we get. Love dot. Let's see. And you know what? We're not getting anything. It's because currently we're in the menu state and everything just gets drawn if the state is not the menu. So yeah, let's go there and just go false. And in here we can just say running is true. There we go. Now it should work. As you can see there, the enemy comes to get us, but currently nothing happens. So the enemy just stops once it gets on top of us. But it should later on like stop the game if the enemy touches us. But you'll also notice the enemy always comes from the same side. And that's very boring because we want the enemies to actually come from different sides to make the game more interesting. So to do that, we can just implement a little bit of math. And this math will basically make the enemy come from different sides. Now, here at the top, I'm going to declare 4 variables. Local dice, local x and y. And take notes, these have underscores. You don't have to give them names of underscores. I just find it much easier to work with them if they have that. And also local and an underscore radius. Cool. These two are not going to have any values associated with them at the moment. Radius will make 20 as a default, but you can later on then modify this radius to give you more interesting sizes. So let's say you want different size enemies. That could be kind of neat. Now this radius here, I'm going to paste it here. This X here, I'm going to paste it here because it's going to be modified. And this Y here, I'm going to paste it here. So these are all going to be modified except for radius. So these are all going to be modified and these two will now be set here. And we're doing this because we want the self to work when we want these. Because this is not part of the table. It's part of the function, but it's not part of the table that's being returned to us. But it is part of the function. So this one won't be returned to us. We won't be able to access these values. But we will be able to access any values in here. It's something you have to wrap your head around because it can be a little confusing. Okay, and this dice will basically determine from which side will the enemy appear. From this side, from this side, from this side, or from this side. So I'm going to make this a math.random. And we're going to make it 1 and 4. And before we forget, in the main.lua file, not in the enemy, but in the main.lua file, we want to just math.randomSeed. And we want to just give it os.time. Now, what we are doing here is we're basically saying every second change the seed we're going to get. So whenever the user boots up the game, their random numbers will be more random. Because if we don't add this, then the enemies will always start from the same place. And we don't want that. Because currently, as you might have seen in my random video, the random numbers don't really change. They kind of stay the same. Unless we seed them. So, unless we seed them. If you don't understand that yet, I do recommend you go watch my tutorial on it. I do have an entire crash course on it after all. Cool. Now we need to basically give the dice functionality. So we can say if dice is equal to 1, then underscore x is equal to math.random. So we're going to give it a random position on the x-axis. So anywhere random here. So there we go. Math.random. And then underscore radius. Because we wanted to start at minimum at the radius. So the enemy will always be hidden. No matter where it is on the x-axis. And then love.graphics.getWidth. And this will just throw in the width. So it will give us basically a random number between the radius, so 20, and the width that's given to the window. And then we want to say y, or you can actually just do it underneath. Y is equal to minus, so negative, underscore radius times 4. So if the dice is 1, and this should be underscore y. So if the dice is 1, x can be anywhere on top of this right here, anywhere. But y specifically will be minus the radius. So remember, it's going to basically be here. So y0 is here. So y minus the radius would go up. So minus the radius will basically mean hide the entire ball, hide the entire enemy. And we times it by 4. So it's going to be basically being hidden 4 times itself. This will also give it a little bit of a time you have to wait once the new level starts before it actually starts jumping in. So it doesn't just go into the screen immediately. You'll kind of understand it once we actually use this. So now we can just say else. And I'm just going to copy this right here. Alright, a little disturbance. I can't remember where it was, but okay. Yeah, I believe it was just like this, and we go boom. Okay, now else if the dice is equal to 2. It's going to basically be the same thing. But I'm just going to copy these else ifs, because we're going to have kind of a lot of them. Except for the last one. The last one will just be else. And in this one we can make 3. And in the else would be if it's not 1, 2, or 3, then just give it this one by default. Okay, so with the second one, it's going to be a little bit different. It's going to basically be swapped. So x will contain this, and y will contain this. And in here we can, instead of say get width, we can say get height. Now, why is this like this? Why did we swap it around here? Well, if the dice is 2, we're saying, okay, x should be here, but it should be minus its own width. So basically it should hide itself times 4. So it's going to go to the side here 4 times itself, its own width. And then with y, we're saying, okay, find any place from this part right here, right? And just anywhere towards the height. You don't necessarily have to specify this radius here. You can make this 0, because remember, it's just going to come in from a random side anyways. But basically, it's going to be able to come in from anywhere on this side right here. So if the dice is 2, anywhere here. If the dice is 1, anywhere here from the top. If the dice is 3, however, then we're going to do everything the same. But this one right here, this y, we're going to say love.graphics.getHeight plus, and then we're going to say radius times 4. Whoa, radius times 4. And no minus. So why are we saying this here? Well, basically we're saying, okay, if the dice is 3, x can be anywhere from this right here. And then we're saying, okay, the y should be the height plus itself times 4. So anywhere from below here. So now it's not anywhere from the top, but anywhere from the bottom, like from here. That's what we did here. We basically set the y to the bottom of the screen. And in here it will be basically the same as with if dice were 2. So we can do like that. But now the difference is, and remember to remove this minus symbol right there. X here, we can just go and, well, no. We just go and do this. And we can say love.graphics.getWidth plus. And now what we're saying is, okay, it can come anywhere from this side right here. So now it can come, the enemy can come from anywhere inside of this window here. Not this window, but the game window itself. So it can either come from here, the top, which we did first, or it can come from the side, which we did second, or from the bottom, which we did third, or from this side right here, from the right side, which we did last. And now these x and y values, as its default values that ball first gets, comes from here. And this will be different for every ball. That's the nice part, because every time we create a ball, it's going to execute all of this. And then it's going to return this to us. But this x and y would have changed. And if you want, you can also change the radius. So yeah. Now if we were to run the game, it comes from the part down here. Okay, let's run it again and see it happening again. Oh. Attempt to perform algorithm get field a function value. So this is enemy 18. Let's see here. Ah, there we go. That should have those little bracket things there. Okay, let's see. And it starts from this side now. Okay, one more time just to make sure we have everything. It starts from the top. So that's the nice thing. Every time you start the game, it starts from a different angle, which is pretty neat. And I believe that's all we need to do for the enemy. Alright, so first we want to go to the main.lua file, this main one right here, and we want to make this true because today we're going to be working on the menu. So we want to be able to see the menu by going here to true. This shouldn't do much except for resizing your cursor, so make sure it does. Now we're going to create another table here called local buttons, and these buttons will basically contain all of the buttons for all of our different states. So menu underscore state will then become an empty table. Cool. So now that we have that, let's go here to the side and just create a new file. I'm going to call this button.lua. It's going to be a button class. And this button class will basically contain all of the things we'll need for buttons. So local love, which is optional, but I love doing this. Require, and then we can just say love. Then you can create a function called button. And yeah, simple as that. Now we want quite a few things. We're not going to mess around with too many things just yet. But I can tell you from the bat, our button will probably have text on it. And we probably want to set the text when we create the button. So something like text. And we also need to be able to execute a function. So func, because when we click the button, it should be able to do something. And this func we pass in is what it should be able to do. This method isn't too great. I don't love it that much, but it does get the job done, and that's what we want at this moment. We also want to be able to pass an optional parameter into the function. So we can include func param. And then we want to include the width and then the height of the button. Okay, so next we can just say return, and it's going to return a table. This table is going to return will contain width, and that's going to be either the width passed in or 100 by default. And then we want a height, which will be the same thing. So like that. So either the height passed in or 100. Then we're going to create a function, and this function will be equal to the function passed in, to func passed in, or to a function that doesn't do much. It's just an anonymous function. It's not going to do anything really. It's just going to print this button has no function attached. As simple as that. If you wanted to, you can even make it shorter and make it one line like that. It's optional. You can make it more than one line. I kind of like it as one line because it just does a quick one-liner. And then the function parameter will be the function parameter passed in. If there's no function parameter passed in, it will be nil and no parameter will be passed in. And then the text will be equal to text or no text. Then the button's X position will be equal to 0. The button Y position will be equal to 0. And then the text on the button should be at position 0, and then the text Y of the button should be at position 0 as well. Okay, so this is a lot of things we're just setting by default. You don't have to worry too much about it. And then of course we want to return the button down here before I forget, because I'm going to forget if I did it now. Cool. Now we are going to do things like making the button clickable and whatnot, but first we want to be able to draw the button. That's the most important part right now, because we need to kind of get the button just on to see that it works. So let's create a draw function for the button, which will be a function, and this function takes in self, and then the button's X position, the button's Y position, and then the text X and the text Y position. Now, I might be putting it here, like the button X, Y, text X, and text Y might be able to be passed in from here. So these 4 attributes. But if you wanted to, you could pass them in here. The reason I'm doing this is if you ever later want to animate the button, so the button moves from one position to another position, then you can do it from here. You can, when you draw it, you can just move the button X and Y positions as you please, instead of having the X and Y positions kind of set as soon as you create the button. This is personal preference. I like doing this. You don't have to do this. You can put all of this. You can put it in here. There's no problem with that. I just want to do it here. And this also keeps this from kind of cluttering up and having 50,000 freaking things it needs to take in, because now it's being split into two. Cool. Now here we want to say self.button X, and of course you could have made this a table as well, but we're already in a table, so having another table within a table is just, personal preference yet again. And that can be equal to button X, so this button X right here, or self.button X. So this button X here or this button X here, one of these two. Self.button X is referring to this button X. Don't get too confused here. So just as I said, you could put the button X and the Y up here as well, and it will be set here as well. Anyhow, and we can just copy that and do the same for Y. So self.button Y, like that. Then here we can basically set the text position. So if text X, so if the text does exist, the X position of the text, which is passed in here, then we can say self.text at position X is equal to text at position X plus self.button X. Else self.textX is equal to self.button X. Now you could have done this yet again in one line, where you basically check if this exists, and if it does exist, you do your things. You could have done it like this, but I find it to be a lot less confusing and just so much easier to also understand if you're reading it, if you do it like this, where if it's text X, do all of this, otherwise do this. Instead of using this OR way here, which could work, but I'd rather not, because that's going to be prone to bugs, because I'm not too good at reading that. And then here we can of course just go text Y, and in here we can say button at Y, like that. Now we're just saying the text on the button. So this is the text that exists on the button. If the X exists, so if this X position is being passed in for it, then make the original one here, make it equal to what is passed in plus the button X. We're saying the button X here because the button may be 30 pixels to the right. But the text isn't just going to be placed onto the button automatically. So we'll need to tell the text, add that X. So we're going to have our button X, and then we're going to need to add to it. That's this here. I'll show you how this works in a second once we actually draw this to the screen, just so you can kind of get an idea. Now take note, this bottom order I'm going to do here is very important. So love.graphics.setColor, and you can pass in your own color, the color you want for every single button. But in this game, I'm just going to keep all of the buttons the same color. 0.6, 0.6, 0.6. It's going to be a light-ish color. Then we want to draw the button. So love.graphics.rectangle, and if you're still a little bit touchy on this right here, don't worry, I am going to explain it. I just want to kind of give you something you can visualize when I explain it. And we can just say fill it, because we want to fill it so we don't see the background color of the game. And then self.buttonX, position at X, self.button Y, self.width, and it's self.height. So this is where the button is going to be drawn to and how it's going to be drawn. Okay, so that's for the button. We can do that. Now we need to do the text, because remember, the text isn't really part of the button. It's its own thing. So we need to do it here as well. So love.graphics.set color, and we're going to make it equal to black. Now you can make it a different color, but I feel like this color works perfectly with this lightish grayish color. Then we want to love.graphics.print, and we want to print self.text, self.text, and then self.text at position X, and then self.text at position Y. Take note, I'm using self everywhere because we want to, on the end of the day, use this everywhere in our code. This will just make things so much easier. So whatever you do, do not change these values here or any values you set in here. Try and keep it as much as possible to these global-ish values we have here. Because believe me, it's going to solve a lot of problems later. And then we just want to reset. This is optional, you can do it somewhere else, but I'm going to reset the color here to be white. So that's going to be my always fallback default color. It's going to be pure white. Okay, we have created the button and the button can now be drawn. Now here we want to basically create the 3 buttons for our game. I'm going to create just one button for now. And here we have our menu state button. So we want to create it on here. So in the load, we are going to go here. So here with the onload, I'm going to create a button, or go to our buttons, say dot menu state, and then I'm going to add a play game button. Now this play game button is just going to be a button which we need to import. So let me go here and just import the button. And here we can just make that button. Cool. Now here we can make that equal to a button, which we just imported from this file we have here. Make sure to export the button by saying return button. And in here we can pass in our values. So first it wants text. So here we can just say play game, because that's what it does. It tells you to play the game. I'm going to pass in nil, because we do not have a function or a function parameter we want to pass in. Then I'm going to pass in, let's say 50 and 50. We're going to position it nicely later. So it's going to be the X and the Y position of the button. Now down here, where we draw the game, and here it says game.state running. We want to add an else if, because else if the game.state is not running, but instead it is of menu, and this should just be in square brackets, not circular brackets. So else if the game state is in menu state, we want to go to buttons dot menu state dot play game, and we want to say colon draw to call the draw function. And now in here we want to specify a bunch of things. So I wonder if it, yeah, there we go. So the button X position, we can go 10, the button Y position 20, and then we could just maybe say 10 and 20 like that, just as an example. Now it's not going to give us anything great. And was this really X and Y? What was this? This was, oh, the width and the height. So it's going to be 50 width, 50 height. And then here it's just going to draw it at position 10 and 20. And then the text is going to be at position 10 and 20 as well. But not the same 10 and 20 as this button, because we changed that. And I'll show you that in a second, because I know it's going to be confusing. And take note, this is still here, this if statement, because if the game state is not running, we just want the circle to be smaller. So the circle should be smaller in this menu state. And the circle should be smaller in this running state. Or it should be larger in this running state. Anyhow, let's go here. And here we go. So we have a button, not really the best. It's looking kind of small there. So let's just make the button a bit bigger. So I'm going to go here to the above where it's 50-50. And I'm going to maybe make it a bit longer, so 120, and maybe a bit shorter or a bit less tall, so 40. Now that does look much better. Okay. And then here we have a play game, and you'll notice it looks kind of weird. Now if I were to show you something interesting here, so what do we have here? We have the button X and Y position. So let's make this text X and Y position 5 and 5, just so I can show you what's happening, because this is kind of part that may have been confusing to a lot of you. As you can see here, it's 5 from this left side and 5 from the top. Now, if we go back to button here, and we don't do this, we just say, okay, just make them what is passed in. That's all you have to do. Just make them what we pass in. Or actually, no, let's actually change this up. So we go like that, and we uncomment these. There we go. So if we just did this, I want to show what would have happened. So if we just said self.textx and self.texty is what we pass in, then you can't see it, because the text is now 5 pixels from here and 5 pixels from the top. Not from the button width and height, but from the top. So that breaks a lot of things. So if we change the text color then instead. So here it's 0, 0, 0, 0. We can just make it 1, 1, 1, 1 then. All these finger pop-ups. There we go. 1. Then you'll see it's right there. Now, we don't want that, right? We don't want that. That is why we have this right here. This self.buttonX. So even if we don't pass in anything, it's going to be at the same location our button starts at. So for example, if I were to comment all of this back in again, and I were to not pass in a text X or Y, which will run this then it would look like this. As you can see, it's right there at the button, but not at the game. So that is why we did that. We don't want this to start here at the game. We always wanted to start at the button X and Y positions. Cool. Now let's make this maybe like a 17 and a 10. That should look good for right now. Yeah, that looks perfectly fine. Later on, we'll change the font a little bit to be a bit bigger and just match the button better. But for now, I think that's fine. So yeah, there's our first button, play game. Let's create 2 more buttons. And I'm going to just go here. Now this second button is optional, because I'm not going to code it. It's going to be your homework at some point. So settings. So this is going to be the settings button. And then we want an exit game button. And in this button, we'll say settings. And it's going to have the same width and height. And in this button right here will be exit game. Or just even exit if you want to. And then the same width and height. And because all of them are the same width and height, you could always make this the default width and height. Like here where we do this, you can make it the default here. That would actually be a good idea. Now we can code the exit button right now. We can give it its function. So love.event.quit. Because this will quit love. So once the button is clicked, it will run this code. Or we haven't really implemented that, but that's what it should do. Take note, all of these are from the menu state because they will all be displayed once the menu state is true. Okay, now we can go down here again and we can draw the game. So let's go like this. And let's draw settings. And let's draw exit game. And let's see. How do they look? What do we see? Like, we just see exit game because that's what's been drawn last. So we can just make them all go down a bit. We can leave the rest to be exactly the same. So we can say 70, and here we can maybe like 120. And that looks fine to me at least. So now we have a play game, a setting, and an exit game. They don't do anything if you click on them, but now we have that. Now we want to go back to the button because we need to make some function that will allow us to press the button, to click the button. So we're just going to check if it's been pressed, and we'll do the press doing on the main, in the main file. So here we can just do something such as check pressed, right? And in this will be a function, and here we can just put a comma. Cool. Now this will take in a self, a mouse, X position, so where the mouse currently is at the X position, the mouse Y position, so where the mouse is currently at the Y position, and in the cursor radius. So if we ever change the cursor size, we don't have to worry about changing it here as well. So cursor radius. Cool. Now here we can just create a basic if statement. So if mouse of the X position of the mouse plus the cursor radius is more or equal to self.button X. So let me actually draw that, because I think this will become a little bit more difficult to understand. So let me just go like this. So we are saying, let me just make this a good, easily seeable color on white. So this is our cursor, right? And this is our button. I'm going to say B for button. Now, if I go here, you'll see the mouse X position. Okay, so the mouse X position. And remember, this is our mouse. That right there is our mouse. But remember, our mouse, if I can just make this red maybe, our mouse is here in the center. That is actually where our mouse is. That's where the point of our cursor is. You might have remembered from the first video, where when we drew this, you would have noticed the mouse cursor thing. It's like that. So that's our mouse. Right there. Now, we go back here. There we go. We say if the mouse X, okay, so this is X, remember? So that's X, and this is Y. So, because remember, this can make a Y-ish shape. That's why this is Y. This is X. So if the mouse X position, let's go like that. So this is the mouse X, right? So, boom. The mouse X position, right there. Let's make that 32, for example. Right? Plus the cursor radius. So this part right here, this is the cursor radius. Because remember, a circle, whoa, not a good circle there. A circle has a radius. That right there, that's the radius of a circle. So take note, that term is very important. That's the radius. It's only half of the circle. So this right here. So this X plus the radius, and let's say this whole circle is 20, right? So the radius would then be 10. Because if the whole circle from here to here, if that whole circle is 20, and the radius is half of the circle, then it would be 10. That would be the radius. So 32 plus 10, that's 42. So we're saying if 42 is more or equal to the button X position. So let's say this button X position, which is obviously further than that circle. So that would be this button X position, which would be like this. This is the button X position. I should actually choose a different color at this point. Let's go maybe something like a bluish color. I hope everyone can see that. Yeah. Nope. Let's go like that. Okay. So this is the button X. The button X we can say is 62. This would then be false. Because here we're saying if it's more or equal to, very important. It's not more or equal to 62. It's 42. It's less than 62. So if we move our cursor, so the cursor is, let's say, like this. So you'll notice the end of the cursor is inside of the button. This would then, remember that's the radius, right? And this is 32. And let's say, I know, this right here, that part right there. So from this corner right here to this part right here is, let's say, 45, because remember, there's not like a lot there. So that's just 45. So 45. Then we can just add the radius to it to get back to the middle. That would be 10, so we can make that 55. Right? Now we can add the radius again, because we're at the center, or we could have just added this full 20. That would have worked well. But if we add the radius again, we'll get 65. So remember, this right here, that's 45. This whole length here, that's 45. Because that's just what number we made up at this point. And then we add 20 to get from this point of the circle to this point, or 2 10s to get 2 radiuses, because 2 radiuses makes one of the circle, because a radius is half of the circle. Very important to know. And then we get 65. 65 is more than 62. Thus, we are pressing the button. We are now pressing the button. That is what all of this math does. If most of this math went over your head, don't worry too much about it. You can kind of figure it out on your own as you play with this. But basically, if a part of the circle, no matter how big the part, but if a part of this circle we have goes over the button, this right here, that's the button, then we should say it's clicked. So that this is just for the X, right? Simple as that. Now we also need to do it the other way around. So if we go back here and let's actually, can we create a new, no, I don't know how to create a new one. Control N doesn't work. Okay, that's fine. Let's say we have this is our circle and this is our button. So this is button. Now we need to do the same thing. But if the circle does this. So we need to do the same thing. Because we need to take note. We should not press this button. We should not be able to press it if our circle is here and the button is here. Or if our button is here and the circle is here. We should only press the button when the circle is basically on the button. A part of the circle should be on the button. But if a part of the circle is not on the button, no matter if it's to the left or to the right, we should not click that button. Only if a part of that circle is on the button should we click the button. And oh, okay, it did make more. Okay, good to know. Good to know. So now we need to do the same, but the other way around. So I'm going to just put that inside of brackets to make it easier to read. And I'm going to say and, start another pair of brackets and just paste that in here. Now we want to minus the cursor radius here. And we want to say, instead of more than or equal to, we can say less than or equal to. And I recommend, if you kind of struggle viewing what we're doing right now, if you're kind of struggling seeing what's happening, draw it out. Drawing out math is probably the best thing you can do, because that's what we just did. And if that helped you to understand at least the first part, then that means if you draw it out for yourself, then you will be able to understand the second part as well. And in here we can just add width. So plus width. Self.width, that is. Now this self.width, remember, refers to the width of the button. So let me actually draw this again. So draw. So here we're saying, if the mouse X, so here's the mouse. Let's do this. Mouse X, right there. That's where the mouse X is. So let's say X is equal to 32, right? If that is less than or equal to this button X, right? So this button X right here, it starts there. That's where the button X starts, right there. Plus the button width. So it's going to be plus the button width. So this is where it's going to be. This dot right there, that side, that corner. If it is less than that. And we're minusing the cursor radius because we want this point. So if this point is less than this side right here, then this X right there, if it's less, then we want to do something. So if So let's make this blue. So if this part right here is past this part, so if it's more than this X location, because remember, X is just a position, and this red part right here is below this red part right here, then we want to call the button. This can be very confusing, and I myself got confused here, but this math is very important to understand because in all future games, this is how you can code a button. Anyhow, so I hope you understood this part. If you don't, you can still follow along without any problem, because believe me, I'm also trash when it comes to math. Cool, now we need to do the exact same thing, or we want to do it for Y. So here we can just change mouse X to mouse Y, right? And then we can do the same here. Button X, but button Y. And instead of width, we want to say height. We still keep the cursor radius, because remember, it's just a circle. Meaning, if we go from the center of that circle, and we add the circle radius, whether it be left, right, or up or down, then we'll get the edge of that circle location on X or Y axis, depending on which we choose. So it should still have the cursor radius. So if it's more or equal to the self.button Y and mouse Y minus cursor radius is less than or equal to self.button Y plus self.x or self.height, then, and take note, we're using height with Y and width with X, because width is left to right, height is top to bottom, just like how Y is top to bottom and X is left to right. That's why we use those two respectively. Okay, now we know the button is inside, or the cursor is inside of the button. We know that for a fact now. So we can just start executing stuff. So self.funcParam. So if a function parameter exists, if one was passed in, right, then we want to call self.func, and we'll do pass in self.func parameter, like that. Else, we want to do the same thing, but this time we just don't want to pass in a parameter. So if a parameter was not passed in, we don't care about it. And just like that, we have implemented a press operation for our button. Alright. Whew. That was quite a long one to do. We are almost at the end though, so don't get discouraged just yet. Cool. Now I'm going to create a mouse pressed function. So whenever the mouse is pressed, now you can do that within draw, within update, within load. I'm going to create my own entire function for it, which is possible with Love2D. I didn't do this in the tutorial because I kind of wanted to keep it for this tutorial. So if you don't notice this from the tutorials I had, don't worry, I did skip it for a reason. So we can just say function love.mouse pressed, and I find this to be a lot more powerful than the one we had in the tutorial. And you can just say x, y, button is touch presses. So all of these gets passed in for us. We get the X position of our cursor, the Y position of the cursor, whether the right button was clicked, the left mouse button was clicked, or the middle mouse button was clicked. I think there's probably support for other mouse buttons, like the ones you get on the side of some mouses and stuff like that. I just don't know how to work with them. And then we have is touch, so basically, is it a touchscreen? You know, so touchscreen mobile support. So is touch, and then presses, so how many presses, I believe. So basically if they touched with their finger, and here's how many times they touched, or how many times they clicked or whatnot. We are not going to implement touchscreen support in this game, because I think that's, I don't know, I just think that's something you could probably do if you wanted to, but it's quite a lot of debugging, especially if you don't have a touchscreen yourself. Anyhow, we can then just say if not game.state is running. Because remember, we don't really want the mouse to be able to click anything if the game state is running. The mouse buttons shouldn't do anything while the game is running. Then, so if the game is not running, then you're allowed to do anything in here. We can say if button is equal to 1, meaning if we pressed the left mouse button, so not the button that brings up this one, but the other button, the one if I click like this. If we click this button, then do something. So if game.state, so if it's the menu state, we want to specifically use the menu buttons. Then you go for index, and we don't need a value, and we can just say buttons.menu state. So we're going to loop for all of the buttons in the menu state. That's why we created it here, because we're going to loop for all of these buttons inside here to check if they have been pressed. That's why it's in the menu state, so only if it's the menu state. This is also to save a little bit of performance. We're going to say buttons.menu state dot, or not dot, we can just say position index. So that should be a dot. So buttons.menu state at this index. So let's say the play game button, for example. And then we want to just say check pressed for that button. And we want to pass in the X, the Y. And the X and Y is basically the cursor X and Y that we're passing in. And in the player dot radius. And the player radius is coming from here. There we go. The player radius, which in this case is actually 20. So yeah, that's the radius. It's half of the whole circle. Anyhow, so we passed that. So it's going to check if any of those buttons were pressed. So if I were to now run this, and let's try X again, because that's currently the only button that has anything implemented. And we actually get an error, but it worked. So button.lua at 17. Okay, so button lua at 17. Attempt to perform algorithmic on field height, a null value. So let's see here. Height, self.height, which is a null value. Oh, probably just spelled it incorrectly. There we go. Actually, I think height might be spelled incorrectly. I don't know. I can't grammar for the life of me. Now let's try it again. And it worked. Our game exited without any problem. Cool. Now let's quickly work on the start new game function, and then we're done. then we can turn it off for today. So I like to do that underneath. I don't know. Actually, I think I'll do it above load. And maybe I'll even put this mouse pressed right here. I'll put it above load as well. Why not? And we can just do that. Boom. Okay. Now here I'm going to create a local function. And I'm going to say start new game. Right? And then it doesn't take in anything. We can just say start new game. Then game.state at menu. Whoa, whoops, my bad. Yeah, at menu, right, then becomes false. So we're setting the menu state equal to false. And currently, because we only have the menu and the running state, we're not going to worry too much about the other states. But now we can set this running state equal to true, because we're starting a new game, so we should start running the game. And in here, we can also just create our first enemy as well. So this part right here, we can completely remove it and just move it up. So now here, we can just boom, like that. Now whenever start new game is pressed, we're going to insert a new enemy into our game, and we're going to set the menu state to false and then the running state to true. Okay, now let's actually just implement that here. So where it says nil, we can say start new game without the parentheses. Take notice, without the parentheses, because otherwise it's just going to execute before it gets passed in. And yeah, then one last thing. this is going to become more helpful later in the game, but we can just say if game dot state is running. So if the game state is running, then we want to do this. This is so the enemies don't try and keep chasing the player if the player is like in the menu or the game is paused or anything like that. Because believe me, it's going to be very funny, but the player isn't going to like that. That they can still lose while in the menu or something like that. Anyhow, so we just say they're only allowed to move if the player or if the game state is running. Cool, now let's try and play game. As you can see, not only does our player grow, but the enemies now start following us as well. That's pretty neat. So we did quite a lot in this tutorial. Well done if you're still following along. So basically, we created our first buttons. We implemented touch for those buttons. We implemented the drawing the buttons. And then we implemented the actual functions of the buttons. And that's that. So let's actually start with the enemy. Let's actually try and improve the enemy. So first off, I would like us to actually now receive a level. Now level is basically going to allow us to say what level every enemy should be. Because we can have 10 enemies in the game, like just coming at you. But the problem is, without the right leveling method, those enemies will just be kind of the same thing. Whether it be difficult or anything like that. So what we can do is we can go here where it says level, and instead of saying 1, we just make level equal to level. And just in case we didn't pass in a level, but usually you would be passing in a level. But just in case we were not, we can just say, or let's say 1. And you could also, if you want to make this underscore level instead of level to make it a bit easier to understand. Although I think this is perfectly fine. You can even rename this to be LBL instead. Alright, so that's all we're going to do here for now. We will be getting back to this later, but right now I think it's perfectly fine. You probably want to know how we're going to kind of get the enemies and stuff to come in. So I'm going to show you an example of what we will basically be doing. So here I have basically what we're going to be doing. So when we say play game, we will have a little scoreboard here that is going to count. And then once this scoreboard gets to a specific amount, like 15, it's going to spawn another enemy with a higher level. The higher the level, the faster the enemy will be. A good thing you might want to do is you might want to make every enemy a different color, maybe randomly generated or something like that. And then once the enemy touches you, the game ends. We'll later on implement an end screen or a game over screen and whatnot. But that's the basics of what we're going to implement. So we need to implement some sort of point system. Alright. So here inside of game, we can actually implement it here. So the amount of points we have, we can make equal to 0 at start. You could also put this inside of the player here. So then the amount of points the player has. But you could also make the amount of points there currently is in the game. So whichever floats your boat best. And in here we could say levels. And this will basically be whenever an enemy spawns. You can either have set levels like I am doing now, or you can have randomly generated levels, or levels at every specific interval, something like that. But I'm just going to have 4 levels, 5 if you include the very first level, and these levels will basically just be 15, 30, 60, and 120. So if you have these points, so 15, 30, 60, and 120, like that. So if the player has 15 points, then a new enemy will spawn. If they have 30 points, then a third enemy will spawn, because you have the first enemy, which is from 0 to 14. Then you have a second enemy from 15 to 29. A third enemy from 30 to 59. And then a fourth enemy from 60 to 119. And then the last enemy at level 120 and above. So let's implement the points. So here with new game, we can just say game.points is equal to 0. So this is basically whenever we start a new game, we're going to set the points to 0. And now with these enemies here, we actually want to do something a bit different. We want to go enemies. So we want to create an entirely new enemies table. So we're going to clear the previous enemies table. And we can just say enemy and then at level 1 like that. That means we can remove that line there because we have our enemy here. This will be the very first enemy at level 1. You can do it like this, or you can have it split up into multiple lines. So right here where we do the love.update, inside of the game state, or inside of the if game state is running, this part right here, we want to just say game.points is equal to game.points plus dt. So this will basically increase the points constantly, but with dt, so 0.016 or 0.032, however, so basically about every second you'll get 1 point. Now when we go down to draw, we can find a way to actually display this to the user. So here in if game state is running, we can actually put it just above enemies so the enemies can move over it. But you can put it below enemies as well. We can say love.graphics.printf, and this will print text to the screen. We can say math.fluor game.points, and this will display the game points but to the lowest value. So if we have 3.14, it will display 3. If we have 3.55, it will display 3. If we have 29.99, it will display 29. So it's basically like math.round, but just always downwards and never upwards. We can then specify a font, because with Love Graphics Print, you might notice we need to specify a font. So let's just say let's just copy this. Now we want it to be bigger than something like the FPS, because it has to attract more attention than the FPS. So we can make this about 24 instead of 16. Then here we can basically put our location, so 0, 10, and then we can tell it how long to span. So love.graphics.getWidth, and then we can also just specify center. So all of this does a lot, but basically you can think of it as displaying the text at the center of the screen. And I'll show you how this looks in a second. So let's actually try and run this and see if it works. So love. Alright, we say play game, and here it does. So it's here at the center of the screen, near the top, and yeah, it just counts about every second. I believe this 0 here is the X. So if we were to make this something like 90, and we run it, then you'll notice it's a bit more to the right. So the 0 is basically the X, and this 10 is basically the Y. Cool, and then this here just specifies you want it to be basically aligned to the center. Nice. Now before we get to the enemy, I would like to implement a better way to change the game state, because currently the way we change the game state, we have to constantly go around and we have to change a bunch of things manually, which isn't what we want. We want to make it as simple as possible, so in the future when we return, we never forget about something we might have to change if we change this value here, or if we add this here. Alright? So let's say local, and we create a function. We can call it change game state. I can take in state. Then here we can say game.state menu. So the game state is menu. Or we actually just make it state is equal to menu. So we basically say make game state menu. So true or false if the state passed in is equal to menu. So if we pass in menu here, it's going to make this value here that. And we can do the same for all 4 of our current states. So paused. And here we can say running. And in here we can say, and then we say ended. So we never have to worry about changing another game state, because here it will automatically make things true and false as we want it. So for example, here where we do this, instead of having to set 2, 3, 4, 5 states here, we just call change game state like this, and we want to set it to running like that. And that will just make our life so much easier. Since now whenever we change the game state, we don't have to everywhere we want to change it. We don't have to constantly basically be doing this. Because now we have a function. Let's make sure this works. So if I press play game, it should start the running state. And it does. Alright. So next up we should maybe work on getting if the enemy has touched the player. If the enemy has touched the player, the game should end because the player has lost, because that's the point of the game. So what we can do is we can go here to enemy.lua and we can implement a new function. Check touched. Now this check touched will contain a function, and this function will take in self, player X, player Y, so the player X and Y position, and then also the cursor radius, like that. And I did explain a lot of this in the previous tutorials, so I do recommend you go watch that if you have not, where I do explain a lot of collision detection math there as well. So now we just basically need to detect if the enemy is anywhere near the player. There's going to be some interesting math here, so just bear with me for a second. Math.square root. So SQRT for square root. And I'm going to create 2 brackets here so I don't get confused with mathematical operations, and so Lua knows what to do first. Self.x, so basically the enemy current X position, minus player underscore X, so the player current X position, to the power of 2. And I'll explain this in a second. Then you can say plus, and then another pair of brackets, self.y minus player underscore y. And we just say times, or to the power of 2, less or equal to cursor radius times 2. So basically, this math here will check if the player is inside of the enemy. So it's basically like the previous one, just kind of in one line to make it easier for us. You could split this up into multiple lines again, very similar to what we did here inside of the button check pressed. You could make it very similar to this. Not exactly like this because, one is a square, the other is a circle. But hint here, both of them are circles. But this will basically, in a sense of argument drawing app here, it will do this. So this is the enemy. This is the player. Whoa. Now in this scenario, so this is the game scenario, it would be false. Now our math will basically check this. This is the enemy. This is the player. Now that will return true. So it will just basically check if the enemy or the player is touching each other. Because if so, then they are colliding, meaning the player has lost. So yeah. If you want to know more about this math, I do recommend you do go maybe refresh up on some mathematical things you can do with circles, because this is one of the things that works with that. Alright, so once you have that, you have your collision detection. Now with your collision detection, we can finally do some coding to actually see it do something. So let's go here to the running state right here. So inside of this for loop, we're going to increase a few things here. So increase the amount of lines. So right here, we can say if not enemies at index I, and we're getting this right here. If not enemies at index I, check touched. And this check touched will just basically execute this math right here to check if the player is inside of the enemy. Then once you have this, you can just say player.x, player.y, player.radius. Because this check touched needs three things: player X, player Y, and then the cursor radius, which are all provided here. This will check if it is touched. So while it is not touched, as you can see there, because that has a not. So this will check if it's not true. So if this does not call true, if it's not being touched, then, and in here all of our things will happen. But let's first code the else, because this is a quick one. It's just change game state to menu. Later on, this will change the game state to ended and whatnot, but we don't really have anything for those states. So currently it will just change the state back to menu. And see, this is why this change state is so useful, because now we just call this and it will do all of the other background stuff for us. Now this enemies.move here, or this enemy move, we can move it there. So the enemy can move. So we can now say for I is equal to 1 in game.levels do. So we're saying for I becomes 1 in game.levels. You could call this something else even if you wanted to, because we have an I here. So you might want to call this something like J or K or some other value. And game.levels, and game.levels is right up here, so it's 15, 30, 60, 20. So we're saying for I equals 1 through that, we can go if math.floor, it again, this is to make sure we round down, game.point, and this is the points we have scored up until this point, if you can remember. And we can say if that is equal to game.levels at index I, then we want to say table.insert and enemies 1 and then enemy and game.difficulty times I plus 1. So what are we doing here? We're basically saying insert into the enemies table at position 1 an enemy that has the game.difficulty. So the game difficulty is basically being set up here, so it's 1. So in this case it's just going to be 1, but if you want to increase the game difficulty, then you can, times, in this case it's going to be 1 plus 1, which is 2. But if this I increases, this would be 2 plus 1, which is 3. And then this will basically increase the enemy difficulty or the enemy level as things go on. We did implement the leveling thing with the enemy in the previous video. I think it's actually in the 2 videos ago, not the previous video. So let's see here. And let's just search level. Yeah, there we go. So self.level in the move. So we did implement working with level, so we didn't have to mess with that now because we did it before. And then this is both to avoid bugs and to kind of tell the player, you have done this. We give the player 1 bonus point. So game.points is equal to game.points plus 1. So we gave them 1 bonus point as well as trying to avoid a bug. Because otherwise, this for loop is going to run multiple times. Because DT is going to take a while before it goes 1 full point, because it's like 0.016 or 0.032. So yeah, we have to be careful with that. So we give it 1 extra point so it can also break out of the loop. There are also other ways to deal with it, but this is the easiest way I find to go around it. Now once you have that, you can just save your game or your code and let's see if it works. Play game. Okay, so here is the first enemy. We wait until we get to 15 to see for the second enemy. And here we go. So now there are 2 enemies. If we are willing to wait to 30, we should see a third enemy. That is even faster. Yeah, as you can see there. And then once one of them touches us, we just go back to our main menu. And yeah, that is it for this tutorial. We just implemented a basic point system, and we implemented the basics of adding more enemies. Let's start with fixing something up first. Currently, we don't use fonts very nicely. Because if we want a set font that we might want to use over a large amount of spaces, this isn't going to work that well. Because we have to basically come back here, copy and paste or remember this number. That is why I think it would be best to create another table. And this table, we can say it's called local fonts. Now local fonts will just contain a few fonts for us. So medium, and this would be of course a medium-sized font. I'm not going to have small or extra small fonts. I'm just going to go medium, large and massive, because these are the different sizes that I'm going to use. Nothing is going to be really small. And I'm saying medium because the size of medium is going to be 16. And if you're a web developer, you know the default font size is basically 16 pixels. Anyhow, so we can say font is equal to, and I'm going to copy this font because it's basically just going to be this right here. So I'm going to paste that there. And then I'm going to say size is equal to 16. We won't really use this part too much, but it's more for future reference because sometimes you want to access the size of the font and not just the font. So it would be good to include the size. So if you ever want to know like the font size, like let's say you're in settings and you want to increase or decrease the font size, then the player can maybe choose between large, medium and small. And you can tell them the font size is 16 and then it's 24 and then it's 60 or what not. Cool. So that's just for future reference. Mostly it's not per se you're going to use, or not two sets you're going to use it. Now I'm going to have two more fonts here. One called large and then one called massive. So large will be, instead of 16, 24. And massive would be, instead of 16, it will be 60. Like that. So now we have a fonts table. So first let's go down here to where we draw, because this is mostly where we're going to use the fonts. Now we want to set the font to its default whenever we draw. This is mostly just because if we do set a font somewhere, then that font won't just stay there the whole time. And you'll notice when we get to the end game state that this right here will become quite important. So love.graphics.set font. So we're going to set a default font for every iteration, and it's going to be fonts.medium.font. So we're basically saying add from fonts medium, and then from medium we add font, and font is just this right here. That's basically the medium font. In fact, we can copy this and we can paste it right here. Boom. Now it's fonts medium font. So whenever we draw this, this will be the medium size. This right here, this would be the same, but instead of medium, it would be large. So this will be a large font. Alright, and that's currently all the fonts we really have. If we run the game, we should not be seeing any difference really. So as you can see, fonts still look the same. If we say play game, that's still the same size, and that's still the same size. Cool. Now I think it's time we start working on the end screen, the game over screen. So we'll need to create the buttons for this screen. So here with this state right here, this buttons, we can go here where it says menu state and we can make it ended. You can make this game over or whatever you want to call it. I'm going to call it ended state. So now we can have game over buttons. Now we can go to love.load right here and we can copy and paste this like that, and instead of menu state we can turn that into ended state. Now the first one is replay, so if you want to replay the game, so replay game. The second one is the menu button if you want to go to the menu, so we can say menu. And the third is exit game. Exit game will contain all of the normal values, so love, event, quit, and just exit game. This will contain menu, and here we want to pass in change game state, and the state we want to change it to is menu. Now take note, change game state was declared right here, where it just changes the state to whatever is passed in. And then of course we want our replay, so right here, replay for replay game. Yeah, we can make it full replay game. And in here we can just say start new game. Now currently we don't actually ever see the ended state, so we'll need to go here to update and we'll need to change this to ended. So from menu to ended. This will, instead of making it go back to the menu state where we see the menu, it will make it go back to the game ended state or the game over state, and we can see the game over screen. Then we can go down and we can copy this else if. We'll see, and like that. Now this else if will be, instead of menu, it will contain ended. Cool. Now I'm going to go love, or let's just copy this here, love.graphics.set font, because for the ended state we want to set the font to be something a bit bigger. So fonts.large, and this will make the fonts a bit bigger. This will allow us to basically everywhere within the game, while it's ended state, just increase everything with size. Then here we can go back up here and we just copy these three names here, and we can go back down and we can paste them here, and in here we can just make menu ended. So let's see what we can see. So when we run the game, what do we see? Okay, so we see this. It doesn't look great. We can definitely make it a bit better. For example, instead of having it here at the side, I think it would be better if we had it here in the center. And we of course have to resize it a bit, just make everything look a bit better. So first, let's try to center everything, because I think that would look best. So here, everywhere where I say love.graph, or where I say 10, we can say love.graphics.getWidth, and we can divide it by 2.25. Now this is a very specific value here. This value was actually calculated while trying to find the perfect way to center our buttons. Because currently we can set the button X and the button Y. And this process right here allows us to make the button more centered. If you have a different aspect ratio for your game, so if I were to just quickly run this, if your game wasn't this aspect ratio, which I think is 4:3, or it just actually looks like a square, it might be 1:1, but if it wasn't the same aspect ratio, the same size, then you will have to change these values here. Or you might have to. It's not maybe you won't have to. Maybe you're lucky. Anyhow, and in here where we say 20, 70, and 120, we can say love.graphics.getHeight, because this will be the Y position. We can then just divide that by 1.8, but that's only for the first one. For the second one, we will want to make that 1.53, because remember, unlike with X here, where basically all of them will just move here, all of them will now move top to bottom. So if you make this the same, they will all be at the same Y position. And if they're all on the same Y position, they're going to be stacked on top of each other. You can play with this a little bit if you want to see what the difference would be if you didn't add that and stuff like that. And in here we can say 1.33. Cool. Then for the last two ones, which would be the text positions, we can specify 10, 10. And then here we can just keep that 1710, and in here we can change that to 2210. This was quite a lot of changes, so let's first see what we have, because currently we did a lot of things. So let's see, how does our things look? Alright, so that's already relatively close to the center. The reason why it's further down to the bottom than what it is from the side is because we want to put our score here in the complete center. So this will be below the score. That is why it does this. And the buttons work, so if we go to menu, or they don't because we haven't implemented clicking yet, so never mind that. Alright, so let's do the points. Let's quickly draw that before we continue to the buttons. So love.graphics.printf, and we can say math.floor game.points, so we're going to put the game points for everyone to see. We can say fonts.massive.font, because we want it to be massive. We're going to set this to 0. Then love.graphics.getHeight, and we want to divide that by 2 because it's going to be kind of halfway. And then we also want to minus the font size, because remember, it's basically going to look like this. So if I can open up my drawing application, it's going to look like this. So this is our font, right? But you have to remember, so let's say that is the 0 character. But you have to remember, fonts are actually inside of squares, just like images. So this is actually how the font looks, somewhat similar to this. So when we do that, we're basically saying this. Now we have to minus the font size, specifically because the font still goes down. So if we minus the font size, it will go from here, but up until let's say this point here, because that would be the half of this font if we were to circle it like that or something. This might be a little bit confusing to understand, so let me actually show you. So instead of minusing it, we'll keep it like this for now. And then we can say love.graphics.getWidth to say where it should bend. And then we can just specify it should be in the center. Alright, once we have that, we can do this. Play game. And as you can see, the 1 is right there. And if we want this to be a bit more up, we'll have to minus the font size. So minus fonts.massive.size. Not the font, but the size this time, because we want to minus it by 60. Now if we were to run this, boom, our 2 is nice above the buttons. Now what I would like to do is I would like to go up here a bit to where we were here. And I'd like to change all of these 120s to 100 instead. And in this 40s to 50s. And let me show you why, because now it will look actually a bit better. So if we could just go like this, as you can see, it just looks a bit better. And I don't think this end game looks that great, and I don't really want the buttons to be too long, and I want them to all be the same length. So instead of exit game, let's rather say quit, because quit won't be that long. So quit. And actually, while we're at it, let's make this, instead of a replay game, we make it replay instead. And this will make everything nice and short, so when we get to the game over screen, everything fits into the buttons nicely. Alright. And that is actually just perfect. Next up, we need to make the buttons able to be pressed, because currently the buttons have nothing to check if they're being pressed. So here where we say if the game state is menu, we can say else if. And then we can do the same thing here where we say menu, but instead of menu we say ended. And in here we can just specify this. But this time, instead of saying menu state, we can say ended state. And everything else can stay the same. You could even maybe create a function that will replace this for you, so you don't have to do this every time. Anyhow, if we were to now run the game, our buttons will work. So if I were to end the game here, say replay, we can replay the game. If I say menu, we go back to the menu. And then if I were to say quit, we exit the game. And that is basically all for this tutorial. You will notice that the game is not quite finished yet. There's quite a lot of things you can still do here. And I believe the best way to learn is to do it yourself. I am going to bring out another course which will cover some of the topics I'm going to give as homework. So if you can't figure it out at all, once you watch that tutorial, you should be able to get a sense of how to do it. So let's first start with what we need. First of all, you'll notice if I were to just move this to the side a little bit, we have a paused state here, but we did not implement that paused state. Implementing a paused state is incredibly simple, and I will be doing that in the next tutorial as well. But currently, we don't have that paused state. I want you to try and implement that paused state. It's very, very simple, and it's probably easier than you think it is. Next up is the settings page. We have a settings button, but currently all it does is say this button has no function attached. This is a bit more complex, and there's a lot of ways you can implement the settings button. I want you to try and do it first. In the next tutorial, it's going to be your homework again, but I'm going to give you a kind of an example, a sort of, hey, you can do this. So you can try and do it here, and I recommend you do because it's quite a challenge. And if you do it right, then you have a perfect settings menu. Otherwise, you can wait till the next tutorial where I will give you a little bit of a push towards the right direction. I'm not going to implement an entire settings page, but I will show you kind of a way to get started with it. And next up is make the enemies more different. Currently, the enemies are quite boring. They're all circles, they're all pink, and that's it. There's nothing special about any of these enemies. In the next course, I will show you a basic way of how to make your enemies more different. So stay tuned for that if you do want to get the answers to this as well. But changing these enemies up to be a bit more different, like maybe making them, instead of circles, make them squares. That could be a great idea. Maybe start a scoreboard as well. So let's say you can have a high score, and then you can compete to beat your current high score. I'm going to show you how to do this in the next course as well. But I would like you to try and implement this here as well, because it can be quite difficult. Ooh, that's a fast one. It can be quite difficult to do. So I would recommend you try and do it on your own first. And hello everyone, if you're enjoying this tutorial, please leave a like and subscribe for future tutorials. So in this tutorial, we will be making a pretty cool game. The game's name is Asteroids. So here's an example. It's a little big. Let me just turn down the sound so everyone can hear me. So here we basically have a new game, settings, and a quit option. And we can say new game. We get started a game. It has fading text. It has a working high score. It has a score, and it has lives. You can shoot things, and you can go to the next level. And then there will be more difficult times ahead. You can crash, and then you'll lose a life. And you can shoot things. Now this may look incredibly simple, but it is pretty complex, with a lot of things working inside of it. Let me just go out of invincibility mode, and there we go. Then when it's game over, you have a fading game over screen, and if you have a new high score, it will save that high score, and then boom, here you go. So that is what we will be working on in this tutorial. For future reference, if you ever do fall behind, you can go to GitHub, and the link will also be in the description. But you can go to GitHub, Weebnetsu, YouTube project, and then in here, you can go to Lua and then the Love2D folder. Inside of the Love2D folder, you will have an Asteroid game folder. And in here, you'll have all of the tutorials, and you'll have some homework if you want to do it. Now, what do you need in order to start with this tutorial? Because some of you might be completely new. First, you need to know Lua. If we go Lua crash course and we search it on YouTube, then here at the top is my crash course, Steve's Teacher Full Lua Programming Crash Course. You will need to follow this course if you want to follow along. Of course, not all of the topics are necessary, but a lot of these topics are very handy to know about. And once you know this, it will be very smart of you to know a little bit about Love2D. So Love2D right here. And here we go. Now I recommend you know at least this one, and this one. And then I would also recommend you follow the previous tutorial, game dev tutorial, where we created the Save the Ball game. This tutorial covers some really basic items from Love2D. And if you follow the tutorial, then this tutorial that we're going to do now will be a lot easier to follow along. First, we need to create a folder for all our things. So I'm going to go to Documents, going to go to my trash, and then I'm going to create a new folder and call it Asteroids. I don't know how to spell asteroids, but I hope that's correct. Cool. Inside of this folder, and you don't necessarily have to do it in your trash folder. I just have a trash folder for tutorials. And inside of this folder right here, you can create a new file and you can call it main.lua. Now once you have created a file, you can open up VSCode in here. I wonder, can I open up? I can't open up from here. Anyhow, I can go here to my terminal, but you will probably have an option to go here and just right click and say open in VSCode or whatever code editor you use. We can then just say code dot to open up VSCode here, and you should see something similar to this. We can close this folder here because we won't need it. Now take note, you do need Love2D installed and Lua, so if you don't have those two installed, I do have a tutorial at least on how to install Lua. Then here we have our main.lua. If you also use VS Code, you can get the Love2D extension right here. And you can also get the Lua extension right here. And you also do Lua debug if you want, but this is unnecessary. It will probably auto-download anyways. Anyhow, now that you have that, everything is ready to go. Let's just set up a basic project. I think for today we don't have to go all out. So just local love is equal to require love. This is an optional step. You don't have to do this, but it is optional. Then we can create a function. We can call it love.load. And it's just a basic Love2D setup. And we can create two more functions for update. I almost said delete here, but this should be a draw. Now since we're starting off very basic, we're not going to do a lot. We only want to get everything up and running and maybe make sure everything works. If I were to run this by saying love dot, and you can also use the VS Code inbuilt terminal by going to terminal, new terminal, and then you will have the same thing as what I have. And you can just say love dot here as well. This is the same thing as what you just saw here. I just like this one more because it looks cooler. And then you'll see this. Pretty neat. We can then create a new file by clicking on this file icon here, and we can call it conf.lua. And here we can just say local love is equal to require love. Yet again, optional. You don't have to import love. Now you can say function love.conf to set up the config file, pass in the app, and we can say app.window.width, and you can make it any width you want. But I am going to make it equal to 1280 or 1280. Then as for the height, app.window.height is equal to 720. For some of you, this might be too big. So just for reference, this is a 16:9 aspect ratio we're working with. As long as you work with the same ratio, you don't have to change too much. For example, a 1080p resolution, this is 720p, but 1080p would be 1920 in width and then 1080 in height, as an example. This would be bigger, of course. If you want to go smaller, it should probably be around 480p, but you can Google a 16:9 aspect ratio smaller than this. And of course, we want to set the title, app.window.title is equal to Asteroids. And then lastly, we want to say app.window.display equal to. Now, take note, not all of you will benefit from this display I'm using here. I have two monitors, the one on my left, which you cannot see, and then the one on my right, which you can see. However, I don't want the window to spawn on my left monitor, which is probably display 1. I want to do display on this monitor. So let's see, does everything work? And it does. It's big, boy, and it has the Asteroids title, and it spawns on this monitor. So this one here is optional. These are also optional, but I recommend using them because why not? As for the window width and height, I recommend 16 by 9, smaller size if you want, but if you don't want to change the window height and width, then you don't have to. First thing I want to do is I want to hide my mouse. So when I'm here, the mouse should be gone. Now that's pretty simple. To do that, we can go here and say love.mouse.setVisible, and we can just go false. And this will set the mouse visibility to false. Now for future reference, we're not going to do that in this tutorial, but it would be smart to set our mouse X, mouse Y equal to 0 or whatever you want to here. So these will be two global variables containing the mouse X and Y positions. This is for a future reference, so you don't have to put it here now, but I do recommend you do, because then we don't have to worry about it. And then next up, here in the update, we also want to set the mouse X and Y. So I will actually just copy this, paste it here. And then here we can go love.mouse.getPosition. And this will return the X and the Y position of the mouse. Both of these are global scope. So if you wanted to, you can go _g dot, and that would be allowed. But for me, here I'm just going to say quick fix. And if you're in VS Code, you can choose one of these. And I'll just go here, disable diagnostics for lowercase in this file. Or even in this workspace could work, but I'll go file. And it will add this where it doesn't show that errors underneath these. And then last but not least, before we continue, I would like to set the show debugging equal to true. And this will basically say if we want to see debugging items. Right now we're not going to use it, but we will later. If we run this, you can see I can no longer see my mouse, but if I move outside of the screen, you see here, there's my mouse, but if I go in, it's gone. That is what we wanted. Cool. Now we can create the player. To do that, we can go here and create a new file called player.lua. I'm using a capital case P just because I believe objects, or at least other files, should use capital case P unless it's the main files or the core files going to be used by Lua, like the conf or the main. Cool. Now the player here will be an object. If you don't know how to work with objects in Lua, I do recommend you go watch my objects tutorial I have on this. Then you can go local love equals require, and then love. And if you want to, you can copy this and you can put it in here. Take note that this diagnostics only works if you're in VS Code. If you're in a different IDE/code editor, then this may not work. Now we can create a function, call it player, and player will take in whether the player is busy being debugged, so debugging. So if we're debugging the player, then we want to see some extra information. And then at the end of the file, we can say return player. Nice. Now, some variables you might want to set at the start will be the ship size. These will be constant variables that will never be changed, so they are capital case. And we won't want to access them outside of this file, so we're not putting them inside of the return. We can make this equal to 30. You can change this, but this will basically determine the ship size, because this would be from the left side of the ship to the right side of the ship. Then we can go local view angle is equal to math.rad90. To get an example of what this does, because it transforms degrees into radians, because we want to use radians and not degrees. So to understand what we'll get here, we can go here and say Lua, and then say math.rad and then 90. And that will give us 1.57 radians. So yeah, we're going to use radians, not degrees. Just keep that as note. So this would be 1.57 radians. And it's all to do with math stuff, so don't worry too much about it. Then here we can say debugging is equal to debugging or false. So if we do not pass in the debugging argument, then by default it will be false. That's what we are saying here. Now return is what we want to get back, what we want to be able to access within this whole thing here. So x will be the player x position, which is love.graphics.getWidth divided by 2. So we want the player to be positioned in the center of the screen once the game starts. So that's what we're doing here. We can then do the same for y, and then y instead of getWidth would be getHeight. So now the player will be positioned in the center of the screen. Then the radius of the player, and this will kind of be like the hitbox of the player. So the circle around the player, if that circle is hit, what happens? Anyhow, so the radius will be the ship size divided by 2, and then the angle will be equal to view angle. So the angle by default will be 90 degrees, meaning the player will be facing upwards. How do I know that? Because the player will be a triangle. If you've seen the demo of the game in the first tutorial, I showed you that the player itself will be a triangle that moves around. And if the angle of the triangle is 90, in terms of degrees, and the radians 1.57, then it will point upwards. Cool. Then rotation will be equal to 0, so this is if the player has been rotated. Then thrusting will be equal to false. If the player is thrusting, that means we want to move, because he's thrusting, is blasting out fire and stuff, which we won't code in this tutorial, but we will code later. And then the thrust itself will be equal to the x 0 and then the y 0, and I'll explain what all of this means later once we get to it. And then the speed 0. Cool. Now this currently won't do anything, so let's draw the player to the screen. So underneath this thrust, we can just create a function called draw. This will be a function that takes itself, and then here we go. Now local opacity is for future reference, but basically this will determine how visible the player is to the screen. So if the player is on the screen, can we see the player or not? Next up, we want to say love.graphics.set color and then 111, and this means white. And we pass in the opacity, which is also 1, so it means it's completely visible. To draw the player, we can say love.graphics.polygon, and in here we can type in a lot of things that will draw the player. First of all, we want to draw the player as a line, not as something that's being filled in. So we can say line. So it's going to draw lines. Then we want at least 2 items to draw that line. So let's go self.x plus, and this will be a little bit of math, so bear with me. And we have 4 divided by 3, and note I'm using 2 brackets here. This is just for me to know, okay, I want to do the division first. The computer will know, let's do division first. But I want to know as well, let's do division first. Because when it comes to math operations and when to execute them, I am still a little bit junky on that. And you can say times self.radius. Take note that this is not inside of these brackets, inside of this bracket, but not inside of these brackets. Because we want to execute this first. So 4 divided by 2, and I think this should be 3. And I'm going to explain this in a second. And then times the radius. And then once that has completed, we want to times that by math.cos self.angle. Now the 4 divided by 3 is mainly to find the center of the triangle. Next up, here we can say self.y, so we can copy that line, say self.y, keep everything the same. And in here, instead of saying cos, we say sin, because we want to go the other way. So let's create the player and hope for the best. So then here we can say local player, capital P, is equal to require player. And there should also be a capital P, because the file has a capital P. Then down here in the loading section, we can say player lowercase p is equal to capital case P player. If you don't understand what I'm doing, I recommend you to go watch my course on OOP in Lua. And then we can also pass in show debugging. So this will create this little object of player that we can use and get data from. Now here we want to just see the player. So let me just draw player colon draw. How can I use this? Because right here we export the draw function. It's inside of return, and then it should draw the player for us. Now if we were to run this, do we get? No, we don't. It needs at least 3 vertices to draw a polygon. Oof. Okay, so we'll have to draw the whole thing, unfortunately. But okay, not a problem. So since there's a lot of typing, I'm just going to paste this here, and then I'll walk you through it. So basically, here we have what we just coded, and in here we say self.x minus the radius, right? Times 2 divided by 3 times math cos self angle. So first we're going to times this because BODMAS. If you want to make sure of that, you can do that. Anyway, so we'll first times these and then we'll add this to it. And it's going to be the same all the way around for x and y. The only things that change is when sin and cos is being used. And yet again, I didn't quite understand this math. It was a 1 a.m. thing, so just excuse me if I don't quite know how to explain this. But you can play around with it if you want to understand it more. I don't really want to understand it more because it breaks my brain not understanding it, so I'm scared of understanding it. Anyways, if we try and run it now, aha, here we go. Doesn't quite look like the player. So let's see, what went wrong? Oh, you know what went wrong? Here we should minus it, my bad. Now, if we run this, we'll get a triangle. Cool. If you want to actually test it out for yourself and see how it looks, what you could do is you could run Lua and then open up a drawing application. Okay, now there is our x position and our y. So x would be side to side, as you know, and y would be up and down, as you also know. To remember this, you can remember y has like this little finger goes like that, and you can add arrows here to specify up and down. That's how I remember which one is x and which is y. Anyhow, so there's our center. Then what we can do is, let me just do that. So first we get our self.x, and let's say x itself is equal to, what is it? Okay, let's make it 20 or 200 because that would be more realistic. So 200 plus, and since we know this isn't going to execute yet, let's first go 4 divided by 3. 4 divided by 3. That's 1.333. So 1.33333 times, and then the radius, as we already know, is, let's see here, ship size, that would be 15 because ship size divided by 2. So the radius would be 15, so times 15. So this right here is basically 20. So that's 20. Then we times this with math cos and then the angle. And this is why we used radians right here and not degrees, because if this was 90 degrees, then this would be way off. So we are using radians to give it a much smaller value to work with, because 90 would be pretty big compared to 1 point something. Anyhow, so then we can say math.cos, and then in here we can specify the angle, and the angle, as we know, is math.rad90. So math.rad90, like that. Okay, so we got our values. Now we have to times these two together. So 19.99999 times 6.1232339, I believe. That will give us this right here. And then we can add our self.x, which would be 200. So this value right here plus 200. Now that we have that, we can see where the next dot will be drawn on the x-axis. So here we have our x, and this right here, that's 200 to the x. So that's 200. Now the next one will be 322. So that would be even further beyond. So that would be like here or something. And not downwards, it's just the x part. So like it would be like here or something. There. And this is where this one is. And you can just imagine that these two are 120 pixels from each other. Now with the y, it will position this one downwards. So you can use this to kind of figure out where everything goes if you were to do the math like this. This is at least how I can understand math. So if I want to spend the time, this is how I would understand it. So we can draw the player. That is good progress. We can't do anything yet, but we can draw the player. Nice. Now, we still have a debugging option. So let's quickly implement that. So right underneath opacity, we can say if debugging, then, and here we can say love.graphics.setColor. And you can make this any color that is not white or black. So 1, 0, 0. Because black is the background and white is the color of the ship. So making it a different color will make it easier to see. So in this case, I'm making it red. And then love.graphics.rectangle. And we want to actually see the center of the ship. This will just help for debugging, for when we try and move the ship and the ship maybe doesn't move, but the center moves or something like that. And here you can just say fill, and then self.x minus 1, self.y minus 1, 2, 2. So this positions it in the center, and I'll show you in a second what this means. So if we do this, as you can see, we have a little red dot in the center of our ship. The reason I said -1 for the X and the Y position was because if I didn't, we'd be getting this. And as you can see, it's a little bit off from the center, and we don't want that. And the reason for that is just because of how we draw. So we add -1 to avoid that. And in the 2 is just the size. So if we were to change this to 4, for example, then now we'll get a bigger circle. And now we'll have to change it more to the side because of the size here. So this will now have to become -2, -2. So the more you increase the size, the more you have to move it back. Because you have to remember, if I were to open my drawing app again, if we have a square like that, this is the X position of the square right here. So right there, that's the X position of the square. And we are drawing a rectangle inside of the player. So we need to minus this to the X and minus to the Y to bring this to the center of this square, if you understand what that means. Anyhow, so let's just change back that to 1 and to 2. And then next I want to draw the collision of the player. So when we try and collide with other things, we can see where the collision would affect each other. So love.graphics.circle, and here we can say line self.x, self.y. We can say self.x and self.y because the x and y of a circle is in the center of a circle and not at the side of a circle. And then self.radius, so the radius of the ship itself. If we run this, we get a circle around the ship. Now this circle right here is basically the collision. So if anything touches that circle, it's touching the player. You might think this is pretty basic and it is moving things and it isn't quite accurate, but believe me, this does decrease the amount of math we have to do, and you'll thank me for this later. Alright. Now, whenever you don't want to see that, you can just turn off the debugging by passing in false here. Cool. Now, let's move the player. Because currently the player isn't moving at all, and we can't move the player even if we wanted to. So let's create a function, and we can call the function move player, or just move. Both will work perfectly fine. We can then say function that takes in self, and then local FPS. So this will get the FPS of the game. So this isn't the best way to say how fast the player should be moving. And we could possibly change this in the future to be a better way. But for right now, saying the FPS will be the easiest way. So you can say love.timer.getFPS. And we can of course scroll a bit down. And then we want to set the friction. And the friction will just basically say how fast the player should stop moving. So let's go here and say local friction, and we'll play around with this because it's pretty simple, is equal to 0.7. Now we need to set the rotation speed of the player. Now I want the player to be able to turn a full 360 degrees, so completely around within a second. To accomplish this, we can say self.rotation is equal to 360 divided by 180 times math.pi divided by FPS. So first, there we go. So first it will execute this and it will get the value of this. So Lua 360 divided by 1080, that's 2. Then it will divide these two. So math.pi divided by FPS. So math.pi, and we can assume we'll be getting 60 FPS. So that's 0.052. So that's 2 times 0.05235, like that. And that should be a times symbol, not an and. And they will get this value right here. Now this value right here is basically how much the player will turn every second. Cool. Now let's actually use that because I think it would be easier to understand if we use it. And don't worry too much, there won't be that much math in this course. It's just the first one has quite a lot of math because we're using a triangle and whatnot. So you don't have to worry too much about the math. We want to basically say when the player should be turning left and right. So to do that, we can go here and do a quick fix to that and say love.keyboard.isDown. And we want the player to turn left whenever they click on the A button. And you don't have to add these extras, but I like to add options. And we can say, or if they press the left button on their keyboard. So that's like the left arrow on your keyboard. Or if they press the KP6, and that's the numpad number. See, and that shouldn't be 6, that should be 4. So that's numpad number 4. So if they're on the numpad, they press 4, then the player will also go. So now they have a lot of options to choose from. You don't have to add this many. I just like to. And you can say self.angle is equal to self.angle plus rotation. So every time this runs, it will add this to the rotation. So it will add 0.1047 to this right here, and that should be self to the angle. So the angle will change every time, and as we know, the angle is in radians, so we need a small value, which we got here. As you can see here, we got 0.147, and we add that to this, and you'll see it working in action in a second. We can then copy this, and we can then go here and say D if they want to go right, and then right for the right arrow key, and then KP6 if they want to go right. And in this one will of course be minus. Cool. Let's test this out. So if I were to run this, and of course we don't do anything yet because we have to go here into the main file and we have to say player move. So right here, player move. So it should execute this every time this update runs, which is like a lot. 60 times a second, in fact. Run this. You'll notice I can now rotate. So that's pretty cool. And it takes me a full second to do a full rotation. Now, of course, if your FPS fluctuates like you have 30 FPS, then the player might actually rotate faster than a second. So that's why I don't like using the FPS. But for right now, that's the easy way out. And we don't really use DT at the moment, but we can later. Nice. Now let's add a movement so the player can move up and down. Now we were not going to add the keyboard bindings for this in here. We're going to do it out here. The reason for that is because we will be using that for more than just the player. Anyhow, so then we can go if self.thrusting, and we set that up here, which is just true or false. So if the player is moving, or if the player is trying to move, so if they press W, the thrust will be true. Then, and here we want to start moving the player. So self.thrust.x, and this thrust.x is set here, is equal to itself. Whoa. And then we can go plus self.thrust.speed, and we get the speed from here, which is 0. And it shouldn't be 0 now that I think about it. It should be 5. You know, you should give it at least some speed. So the faster you make this, the faster the player will move. So the higher this is, the faster the player will move. And here we can say times math.cos self, and this is just to kind of nerf the speed, and we can actually remove this in a second, and then divided by FPS, and then we can copy that again, and this time for Y, and then we still everything the same, but here we can go minus, and then we do sin, and there. Now currently won't do anything, so let's try to implement that. So right here, between the load and update, we can say function love.keyPressed, and we can say key, and this will allow us to add a key press. Then we can say if the key is equal to W, or, and now we can add a bunch of extra options. Yet again, you only need to add one. I just like to give choice. And here we have 3 options. One that will be the up arrow on the keyboard, and then KP8 for 8 on the numpad. If it's one of those 3, then player.thrusting equals true. So it will make the player thrust. If we play it, we don't really get anything. And the reason for that is because we're not applying this thrust. We should apply this thrust to the X position. So self.x is equal to itself plus self.thrust.x. So you should apply the X amount of thrust to this. So let's just copy that and do the same for Y. Now if you run this, as you can see, he moves, but he just kind of moves out of the screen first of all. And as you can see, also just constantly speeds up. That is because thrusting is always on. Now it would be even worse if we were to remove this right here, because that nerfs it a lot. So let's go here. And now if we were to run this, as you can see, he moves up super fast, and even optionally in the wrong direction. But yeah, so this just nerfs it to be slower and moves to the correct direction. Alright, and you can play around with that. Next up, we need to be able to slow down the player. So else, then we can go if, and you could make this an else if you wanted to, but I like to just go else and then if inside of it. Self.thrust.x, if that is not equal to 0. So the thrust x is still running. And the same with the y. So or, because if the thrust x and y is not 0, that means thrusting is still continuing. And we're going to go here also not 0, and that should be y. Then we should decrease it until it becomes 0. So self.thrust.x is equal to self.thrust.x minus friction times self.thrust.x. So the higher this friction we set here, as you can see there, the faster the player will stop. And of course divided by FPS. And we can do the same for y. Cool. Now let's implement that. Because currently when we press the key, we set the thrust to true. But it doesn't do anything after we set the key. We should actually tell it to stop thrusting at some point. So let's go here. So if the key, instead of pressed, we can go key released. And this means once this key is no longer being pressed, so being held in, we want to turn this to false. Cool. Now we can run this. Let's see. And as you can see, he moves much slower and he actually stops. So if I go like that, he will stop at some point. Now just to give you an example, if we were to go here to friction and up that to, let's say 1.7 and then go, then as you can see, he stops a lot faster. So the player now just almost immediately stops because the friction is so high. If you want to do the real space game, you can make the friction something like 0. Now, it will always just move forward. And this is how Asteroid actually is. The player never actually stops. So this friction just says how fast the player should stop moving. 0.7 I found to be a fairly decent value. It's not too fast and it's not too slow, but anywhere around that will work. Cool. The last things we need to do is we want to reset the color. So if any color changes happen, we want to reset it. So love.graphics.setColor. and then 1, 1, 1, 1. So it's all visible and it's all white. And then of course, we want to actually, just for debugging purposes, show the FPS. So love.graphics.print love.timer get FPS and then 10, 10. So it will print the FPS right here around the top. Now if we run this, we can also see your FPS. Comment down below what FPS you are getting. And yeah, that is that. We added the player and the player can now move. So we have this. Oh gosh, my bad. That's a bug we might want to fix. Okay, there we go. You see the player moves. And the player stops at some point as well. We should also at some point just implement something here so the player can't go off the screen. But yeah, and that's that. Thus, we are now going to be working on this right here. A little thruster that animates and moves up and down. Basically showing you that you are basically thrusting yourself through space. So we'll be implementing that today. At least it's not as much math or massive blocks of code as in a previous tutorial. So no need to worry. First of all, we can close this main.lua. We'll be focusing mainly on the player. Cool. Now I would like to add 2 more attributes here to thrust. First, I would like to add big flame. And the big flame will basically determine when we change our flame size. We'll make that false by default. And then also flame and then 2.0. And this will just help with the animation of the flame, where it goes from big to small and from small to big. So that will just help with that. So first we need to actually draw the flame. So let's create a function for that. So right here we can say draw flame thrust. Now you'll notice in the code I will give you, you will see this. But I actually want you to, instead of going underscores, go camel case like this. I am not going to do this because I am following a script and I can't really change that script now. It's a little late. However, you can still change it. Why do we do this? Because this one here is using camel case. This here is using camel case. This here is using camel case. So we want to basically stick with everything using camel case, except for, of course, these constants. Now I've already scripted it, so we have to use this, but you can still change this to be camel case. I just accidentally messed up. But that will be a function, and it will take in self the fill type. So this will basically say how we're going to fill the thrust on the ship, because this will basically automate a lot of the drawing process for us. And then as well as the color. Now we can actually take this and we can copy that and paste it here, and of course add a comma here. And we'll get to editing this in a second. First we want to set the color. So love.graphics.setColor to color that was passed in, because we will draw more than just the inside of the flame. We'll also draw like the outside of the flame, so we'll need to set the different colors and whatnot. And in here we specify the fill type, which can be either fill or line. So when we use this function, it will either draw a line or fill it for us. Now this will change a little bit. So here we can say self.x minus self.radius, because this will have to be an upside down triangle. So self.radius times, and it's basically going to be the same in most regards. So 2 divided by 3, a little bit different, but still relatively the same. Just instead of 4 divided by 3, we're using 2 divided by 3, because now the triangle tip will be at the bottom and not the top. So we say 2 divided by 3 times, and we can take this math.cos self.angle and paste that there. And we can say plus 0.5 times math.sin self.angle. Now you're basically throwing the thing on its head, so don't worry too much. And we can copy and paste that. So now we have self.y, and instead of minus, this will be a plus. So plus, and we can remove that plus there. Then it's a self.radius, and this should be times, not that, so times 2 divided by 3, then math, and instead of cos, this will be sin for sin, and then this will be cos. So we're swapping those two. And instead of plus, it will be minus. Then we can copy these two. Actually, we can just copy the first. We can paste it here. And this should be downwards. Then it's self.x minus the radius times, and this time we want to basically set the flame of the thrust. So right here, that will help with the animation. This will basically draw the flame a specific size. We can remove this whole part for that. And in between these, we can say self.thrust.flame, like that. And why did I do that? Let's copy that. And then here we can just replace. There we go. And this will be cos, not sin. We can then copy that and do the same for y, but yet again just invert everything. So minus will become plus, and then we're good to go after we turn cos to sin. And then we can copy these two and we can paste them here. Now they will basically be the same thing, but this time we just go from plus to minus and from minus to plus. There we go. That should theoretically draw our flame thrust, but we haven't tested yet, and that's quite a lot of math to draw a polygon. Luckily, this should be one of the last polygons we draw. Not the last, but one of the last. Now, we can go to draw. Now, we only want to basically show the thrust when we are moving forward. So did we include? Yes, we did include thrusting. So only when we move forward do we want to show the thrusting. So to do that, we can go if self.thrusting, then, and then here we can draw everything we need for the flame, of course. Now we need to check, is it a big flame or is it a small flame? Because we can have two different flames, a big one or a small one. So we can go if not self.thrust.big flame. So we're checking if it's not the big flame, so if it's the small flame. Then we say self.thrust.flame, and you can find all of these right there. And we can make that equal to itself minus 1 divided by love.timer.getFPS. The getFPS is just to basically give us a bit of animation. So in this case, it will be -1 divided by 60. And this will just allow us to resize it for the animation. And remember, this draw will basically also run once every frame. So you just have to remember that as well. That's how we can get this animation rolling. And then let's leave that there for now, and just say self dot, or not dot, but colon, draw flame thrust. First, we want to say fill because we want to fill it, and next we can draw the flame color. In this scenario, you can even make the flame color change depending on its size. That's actually a cool feature you can add in the future. But for right now, I'm just going to give it a static size or a static color. So 255 divided by 255, then 102 divided by 255, and then 25 divided by 255. and this will give us an almost red color. Now if we save this, I wonder if we'll be able to run it. Attempt to index field frost a nil value. So let's quickly just comment this out before we continue. And as you can see, we have a flame. It's not really animating, but we do have a flame. And that's basically what we are drawing. And it only appears when we're moving forward, so when we're frosting. So that right there, if frosting. Cool. Now let's draw the outer line of the flame before we continue. So self, draw, flame frost, and instead of fill this time, we will say line. And now you'll notice why I did it like this and not just put it here, because we're going to use it 2 times. So why have that code twice when we can have it once? And then we can set the color, and this time just to give it some variety, but usually you should stick with one type. So if you're using RGB like that, then you should keep it like that. But this is just to show you, you can have multiple. So 1, 0.16, and 0. Now if we were to run this, you'll notice it has a little bit of an outline. Not very noticeable, but it does give it a nicer feel. Cool. Now we can start resizing it and making it feel pretty cool. And here is basically where our problems began. There should be frost, like that. So I kind of messed up the spelling there. Now if we were to just run this, you'll notice the flame just kind of goes weird, because this resizes the flame. That's actually kind of cool. That's like a sword. I like that. Anyhow, so this basically resizes it to become smaller, because if we're saying big flame, we want it to become the bigger flame. Now to make that happen, we can go here and say if self.frost.flame is less than 1.5. So if the size has gone to smaller than 1.5, then self.frost.bigFlame, because we want to make it start giving the big flame. Why do I constantly, did I misspell this somewhere? No. Frost, there we go. And then big flame equal false. So basically, once we reach a certain size, we want to start growing the flame. So we're making big flame equal to false. I mean true, not false. Because we want to start changing the big flame, or to the big flame, so it can start becoming bigger. So now if we start flying, you'll notice at some point it stops shrinking, because we're not calling that anymore to make it continue shrinking. Because of this right here. Because we only run this if this right here is false. In this scenario, it's true, and by default, it's false. Now we need to do the opposite to get this to grow again. So we can say else, and there shouldn't be no colon, this isn't Python. And now inside of this else, we can copy this, just paste it there. And now instead of going -1 to decrease it, we should +1 to increase it. And remember, we're dividing it by 60, so it stays small, because 1 divided by 60 is pretty small. If we go here, and 1 divided by 60, there you go. So it will basically increase with this amount. Of course, you could put a specific value in here, but this will also make it grow/shrink depending on the FPS. Not the best way to do this. I would recommend instead using DT, but we can maybe try that later. And in here, instead of 1.5, it should be 2.5, and then false. So once its size reaches 2.5, and it should be more, not less than, then we should turn this to false, and it should start doing this one again until the flame is a specific size, a small size. Then we change back to this one, and we're doing that toggling with this right here, setting to true or false, and in here we're checking if it's true or false, and then executing depending on the size, or depending on if it's true or false. Now if I were to run this, you can see it now grows and shrinks. Now you can make it grow and shrink less. It's up to you how much you want it to grow and shrink. To me, I think that's a nice amount to grow and shrink, but you know, everyone's eye will be different and feel different about it. Now, one thing I also want to do, because that bothers me quite a lot, when we move this ship like this and it goes off screen, I can't get it back. Unfortunately, it is now gone forever. I don't know how to turn that ship around and get it back the right way. So what we should do is we should implement something to fix that. Now to do that, let's go all the way down to right underneath this, and we can say if self.x plus self.radius is less than 0. So self.x plus the radius. So let's actually open up my drawing app here, because this I can't explain. Pretty simple math. So here's self.x, right here in the center of the circle. Now the radius would be from this part to this. So let's actually draw a bigger circle. So here we go, and then there. Now the radius would be from here to here. And you might be wondering why I'm drawing a circle. The reason for that is, as you can see, the collision detection. It's a circle. This also allows us to get this right here. Now if we say plus, it's going to add these and give us this position right here. So let me actually mark that in red. This position right here. Now when this position goes off screen, so if this point right there goes to behind this here, so off the screen, where we can't see this at all anymore, we want to make the ship come out from this side. So now it's going to come back here. So the ship will start flying here. Imagine this is the ship. Because the ship's radius no longer on the x-axis can be seen, so we can just as well bring the ship in. If you want to make it more complex and you think you have the guts to do that, you can make the ship start getting drawn once it has reached halfway, or even make the ship get drawn immediately once it reaches in here. But that's some math I do not want to bring into this video. Anyhow, so let's do that. So I can say if, oh wait, we already said the if statement. So self.x, and we now have to change it because it went away here. So we now have to make it come back here. So that will be equal to love.graphics.getWidth. And we say this specifically because remember, the window plus its width is this part of the window. So it's going to be the end of the window. And then we add plus self.radius. This just makes it look more natural once we get here, because then we'll come in more naturally instead of just boop appearing. But of course you can make this more complex and make it work cooler. So let's see if that works. Oh gosh, that's a weird bug. Anyhow, here we go. Ready? Oof. Get width, cannot call it. And that should be a dot. My glasses obscure my vision. My bad. Now if we try it, let's see. And there we go. It looked normal. The reason it looked normal was because we made it only start appearing there once we've reached with the radius. So it will add the radius to it and then it will appear. So it will look more natural. But of course, if you were to remove this, then it wouldn't look as natural. It would just kind of plop into view. So if we go here, pop, it looks natural, but it still pops into view. So it's not like it's animated or anything. It's just pop. So it's not the same. Anyhow, so there's self.radius. Now we need to make it do the same for all of the sides. So we did this side, but we need to do this side as well. So we can just say else if, and we can specify self.x minus self.radius. We're minusing this time because here we have our ship and here's the port. Now we're minusing the x, so it's going to go here. So this is where we're checking now. And now we're going to check once it goes out of the screen here, if this part is no longer in the screen that we can see, so in the window, it's going to start appearing here and the ship will start flying here again. So it's the same thing, but this time we check for this side instead of this side, and we check for this side specifically where it comes in here instead of the other way around. With this map, I highly recommend playing with it, because believe me, it can boost your understanding of a lot if you play with it. And since we know this gives us the end of the window, we can just go if it's more than this. And now we can just copy this self.x, and actually we don't even need to, we can just say self.x is equal to negative self.radius, because here we added the radius, but now it should be 0 minus the radius. So you could say 0 minus self.radius, but that wouldn't make a lot of sense, since by default negative radius would be, so if you say 0 minus 30, that will give you minus 30, but if you just said minus 30, it will still give you minus 30. Anyhow, so now we should be able to go with both screens. So if I go here, or with both sides, there we go. There we go, this side, there we go. So that's pretty neat. We can do the same for y by just copying and pasting, and then transforming all of this to y instead of x. We can still add the radius, because now the radius will add downwards and upwards instead of left and right. And instead of get width, we now have to say get height. And this will basically do everything for us. Now we go here, bloop. Now we can turn it around, bloop. Now we can't go off the screen, which is nice, because we don't want to go off the screen, we want to keep coming back. Now in this tutorial, we will be adding the game state. It's nothing you can really see, so I can't really show you an example of it in game. However, this will make our life in the future a lot easier, because now we have something to manage the state of the game instead of us having to do it manually. So let's open up this main.lua. So we have it open. And let's actually just create the game state. So let's create a folder called states, and inside of that a file called game.lua. Game.lua will contain our game state. Currently it will not really do anything, but it will in the future do a lot. So we can say function game, and then we can just return game. Then inside of here we can just return, we have nothing else we need to really do. And we can just return a few things. First, I want to return all of the states we have in the game. This means we will have a menu state, which we'll code later, a paused state, which we'll code later, a running state, and an ended state. And we'll code the ended state later as well. We already have the running state. So we need to define those states. So state is equal to, and then menu can be false, paused can be false, running for now can be true, so it's going to be the default state, and then ended, which will then be false. So these are our 4 states. You can add more states later on as you please. Thanks to this snippet of code here, it's not too difficult. Now what might become difficult is switching between states, such as saying, okay, we don't want the menu state anymore, we want this state. We want to switch to paused or to running state, and later on switching that state to the menu state. All of these things, they can be kind of difficult to implement. So we are going to take the easy way out and implement something that does all of that for us. So change game state is equal to a function, and in the state we want to change to, so state. We can then go self.state.menu is equal to state, and if that is equal to menu. So if the text menu is passed in, then we're switching to the menu state. And we can do this for all of the states we have. For example, paused, running, and ended. So here, 1, 2, or just 1, 2, 3. And in here, 1, 2, 3. Now there's probably a better way than to implement it with a string, but a string for our basic game is perfectly fine. As long as you don't misspell something, you'll be good to go, but you could give it a default state if none of these are true. But we're not going to worry about that. Now that we have this game state, let's add it to the game itself. So right here underneath player, we can add game is equal to game. And of course we need to import game. So local game is equal to require. And as you may remember, it's inside of the states folder. So states, and we're going to go .game, we can go /game. This should import it into this project. Now we can go down, and here with the update, we can now implement some of this state checking. So if game.state.running, then only we want to move the player. So we can move that in there, and we can move this to the top. So now we have that. So only if it's in the running state can we move the player. So if it's in the menu state, or if it's in the paused state or the ended state, we cannot move the player. Then the only other time we might want to have a different state for right now can be in the key pressed. So we can copy this if statement, and then if the game state is running, then do this. And then if the key is equal to escape, then we want to go game and then change game state to paused. And this will make it go to the paused game state. Now we need to be able to change it back. So let's go here and say else if game.state.paused, and then we can just copy this so we get the same key input, and this can change it back to running. So one of the things I left for homework in a previous video was to implement a paused state for the game, and I told you it would be really easy to do so. And right now we have implemented a paused state for this game. So if you were part of the previous tutorial, then now you should understand how to do that if you didn't do your homework. So yeah, this is how you would implement a paused state. It's incredibly simple. Now if we were to run this, we can go like this, and if you say pause by pressing escape, then the player doesn't do anything. And once we unescape, the player will continue. And then like this. And later on we can add like some paused text, but for right now it's fine. In this tutorial, we will be adding text to the game now that we have the state implemented. So what we have currently is something like this. So where we go like this, and we can also pause like that. Pausing isn't perfect, but you get the idea. Now, when we pause, I want the user to actually be able to see that they paused, because let's say they accidentally press the escape button and suddenly their game stops working. they will think it's a bug, but in fact the game is being paused. So we're going to implement that. And here's an example. Let me just bring this over here. So let's go like this and then pause. As you can see, there's no paused text on the screen. And now we go like this. It's nice. Cool. So that's an example of what we'll be doing. Now let's get started. So we already have a states folder. Let's create a new folder for components. And this folder will be used specifically for components that we might want to use in the game. We'll also create another folder, and this one will be for objects. Now, the states contains the states. Is the menu, game, those types of states. The objects will contain objects that we can touch. So the player is an object. And then the components is basically like the text. It's not necessarily an object that we can crash into with the player or something like that. So yeah, now with the player, we can move the player to objects. There we go, move. Then here we want to say objects player, since now the player is in the objects folder. We don't actually use the player here, so we don't have to worry about it there. If we run the game, everything should still work fine. Cool. Then the components, we can create a new file called text.lua because it's text. We include this main.lua, and now we can start working on the text. So first let's local love is equal to require and just love. Then we can create a function, call it text. It will take in some data and then it will return something. Of course, a table. And then at the end, we can just say return text. There we go. Our basic text object setup. Now we need to think of properties that text may have. So let's actually split it up into a few things here. Let's go parameters. Now first, I think all text will have some text, which would be of like a string or a text type that will be displayed. And this text will be the text to be displayed. And it's required. Now, you might ask, why am I doing this? Like, what does this benefit us with? If I were to hover over my text, you'll notice now we have parameters. Text, string. Text to be displayed required. This is called documenting your code. So if someone else in the future comes back to our code here, they will be able to just hover over a function wherever we use it and see what it needs. So that's what I'm doing here. If this wasn't here, then as you can see, we don't get any description. So that's what I'm doing here. Now, this is quite a lot of we're going to have to type. So since I'm too lazy, I'm just going to paste this from the already existing script code. There we go. We need an X for the X position of the text, so from the side of the screen. A Y for the Y position of the text from the top of the screen. All of these are as far required. We also then want from here everything's optional. But we also want the font size. The default will be P, and I'll set up this in a second where we'll actually have some default versions. If you know HTML, then this will help you greatly. And here are some of the options we can use. We then have a fade in, which will allow us to fade in the text. So let's say if it's a game over, we want the text to fade in as well as the text to fade out. This is just a boolean, so true or false if it should fade in and or fade out. Wrap width. This is when the text should be broken. So this should be when should the text break. The default would be the window width, but you can change this and you'll see later where we can change this. Then there's the align. So where will the text be aligned on the screen? It's like center, left, right, all of that. And then the opacity. Basically, this will allow us to set a default opacity for the text. So the text should maybe be a little bit see-through or something along those lines. We can now implement that in here. So we want the text, the X, the Y, the font size, the fade in, fade out, wrap width, align, and opacity. Quite a lot. You don't need all of this, but I feel like giving as much choice as possible is always a good idea. Now here above return, we can set some of the default values. So you can also do this in return if you want to, but most of this will be useful outside of it. So font size is equal to the font size that has been passed in, or it will default to P for paragraph, so paragraph size. We can then just create a space and copy 5 times. We then want fade in, fade out, so fade in, fade out, wrap width, align, and opacity. So all of these. So every one that's optional. Then we want to replace all of these with those values. And of course these as well. And in the fade in would by default be false. This will be false. This wrap width will be love.graphics.getWidth. The line would be defaulted to left. So right here on the screen, you can make it center, so it's in the center, or you can make it right, so it's on the right. And then the opacity here will default to 1. Now we also want to set some constants. First, we can start with the text fade duration, because we won't use the fade just yet. But doing all of the setup beforehand will save us a lot of time in the future. But you don't have to do it right now, but I do recommend you still do it right now if possible. Local text, and this is going to be a constant, so it will be all caps. Fade for text fade duration. We'll make that to 5. Now we have the problem here of this right here. How will we set that? Now we can do that by creating something that can hold all of that. So local fonts, and here we can specify the fonts we want. For example, H1 will be the size of love.graphics.newFont, and we can make it something like 60 for like 60 pixels. We can then copy that 2, 3, 4, 5, 6, 7 times. Then here we can just go H1 to H2, 3, 4, 5, 6 and make this P. You can add more. You can also use a different structure. I just think that, to me at least, this makes sense since I use HTML. And in HTML, H1 is the biggest text you can have, unless you modify it with CSS. But it's the biggest text you can have. And in P is like regular small text, just regular text. P is also about 16 pixels. And in H6 is usually smaller than P. H5, H4, H3, H2, and then H1. There we go. So there's all of our text sizes. We won't use all of them, but they exist if we need the variety from them. You can also give them different names if that's what you're into. We also want to set if fade in. So if we try to fade in, then you want to give the default opacity actually a lower value. Because if we want to fade in, then the default opacity should be pretty low. Since we want it to fade in, if the default opacity is 1, it's not going to fade in, it's going to pop in. So opacity then gets overwritten to 0.1. So no matter what they put in here, if we say it's fade in, then we're going to force it to fade in by making the opacity 0.1. Cool. We have now done all of this setup, so let's use what we have here. First, we can go and say text is equal to the text that was passed in. X, not .love. X is equal to the X. Y is equal to the Y. And opacity is equal to the opacity. Now, whilst I could put all of this inside of here as well, currently I don't think I'm going to use any of this outside of this text. So I'm going to keep it here since I'm not using it outside of this text. But if I do, I can move this, for example, the opacity that I moved here, I can move it to down here, because what's in return is things we can use outside of this right here. So we can't use this or this outside of this text function. However, we can use all of this outside of the text function. Now we can also set our default colors for the text. So colors is equal to R, which will be 1, meaning basically full red, G, which will be 1, and then B, which will be 1. So red, green, blue. And since they're all 1, this also means that by default they are white. So the text will be white on the very dark black background. Now we want to also be able to set these colors at any point. And you could move these colors here if you don't think you use them outside of this text function. But here we could go set color equal to, and we can create a function. This function will take in self, red, scroll down, green, and blue. Then here we can say self.colors.r is equal to red, self.colors.green is equal to green, self.colors.blue is equal to blue. So now if we use the set color, it will set the color to whatever we pass in. So we don't have to type this out every time we want to set the color. And now for the last function that we'll implement, and then we'll wait a while before we try anything else, is the draw function, because we still need to draw the text to the screen. That's a function. Function takes in self, and now we basically need to say what text we want. I'm going to call this TBL text because the text will later be stored inside of a table and also index. And this table is what we're also going to pass in here with the index of what we want to use. You'll understand this in a second once we use it. We can then go if self.opacity is more than 0. They want to do a bunch of things. Else, if the opacity is not more than 0, then we want to say table.remove. And we want to remove from TBL text the item at that index. That should be T. Basically, this is for our fading stuff. So once it fades out, we want to remove it from the table, because if it's still in the table, let's say after 2 hours of playing the game, that means everything that was text is still in the table 2 hours later. And every table requires RAM, and the more RAM you use, the worse the game will perform. So if the user plays the game for, let's say, 10 hours, then by hour 10, their game will probably reach like 5 FPS or something. But yeah, and we can just return false, because that means there's nothing left to draw. Otherwise, we can return true, because there's still stuff left to draw. Okay, now here we can start with the drawing things. We can leave the fading stuff for later. So let's first go love.graphics.set color, and here we can say self.colors.r, as will give us red, self.colors.green, and then self.colors.blue, and of course self.opacity. And this will set the color of the text we currently want to draw. Then we want to set the font of the text we want to draw. So love.graphics.set font, and then we can pass in font, and then at the font size. So the font size we can find right here, which would be something like P or H1, and we pass that in here to get the font size. We'll play a little bit with this to kind of get the idea of what it does. Then we want to say love.graphics.printf, specifically printf because of how much it allows us to modify, how much we can like just do things our way, like customization. So first we want to specify the text as self.text, and then self.x for the x position, self.y for the y position, the wrap width, and then the align. So as I said, you don't have to make a lot of these things you need to pass in. That's why they're optional. You could just hard code them in here, but I wanted to make it more robust. I think that's the word. Then also, after we have done all of this, we want to change the font size back to P, so we have a standard font size everywhere. Now that we have this, I think we can try it out. And then once we have tried it out, we can implement the fade in and fade out. We won't use it yet, but we'll implement it. So let's go here inside of game, and let's create a draw function inside of the game. Draw is equal to a function, self, and also faded. I'll explain that in a second. So first we can say if faded, then text, and this text is what we need to import. So we can actually just go here to main, copy this import, go here, paste it, but now we can say text, and text comes from components / text, and we should just say dot dot and then a slash to specify go back one directory, so one folder. Since we're here, we want to go back one folder and then jump into the components folder. That's what this means. Those two dots means go back one folder. Also, we can just say local love is equal to require love. So yet again, it's not required to specify this. It's just optional, but I like specifying it anyways. And then down here, we can say text, and we can pass in a bunch of things. If we hover over text, then unfortunately we don't get any of the documentation we wrote. This probably still needs to import all of that, but for now it's fine. So the text we want to display is going to be paused. Then we can say 0, and that will be for the X, and then love.graphics, scroll down a bit, .get height, and we can just say times 0.4, and this will kind of position the height in the center of the screen. We don't say 0.5 because you should remember that the very top of the text is actually where the text gets drawn. So if we put it at 0.5, it's actually going to be drawn underneath the halfway mark instead of in the middle of it. Here we can specify the size, for example, H1. We can specify false and false for the fading, and then love.graphics.get width, and this is for the word wrapping, and then where to align it to, and in this scenario, center. If we run this, or if we not run this, but we then can go and say draw. Now, if we run it, we won't get anything, because we need to actually now use this draw inside of main. So down here, if we scroll, we have a player.draw. But now we can actually use our states to our advantage. So we can say if game.state.running, or if the game.state.pause. So if it's one of these two states, we want to draw the player, as well as game draw, game.state.paused. So we are passing in this game.state.paused. The reason for it is because game.state.paused is a true or false value. So currently, if we go here, then we are trying to get a true or false value. So if it's true, then draw this. If it's false, don't draw this. We'll expand on this more later, but for now, this is fine. Alright, so now we're saying draw, and it will basically execute this right here. And if the game state is not paused, it will not draw anything inside of here because faded will not allow it to. It's faded because we're going to change it later. But yeah, for right now, we can just say love dot and see if it works. Okay, now let's go and pause. And there we go, we get paused. Isn't that absolutely amazing? So that's pretty cool. Let's make the text a bit smaller. Let's go, instead of H1, we say P. If we run that, then the text is now super small. So we made it able to change the text size by literally just changing one line. So change that back to H1 to make it nice and big. Now, this is more for the future. Currently, it won't benefit us a lot to type this. However, in the future, it will definitely benefit us to have this. So let's go here underneath opacity and say if fade in, so if we should fade in, do something. Else if fade out, so if we should fade out, then, because we don't want them to both happen at the same time, so we're using an if-else statement. So if fade in, then we first do fade in, and then we can change fade in to false, and then do fade out, because we don't want two different if statements. You want one if statement that just has an else if. So if we want to fade in, then we'll fade in, but it won't try and fade out at the same time. Then we can go self.opacity is equal to self.opacity minus, and here you can say 1. 1 is a little big though, because our opacity is a range of 0 to 1. So by saying -1, we'll immediately go from seeing text to not seeing text. So we can divide that by text fade duration. So there's 5 right here. So depending on how much you make this, the text will fade slower. And in here we can also just divide it by love.timer.getFPS. There we go. And this will nicely fade it for us. So it looks nice once it fades out. We're not going to use it in this tutorial, but we will use it in the future. Then here in the fade in, we can check the opacity, because if the opacity is more than 1, that means we have faded in. So we now want to fade out if possible. So we can check if self.opacity is less than 1. So only if it's less than 1, then increase the opacity. Else, if it's not less than 1, that means it's more than 1. Then we want to set fade in equal to false. Now that we have set fade in to false here, that means fade in will be false, so this will not be triggered. So if fade out is true, then we'll fade out the text. Then here we can say self.opacity, and it will actually just be the same thing. So let's just copy that. But this time, instead of minus, it will be plus. And now we have implemented fade out and fade in. Cool. Now we have added the text, and we can use this text in a lot of the parts of the game.
And hello everyone, if you're enjoying this tutorial, please leave a like and subscribe for future tutorials.
So currently, if we pause, we have a paused text. If we unpause, then it's no longer there. If we move around, we can move around. But the game is still pretty boring, because currently we can't do anything. We don't have any enemies, we just fly around. We can fly off screen, but we'll just come back, so that's no fun. So what are we going to do? Well, of course we should add the enemy. We should create the enemy, and the enemy should of course be the asteroids. That's the whole reason the game exists, to avoid the asteroids. So let me show you an example of what we will be doing today. We can move this here. There we go. We have an asteroid. We can't really do anything with the asteroid yet, but we have an asteroid. And this is the idea. We want to be able to create multiple of these guys without any problem. You also notice the red around the asteroid, just like with the player, that is the hit zone. So if our player's red around it and that asteroid's red touches each other, then boom, the game ends. And we'll implement that later. Yet again, it's a circle, so it's not super accurate. But the game itself isn't going to be super complex either. If you want to give yourself an extra challenge, you can try and make that more accurate than a circle. Awesome. Now, one thing I want to do before we get into actually coding the asteroid is I want to add a new feature to the game. So I am going to remove this text here, go into player, and I want the player to now, once we draw the player, I want it to take in faded, like that. And once it takes in faded, I want us to decrease the opacity of the player. So here we can say if faded, then we want to set opacity equal to 0.2. You can make it lower or higher depending on what you want. Now, because we have this faded right here, we can now go to main. And here we can just pass in if the game is paused. If the game is paused, we want to fade out the player. So let's run that and just see that it works. So pause. I don't see much of it. Oh wait, we don't pause. Pause is this button. As you can see, the player fades out. So pause. The player is still there, just faded out. We want to implement this for the entire game. So where everything fades out once you pause. Except for the debugging stuff, of course. Cool. Now that we have that, we can also implement it at different places. So let's create a new object. This object will be called Asteroids. You could call it Asteroid, but in the script I made it Asteroids accidentally, so now we'll have to stick with the scripts. But we can say .lua, and now we have an asteroid, but you could call it Asteroid, that would be perfectly fine. We can then say, and we can just close this as well, local love is equal to require love. I just love saying that, I don't know why. We can then say function and asteroids, and we can just return an empty table and then return asteroids. We have created our basic asteroid object. Now first we'd want to take in the asteroid's X position, the asteroid's Y position, its size, its level. So depending on the level will also depend on some things that the asteroid might have, and then debugging. Now here we can say debugging is equal to debugging or false. So basically it's going to be either debugging or not debugging. Next we want to set things such as the asteroid's vertices. This is basically how many edges the asteroid will have. We'll play around with this later so I can actually show you an example. So in this scenario, or in this case, we can just say local asteroids. And of course, you can make it something different. If you don't like 10 specifically, you can make it 11, 15, 50, 5, whatever you choose. I'm going to make it 10 because I actually found that that looks pretty good. Then we can also set the jaggedness. And the jaggedness is basically just saying how round the asteroid should be. The more jagged, the less round, and the more epic it looks, but also the less accurate our collision detection will be. So make sure it's not too jagged unless you're going to upgrade that collision detection. But then we can say asteroid jag for jaggedness. I'm not going to spell jagged. I don't know how to spell that, but that's 0.4. But you can make it more or less. I found 0.4 looks pretty good. Then we can go local and then put the asteroid speed, and that is equal to math.random. Why are we saying math.random? Because the asteroid speed itself should be random. Or am I incorrect? Because if all asteroids are the same speed, the game would be less fun. But if this asteroid on the left moves 5 times faster than the asteroid on the right, then that would be pretty cool. Just as an example. We then put in 50, so it gives in a random value till 50. And you can say plus and level times 2. So depending on the asteroid level, we'll add to the asteroid speed. So let's say it's 50 and the level is 5. So then it's 50 plus 10. You could increase this level to something like 3 or 4, and that will also make the leveling system much more difficult, but I'm going to keep it low for now. Cool, and we'll come back to this here at the top. I'm currently just going to go to return for now. We can then specify x is equal to x, so the x that's being passed in. Y is equal to y. Oh, not dot love. Oh gosh. That was supposed to be a comma. And then we can say the x velocity. This means how fast the asteroid will move on the x-axis, so from left to right. That will be equal to math.random. And now we can say times asteroid speed, so that's the one we did right here, times velocity. Now velocity will determine if the asteroid goes forward, backwards, up or down. So on x-axis it will go either forward or backwards. On y-axis it will go either up or down. So let's quickly create that. So let's go here. We can say local velocity is equal to -1 by default. Then we can check if math.random, and here we can specify it's less than 0.5, because math.random will give a value between 0 and 1. Then, and we want to say velocity is equal to 1. So it's -1, but if math.random is less than 0.5, then we're going to make it 1. And this will decide whether this is going to move this way or this way. We don't have to worry too much about this now. We're just setting it up. Now you may have remembered, before we continue here, that in my Lua tutorial I did cover math.random. And I did cover how it's not always random. So to make sure that the player doesn't get the same game every time they boot up the game, so the same asteroids, the same way the asteroids move, everything, we should make it more random before we continue here, because I might forget about that. We're going to go to main, and here we can just specify right before the load, right before everything, math.random seed, as we'll seed the randomness, and say os.time. And this will make everything more random. It will seed it to make it less predictable. Cool. Now we can go back to asteroids, and we can copy this x velocity, and we can make a y velocity as well for up and down. And it can have exactly the same math. So it may not move the same speed up and down as it's moving left and right, which is what we want. Now we need to set the radius of the asteroid, because on the end of the day, the asteroid is pretty much just going to be a circle. So we can say radius is equal to math.seal for math.sealing, so always go up. And then asteroid size divided by 2. And this will give the asteroid's radius. Cool. Now I'm going to leave all of this here for a second, and I'll come back to it a bit later. Let's draw this asteroid, because I'm not really sure if we're getting everything right here. So let's go function self, and also if it should be faded, because if we pause the game, then we can yet again say local opacity, if that is equal to 1. But if faded, then opacity is equal to 0.2. Then you want to set the color to not white, but kind of like a grayish white, because when I think of an asteroid, I don't think of it as a pure white blob just flying to me. In fact, I think of it as a bit dark actually. So let's make it like a grayish color in this scenario. Since the background is pitch black, we can't really make it too dark, because then the player will see it. So you'll notice it's not pure white, as you can see here by these numbers. You can tweak these numbers to kind of fit your need for what you want the asteroid color to be. But yeah, this will determine the asteroid color. Now next we need to determine the asteroid's points. Now the points basically just say where the asteroid is going to be. When we draw the polygon, we have a bunch of points. So you may have remembered when we draw the player. So local points, let's go here, is equal to, and here we can specify a table and then say self.x plus self.radius, which is right here, times self.offset. Now offset is just so we can get a little bit of an offset. So the game, or so the asteroid, which is like a circle if you remember with the player, it needed a little bit of an offset so the center dot can always be in the middle. If you could remember what we did. So if we go here and say love dot, then you see that little circle, that little red dot in the center of our player. That had to be on an offset, which was I think like -1 and -1. Because it wasn't quite in the center of our triangle. And in this scenario, we'll have the same problem. So we're setting an offset. Now to generate the offset, we can go up here and we can say local offset is equal to an empty table. Then we can say for, well, not in pairs, for I becomes 1 to, and to where? To where specifically are we going to set this offset? Well, that depends on the amount of vertices we have. So in this scenario, we have 10 vertices, but we don't want all of the asteroids to have the same amount of jaggedness, right? We don't want that asteroid to have 5 points and then the one next to it also have 5 points. We want one to have 2 and one to have 10 and one to have 4. We want there to be variety. So let's create a more interesting vertice. But you could, if you wanted to, just put it here, put this here, like that. That's perfectly fine. But I want it to be a bit more random. So here we can say local vert for vertices is equal to math.floor, because we also want to go down, but you could make it go math.ceil. In fact, that might even be better. I'm following a script, but you could make it math.ceil and that would work perfectly fine. Math.random, because I want to get a random value. So just right here. So we can pass that in there and just say +1 so we don't get 0. Plus, and we can paste that Android vertex in there again, divided by 2. And this will give us a nice random value, which will also determine how less round our asteroid is. So how many points it has, edges. Now here, instead of saying this specific just always 10 value, we could specify vert +1. And now we can insert an offset, and this will always generate the offset at the correct location. So we can say table.insert, and then the list and value. In this scenario, we want to do offset and math.random, and I'll explain this in a second, times asteroid, and let me just scroll down so I can autocomplete that, times 2 plus 1 minus asteroid jag. The thing is, I can't quite explain this math here because you can't visualize it. That really sucks. But once we see this asteroid, we'll be able to play around with this. I can explain what's happening. But take note before we continue that this right here is not the same as saying this. They are not the same. Just take note of that. For some of you who might want to do that. But there we go. And we can play around with this later so I can show you in examples. But for right now, let's just leave that like that. So we have this vert and offset. And now I can get the vertices like this. So vert. And then offset is offset. There we go. So now we have both of these that we can use here. So back to points. So now we have self.offset, which is basically everything we just did. And now we need to specify at what index, because there will be multiple. Because if you could see here, we're foring through this and inserting for every item. We're inserting a new offset. Or a new item for that offset, the new location. So now here with the points, we need to specify and I'm just going to say 1. So the very first one we have. Times, and we'll later modify this to be a bit more interesting. Math.cos. Yet again, I can't quite explain this yet because we can't see it, so we don't really know what we're drawing here. But I'll show you in a second. I'm going to self.angle in there. And then with the next one, we can just copy it. And instead of saying x, this will be y. Keep everything the same, and instead of cos, we say sin. And now we don't have this angle though. You may have noticed that. We can quickly generate something that will give us an angle, just like with our player how we have an angle. We can do the same here. We can just say angle is equal to math.rad for radians, and then math.random, and we can just say math.pi. You don't have to worry too much about the math we're doing in this game dev course. The more important part is that you can see how everything fits together to create something interesting in Love. So if the math goes over your head, don't worry. There's a lot of games out there that you can build without all of this complex math. And in most cases, you can do what I do and you can just literally copy math from online, because I watched a lot of tutorials and I looked through a lot of documentation and I was like, I don't understand any of this. I copied, paste, test, and it worked. That's what I would recommend you do as well. If you're not very good at math. If you're good at math, then just do this. Math course coming out soon at some point. So stay tuned if you want to improve your math. Cool, so now we have our points. But we still need a lot of the other points as well. So this is just the first batch of points, because if you remember, we need at least 2 more here in order to complete it into a full triangle. So we can create a for loop, and then for I becomes 1, oh that should be I becomes 1 to self.vert minus 1, so the amount of vertices minus 1, do. And we can just say table dot insert. We can specify that we want to insert into points, so this one right here, and in what we want to insert. For now, I'm just going to copy this and modify it because it's quite a lot of typing, because math. So it's self.x plus self.radius times the offset, but instead of saying 1, we say I plus 1, because here we specified 1, but now we want to go 2 and 3 and 4 and 5. If you wanted to, you could just specify that I should be 2 here from the get-go. But this works perfectly fine as well. And then we can specify math.cos, self.angle, but now we need to add a bit of extra math so we can close this polygon we're drawing, because remember, a polygon should close. If we just drew a triangle with like just 3 angles, it's not going to close itself. We need to make sure it closes. For example, if I were to open up my drawing app here, if we just drew this 1, 2, 3, that's not a triangle, is it? This is a triangle. A triangle closes itself. So we need to add some extra math to do this at some point. Or here, but not this. This is bad because it doesn't close itself, it just stays open. So we need to do some math to do this, like that. So now here, after the angle, we say plus I times math.pi times 2 divided by self.vert. There we go. That should be divided. Awesome. We can then insert another one, and we can just skip over the math for now because there's a lot of math here which we don't necessarily need to cover at the moment. And we can just specify y here. Everything else will stay the same, except instead of cos, we'll have sin. Cool. Now we can actually go about drawing what we have. So we can actually display it on the screen and see what we're working with, because currently we're not drawing anything. So we can just say love.graphics.polygon, and now we just specify that we want a line. Oh gosh. We want a line and points, because we generated the points right here. It's inside of a table. we did the points, and now we're passing in the points. So instead of doing what we did with player, where we just passed in the points like this, as you can see here, the math is pretty much similar. We did this instead and generated the points for us, because asteroids won't all have the same amount of points, unlike the player, which only has 3. They might have 10 or 50, we have no idea. And we don't want to draw each one of those out by hand, because that's going to be a massive pain. So we use a for loop to do it instead. Cool, and let's just add some debugging in case you want debugging. So if debugging, then love.graphics.setColor 100, so red. And we can then also specify love.graphics.circle to draw a circle. We can specify we want a line. And then we specify self.x to give it a self x position and a y position. And then we just specify the radius. And there we go. So this would display the hitbox of the asteroid. Now I still want to implement movement, but for right now I think this is fine. Let's just go to main, because I want to see what we draw. You can probably hear my voice, how excited I'm getting to seeing what we drew. Let's go down here to draw. And now we actually need to generate an actual asteroid. However, I am wondering if doing it here would be a good idea. I say we should rather open up the game state. And we should implement a function that could benefit us in the future. For example, what if we had a function that says start new game? And that's a function that takes in self and the player. And I'll explain why in a second. And this every time starts a new game when we tell it to. So let's say the game ends because the player died, or when the player says play game, then this will trigger and it will restart the game. So you could say self and then change the game state to running, because we were changing the game state back to a running state since that's what's happening. Then we are creating a global scope. Very important to remember this, a global scope variable called asteroid. So _g dot, or just plain out here asteroids, just lowercase a. This is a global scope variable, meaning it can be used anywhere inside of this file, or actually anywhere inside of this game now, because we're going to import this file later. We're going to use this and it's going to generate this global scope function, or this global scope variable. This isn't the best way to do it. Take note. In fact, I might even recommend you do asteroids here and say asteroids and then doing this, or finding even a better place to do it than here. But for now, this will work fine. We make that an empty table. Take note, it is global scope. You will get confused if you do not take that as note. Then we specify the asteroid's current x and y positions. So you could do this without needing to put a variable, but I'm going to use a variable just to keep things simple. So local asteroid x position is equal to math.floor, math.random. It doesn't need to be random. You could specify a specific position. For example, we could go here and say table.insert, because we want at least one asteroid. Asteroids, and then what index, and then what value. And in this scenario, in asteroids object, we can go up here and you can copy this and change from text to asteroids, change from components to objects, and then here instead of saying text we say asteroids, and this will import this asteroids object which we are using here. And then we specify the x and y, so you could go something like 60, 100, that's perfectly fine. Then 100 for the, I believe that's the radius. You look here, you go up here. No, that's the asteroid size. So depending on the size, or depending what you pass in there, the asteroid will be bigger or smaller. the level, which will in this scenario just be self.level, so it will level up depending on the game level, and then true for debugging. Now you could do this, but it's boring because we want asteroids to start up at a different location every time we start up the game. So what we could do is we could make it random, and that's what I'm doing here. And we say love.graphics.getWidth because it's the X position and it can appear anywhere on the X axis. Same with Y, but this time instead of saying width, we say get height. And we pass in the asteroid X, we pass in the asteroid Y, we save that, and now we can go here back to main. Then on the game load, when we create this game, we can say game : start new game, and we can just pass in the player. Now currently we're just passing in the player. This is just for future reference. We don't have to worry about it too much now. But we are passing in the player because later, once we start the new game, we'd want to position the player in the center. We want to give the player more HP, and so on and so forth. So by default, that means we'd want a player. We could also specify and push in some asteroids in here if you wanted to as well, but this is fine for now. Now remember, asteroids is a global scope variable, so don't get confused about what we're doing here, because remember, it's a global scope, very important to take note of. So for, and we can say underscore because we're not going to use this is the index, we're not going to use it. Asteroid in asteroids global scope. Remember that. You might get confused, so maybe make it somewhere more global or more local instead of global. But for right now, just remember this is global scope because you will get confused if you don't remember. Then you can say asteroids or asteroid and then just say draw. So call the draw function for every asteroid we have. So if we have multiple asteroids, then this will call it for multiple asteroids. And just pass in game.state.paused, so if the game is paused, so if it should be faded out or not. Let's run this and hope for the best. And ooh, asteroid 8 cannot perform on local level, a null value. That means we may not have passed in the level. Do we actually have a level here yet? No, we actually do not have a level here yet. My bad. Okay, so let's add a level. We are currently at level 1. We can start there. Now if we run this, where's the asteroid? I do not see the asteroid. Let's maybe draw it again. I do not see the asteroid. Oh, you know what? I think this could be the reason. So let's remove that 60. I think I just forgot to remove that. Let's try and run it now. And in here we need to specify the size. Sorry, I got so confused of all of these things. But yeah, now I think it should probably, yes, there we go. So now we have an asteroid. And let's maybe spawn another. That's pretty cool. We can of course have multiple asteroids. Let's just maybe make 4. And then we can just copy this for every asteroid X. And then copy this for every asteroid Y, just so we can have some of an idea of what we see. Now if we run this, we'll have 4 asteroids that spawn randomly. Cool, and they all look different, and that's kind of what I've been doing this whole time with all of this math.random. This one has 1, 2, 3, I can't actually show my cursor, but yeah. So you can see they have different amounts of like spikes, and the spikes also look way different compared to each other. So let's play around with some of the math just so I can show you what I meant. If we go here to the asteroids, of course, if we were to change this to 90 for example, then now as you can see they're like super spiky. So if the higher you make that, the more spiky they can become. That actually looks kind of cool. But if you were to make this something like 2, then yeah, you need more than 2 to actually be able to draw a polygon. So let's make it 4. I think that should be enough. Then there you go. Then they all look kind of plain. And in here with the jaggedness, you can say how jagged it should be. So if you make it a 9, then it will be like super pointy and super cool looking. But as you can see with the red circles, the hitboxes are not very accurate. So unless you're going to do some extra math there to make it accurate, I do not recommend making this too high. I did put it at 4, but you could put it somewhere else. Like, let's say at 5 should still be perfectly fine. Yeah, it's still mostly perfectly fine, not perfect. But yeah, and then let's say you were to make it a 0.1. Then they'll basically all look super round. And you make it a 0.0, I wonder what will happen. Would we crash? No, but it would look pretty much very round. And then the more vertices you add, for example, let's say 19, then now it'll look like a normal circle because it's just a bunch of little lines being drawn. And of course, if you were to make this a 9 again, then now it will look super weird. So that's kind of what these were. So if you were confused, I hope this also cleared it up for you. Asteroid speed we're going to work with in a second. Then here's the offset, which you don't have to mess with right now. But if you want to, you could, and you could like remove some things here and see what offset will do. So if we select 10, for example, what will happen then? As you can see, not so great. And of course, if you wanted to, you could say fill instead of line. And that will give you like a filled version. But then I would recommend choosing a color a bit more gray than the grayish white color we chose, because then it just looks weird. So I'd recommend something a lot more gray if you want to go something that's not line. Because currently it kind of looks a little bit faded compared to ours. And of course, if you pause, they will all fade out a little bit. And unpause, pause. Like that. Cool, and that's the drawing section completed. Some of you might want to take a break right now. I'd actually recommend it. But if you think you still have the guts to go for it, then let's implement the movement. So here we have not in starting game, but in Asteroids. Here we have the draw, but the draw is now completed for now. So we can now go and say move, and move is a function, takes in self and dt. dt because we actually want to start implementing some good ways to move our objects without using FPS, because as I said, FPS is not a great way to specify how fast something should move. Use dt. And remember, dt is the time between this frame and the last frame, so it's usually very small. Then it's self.x is equal to self.x plus self.x, and we can say vil for velocity, and that's right here. So that will basically, with every move, it will move x to where it currently is, but plus its velocity, and then just say times dt to make it move at a consistent rate. So if it's 30 FPS or if it's 60 FPS, it will get from one point to the other point in exactly the same time. And we can do the same for y, but it's time for y velocity. Cool. So that will move it. Now we can go to main, and we can go up to update, where the game state is running. And we can actually just copy this, paste it here, and this time we can call this AST index. But you don't have to. In fact, you could possibly just keep this underscore, because we're not necessarily going to use it, although we might in the future, so I'll keep that there, because it would make sense to be able to access the index from here. But as for future reference, you could make it an underscore for now. And instead of draw, we say move, and we pass in dt. Where do we get dt? dt gets passed in from update. So update takes in dt thanks to Love2D. We take this dt and we pass it in here. If we run this, then now it moves, which I think is kind of cool. Run it again, now it will move a different direction. Move it again, But now it's incredibly slow. Move it again. Now you'll notice as well, oh gosh, I closed my terminal. But you'll notice as well, when I get back to everything, that if we run it, then it can go off screen. Just give it a second. My player can actually go with it off screen, just to show you something. You'll notice my player comes back. But once the asteroid leaves the screen, it never comes back. We don't want that. So what we can do is we can go to player, go to move player, copy this, go to asteroids, and then just paste this here. And it will do the same thing as with the player. It will make sure the asteroid stays on screen. So let's run this and make sure it works. It's going to take a while to get off screen now. There we go. Alright, give it a second. You can also put some extra math here to make it appear sooner on the other side. But I think this is fine. And there it goes. It now appeared. And just like that, we made sure that the asteroid never goes off screen forever. Cool. And of course, if you want the asteroid to move faster, you could upgrade the speed here. For example, let's just go +9 for now, or let's go +10 actually. I think that would be pretty good. And now we'll move usually much faster, but it is still random. So let's maybe go here and just make it a default 150. Let's see, that should make it move pretty fast. Yeah, there you go. So you can just upgrade that to make it move faster or slower. I maybe say increase this ×2 to maybe ×5 or ×4 or ×3, depending on how difficult you want the game to be. This is something you can tweak to make the game your own, to make it something that's just more than what we have. And yeah, that is that. In this tutorial, let's add the lasers. You know, because when you have a spaceship, you can go pew pew pew, and that should be destroying the asteroids. Whilst we'll not be implementing the destroying of the asteroids yet, we will be implementing the lasers themselves. Now the lasers are much easier than you might think they are. They're basically just dots on the screen that move around. So there's not a lot of complicated math in drawing them, it's just a little circle or square that moves. So to give you an example of what we will be doing, let me just go here and start one up. Alright, so here is the example. If I press space, it shoots an asteroid. There's a limited amount of asteroids allowed on the screen. So if you have too many asteroids on the screen, it will remove some of the previous asteroids. But yeah, currently if you shoot an asteroid, it can't, because the lasers cannot destroy anything yet. And I might have said asteroids earlier, I mean there's a limited amount of lasers that can be on the screen, not asteroids, a limited amount of bullets. Alright, it's that simple. Let's first create a new object, and we can call it laser.lua, because this is an object, because it's the laser, it's a bullet. Then right here, we could just remove that, and we could say function laser. Then we want the X position, the Y position, and then the angle it's shooting at, because the player might be at a specific angle, and we want to shoot out of that angle. So if the player is looking upwards, we want to shoot upwards of that angle. Anyhow, then this will return a table, and then we can just return laser. And there we go. Now first we want to set the laser speed. So setting this will determine how fast the laser moves. So how many pixels per second. In our case, I think about 500 pixels a second is perfectly fine. To some of you that might be a little fast, so you might want to turn it down. Or to some it might be a little bit slow. But it's up to you. So local laser speed is equal to 500. So in pixels per second. We can then set the x equal to the x that was passed in, the y equal to the y that was passed in. Now let's first draw what we have. So let's draw, that's equal to a function, and this function will just take in self and fade it as well. So if we pause it, should also fade out just like everything else. And we can say local opacity is equal to 1. If faded, then opacity is equal to 0.2. Then love.graphics.set color, and you can make this red or green or whatever color you think a laser should be. But I'm just going to make it white. But you can customize the game and make it red, green, blue, purple, whatever color fits your eye the best. You can make everything colorful and much more playful. And we can just also pass in the opacity. Since we are literally just using a dot, we can use a point. So just like a point on the screen. Luckily, Love2D already has this built in. So we can just say love.graphics.set point size. And this is how big the dot will be. I'm just going to say 3, but we'll play around with this so you can figure out what size is perfect for you. Then we can say love.graphics.points. And now we can draw the point on self.x and self.y. And we forgot to require love, but yet again it's optional. So local love is equal to require love. There we go. Nice. We'll add this later, but for right now, let's just see how everything looks if we put it on the screen. Alright, so let's go to player, because here is where we'll be adding the lasers. We can go to the top and add a new item. We can call it lasers, and that will just be a table that's empty, because we can have multiple lasers. So we'll just have a table that can hold all of the lasers for us. We can then scroll down, and maybe right above the draw, we can add a shoot laser function. This function will allow us to shoot a laser, and that's it. This could be inside of lasers or inside of game or whatnot, but I feel putting it inside of player makes the most sense, because if you say player and then colon shoot laser, it makes so much sense. But if you say just laser, shoot laser, it's kind of weird. So if you say player shoot laser, then you know the player is shooting a laser. And if you add an enemy, like maybe a spaceship, and the spaceship can shoot lasers, then yet again you can just say spaceship or enemy colon shoot laser. You can follow the same structure and it would always make sense. Cool. Now, for now, let's just go shoot laser, and that can be a function that takes in self. And here we can just go table.insert self.laser and then create a laser object, and we need to import laser. So you can say local laser is equal to require and then objects laser. Now I don't know if this dot syntax works, but if it works, let's use it. But if it doesn't work, you can use a slash. I'm going to try this dot syntax because my IDE constantly auto-completes it like that for me, so let's see if it works. Now down here, where we do this, we can go laser, and then it needs the x-axis, and the x-axis will basically be the same as our player, but we'll tweak this a little bit just to get it right. Let's go self.x, and we'll tweak it so it's found like this, self.y, self.angle. Cool. We'll tweak it more later because this won't necessarily work that great yet. But I just want to get it on screen. Now if we go to main, we can go maybe right here to where it says this key release, and we can say, or actually let's leave that for now. Let's go here first. And we have a few things we might want to do to shoot. So there's a few things the user can press if they want to shoot. First, I think space is a good item to press. then as well as down, like the down arrow key, and then KP5, like that is the 5 on the numpad. I think that's also a good one. And in here we could just say player shoot laser, and this will shoot the laser. Now I also want the laser to be shot if a mouse is pressed. So let's say if the right mouse button is clicked, we want the laser to be shot. So if they want to play with their mouse, they can. So let's actually do that. So we can say function love.mousePressed, and this takes in quite a few things. So first it is X, it is Y, it is the button that has been pressed, is touch, for example if it's a touch screen, and presses, which is also for if it's a touch screen. I believe this X and Y is mainly for the X and Y position on screen. So let's say I click here, then that would be like 50-50 XY. Now here, you can say if button is equal to 1, and this is their left mouse button, I think. Then we can say if game.state.running, so only if it's the running state, player shoot laser, and I will shoot the laser. Cool. But currently if we're trying to shoot the laser, we won't see anything because we are not drawing it. So let's go to player and let's put the draw also here. So every object can basically contain its own version of the laser. So if you have multiple lasers on the screen, then every object will handle their own laser. So let's go here to draw. Let's just do it at the very bottom. So 4, and we can just say underscore because we don't need the key, laser in pair self dot lasers, and we can just say laser draw, and then faded. And this faded is basically what's being passed in here. It's like that. Let's see if this works. Okay, space, and there we go. Currently they didn't move because we haven't put anything there. But now we can create a bunch of cool little lasers. And we can not use our mouse button. And the reason for that would be, let's see. That should be state. Like that. Now we can use our mouse button as well. Cool. So these are our lasers. As you can see, they're just little dots on the screen. They are only little dots because if we go to lasers, we're using points. If we were to increase this to, let's say 30, then it will be massive dots, as you can see. So it depends on how big you want your lasers to be. Some people would like them to be really small, although then it's kind of difficult to see them. Oh gosh, where's my player? There we go. As you can see, it's very difficult to see them. So I think 3 is about a good size, but you could go up to something like 5 or even higher depending on what your preference is. But 5 is a little big. For me, personally, I'm going to go 3 because that just looks perfect. Cool. So let's implement the rest of the things into our laser class. So next up, we'd want to move the laser. So we can go move is equal to a function. This function just takes in self. Now, just like with the player, we need the velocities, x and y velocities. So we can go here and we can say xvel for x velocity is equal to the laser speed times math.cos, pass in the angle, that's the angle we got here, so the same angle as the player, divided by, and then love.timer.getFPS. Yet again, it would be better to rather put something like dt here, just because it would be safer. But I don't think it's that necessary for a game this small. But if you plan on making this game much bigger, then you could definitely implement dt here. Next, we can do the same for the y velocity. But this time, instead of sin or cos, we can go sin like that. Now we have the X and Y velocities. We also at some point probably want to remove the laser from the screen. And how we determine that is based on whatever you want. You can base it on time, for example. If it's been on the screen for 5 seconds, remove it, or something like that. I, however, am going to determine that based on the distance it has traveled. So let's say it can only go 1.5 way around the screen or around the window. Something like that. So we can just say distance for the distance traveled, and we can make that equal to 0. Cool. Now we can continue to this move function here. And we can say self.x is equal to self.x plus self.x velocity. We say x velocity because remember that's how fast it moves on the x-axis. Cool. And then we do the same for y. Nice. Now we want to keep this on screen. So we can actually just go here and we can copy this. You could possibly make this a function and then just reuse the function constantly because we're copying and pasting this the whole time. So it would actually be better to create a function and put this in. But that can be your homework if you want to walk the extra mile. Now for this right here, we don't have a radius because remember, we're just a dot on the screen. We are no longer a circle. We're just a dot. So here with the self.radius, we can just remove that. So like that, delete. Now it should be self.x less than 0. We set x to the width. If it's, and your self.radius with a minus, so let's just also remove all of those. There we go. If it's more than the width, then we want to set it to 0 and not the radius because we don't have a radius. So we're going to set it to 0 because remember 0 would be this point right here where the window starts. Same here, the y0 would be this point right here where the window starts on the top. Next up, we want to say how far it has traveled. So the distance it has traveled. So self.distance is equal to self.distance plus math.square root, and here first we could say self.x velocity to the power of 2 plus self.y velocity to the power of 2. And this will just get us the distance it has traveled from point A to point B. This little part here. Cool. You could use some different math if you want to, but this works perfectly fine. Nice. Now we have the laser and the laser can move. Now let's move the laser. So I'm going to do that right here inside of this player. So right at the bottom. And we can just move the laser from here. So for index laser in self dot lasers, we can then say laser colon move, and this will move the laser. Now if we were to run this, the laser should move. Oh gosh, it's moving, but it's shooting in the wrong direction. Okay, so we did some wrong math, but now the lasers, they do shoot. So let's just go back to lasers and see what we got wrong. Oh, and right here, this should be negative because it's going to move in a slightly different manner. Now it should go out of, yes, now it goes out of the top. Cool. Now that is fixed, we can have a ton of lasers on the screen. I think that's actually pretty cool. Now, never do you really want this many lasers on the screen. You want to limit it. So we have to basically tell the lasers to destroy themselves once they're completed with all of this, once they're done. So let's go here to the player and implement that. So let's go to the top and we can specify the amount of distance the lasers are allowed to travel. So we can say local laser distance. You can also call this max laser distance if you want. and I'll make that equal to 0.6. So they can basically move 0.6 the width of the window before they get destroyed. So they can't go the whole width, but they can go 0.6 of it. You can change this to make it them travel further or less, depending on what you prefer. We can also then specify the max amount of lasers on the screen, and that can be 10. You could make it more or less depending on how difficult you want the game to be. When you implement maybe levels, you could make that, let's say on the most difficult level, you can only have like 3 lasers on the screen at once. Cool. Now we need to implement something that will destroy the lasers. So I'm going to copy this right here, and instead of shoot, it will be destroy. And this is very basic. We can just say table.remove, and we can say from self.lasers, and then the index. So now here we can also just take in the index. So it will remove the laser at that index inside of the table. Now where we move the laser, so down here, there we go. Here where the laser moves, we can say if, and I'm just going to do this inside of some brackets, but you don't have to. I just feel more comfortable if I do that. Love.distance, love, that should be laser.distance. If that is more than the max laser distance times love.graphics.getWidth, and let me just fix this. So if the laser has traveled 0.6 of the screen width, so that's what we're doing here. So 0.6 of this screen width. If it's more than that, then we want to remove it. We can then go here and say self.destroy laser. That's passing self and index. The index that we're getting here. So this will be the index where this laser can be found, which we're using here to destroy it. Right there. Now if we run this, then as you can see, the laser gets destroyed. If the laser moves too fast, you can make it slower. If it's too slow, you can make it faster. We can only have up until 10 lasers on the screen. But we haven't really implemented the whole 10 lasers thing just yet, because we can definitely shoot more than 10 if I had to guess. I'm not going to count that, but let's make it 3 so we can actually see the difference. Now if we were to run this, as you can see, there's definitely more than 3. So what we can do is we go to shoot laser and we limit it. So if the numbers in self.laser, so if the amount of lasers is less or equal to max lasers, then only do we want to do this whole insert thing. Otherwise, just ignore it. Don't allow us to insert another laser. So if we go here, my bad, and we run it, here we currently only are able to do 4 because this is less or equal to. So we could make it less instead, and now it will be more accurate. As you can see, only 3 at a time. Now if we were to change this here to, let's say, 10, then boom, Bob's your uncle, we can only shoot 10 lasers at a time. We're limited now. So you can see there's like a little wait period once I've reached that amount. So you can tweak that to make the game more challenging or easier depending on what you prefer. Cool. Now one last thing is, let's make sure all our buttons can shoot the laser. Okay, cool. So down works, space works, the button number 5 on the numpad works, and the mouse works. Okay, so if all the buttons work, that means we have done our job correctly. We have now implemented shooting lasers in the game. In this tutorial, we'll be adding collision for those lasers, and it will be pretty cool. Now I have to show you this. Let's just move this here. If we go here and we shoot, it splits into 2. Shoot again, it splits again. And shoot it again, now it's gone. And this is a very customizable thing that have popped up here. So you can make this more customizable and maybe break up into more pieces, maybe move faster, maybe be bigger or smaller. And once you shoot it up, nothing happens, but we can implement that later. Isn't that incredibly cool? Also something you might notice, if we were to go here and we were to shoot, pew, you'll notice it's a little explosion animation thing where it has a little bit of color once it touches the asteroid. Nice. Now I'm going to remove the whole debugging thing, not from the game, but just from our visual standpoint, because currently I don't think we need it. But if you do get stuck and some sort of error occurs, turn on debugging and see what's happening. Because especially when we do collision detection, which our debugging is exactly doing, showing us where the collision happens, then that is when it's most important. But I'm going to disable it, but I'm going to make sure that we can re-enable it easily again later. Cool. So let's create a new file. Just say new file, and this can be globals.lua. Now these are going to be variables that are going to be global scope, like massive global scope. Everywhere this can be used, and that's the point of this file. So whatever we put in here, we can use anywhere within the game. So let's first do asteroid size, and let's make that 100. We'll be using this asteroid size in multiple files, so it makes sense to put it here because we're not going to attach this specifically to an object. This will just kind of be there. It will be able to be used whether that file uses the asteroid object or not. And you want to have show debugging. You can make this all capital case just like with this asteroid size. But the difference is we don't want to change this asteroid size in the game. It's a constant. We don't want to touch this except if we're getting the value. But we don't want to set a new value. We don't want to change that to 150 while the player is playing the game. We could, but we don't want to. Show debugging, however, we might want the player to allow them to show debugging. So like if they go into the settings, they can turn debugging on or off if they're maybe a developer or is interested in that sort of thing. And we can make that equal to false by default, but you can keep it true if you still want the debugging information. Now one last thing I would like to do is do our distance calculation math here. And this will just calculate the distance between point A and point B. We can say function calculate distance x1, x2. So this can be y1 as well. We can do x1, y1, x2, x2, or y2. Now this will be the x and y position of the first item. Then we want the x2 and the y2. So this will be x and y position of the second item we're trying to get the distance from. You could put this in their own little tables instead, but I think that's overkill. So let's just do it like this. We can then return just a simple math function, so math.square root, so squirt, and then first we can go here and say x2 minus x1, and then to the power of 2. You could split this up into multiple lines. Don't get me wrong, you could split this up into multiple lines. And why not? Let's actually show you how it will look. So go here and say local dist x, and then we can go here and we can move that like that. And then here we can go local dist y for the y distance difference, and it will be the same thing, but this time it will have y instead of x like this. So remember, it's the second y minus the first y. So it's where you are going to minus where you are. That's very important to take note of. And then in here we can just say dist x plus dist y. And this will give us the distance between x and y. So this math right here. Not between x and y, but the distance between those two values. x1 and y1 and x2 and y2. Or yeah. All right, and that is the basics for this right here. So that is how we calculate the distance between X and Y of two items. And now we can close that because we don't need it anymore. And also it seems like this dot notation works. Since my IDE auto completes that, I'm just going to leave it like that. So you can just use this instead of slash from now on. But in the game code that I'm going to provide you, if you ever download the code, it's going to use slash and not dot. Cool. So let's remove the debugging stuff from our objects and stuff. So let's go here and to the player. And here where we take in debugging, we're not taking that in anymore. It's now global scope. And it's called show debugging instead of debugging. So debugging right here. So instead of debugging, we can say show debugging because it's global scope. And you don't have to because Lua will automatically know. But I would recommend you go require global like that, because right there, so you want to require that. This isn't required to do this is an optional step, but I do recommend if you're going to use global stuff here. Then you can close player. Now here in main, where we pass in show debugging, we can remove that. And we can actually remove this debugging as well. Now let's first go to the laser, because that's where a lot of the things are going to happen. We're going to add a few new things. We're going to make them like states. So first will be the exploding state. And this can have 3 values. It can have a 0 for safe, a 1 for exploding, so if it's currently exploding, and then a 2 for it's done exploding. And then also an explode time, and this will hold how long it has been exploding. So if you want it to be on the screen for like 1 second, then this will allow you to keep it on the screen for 1 second. Cool. Now let's go to move right here. And let's first check if it's exploding. So if self.explode time, if that is more than 0, then we know we are exploding, because otherwise it will always be 0. But if it's more than 0, that means we're currently busy exploding. So self.exploding is equal to 1. What I actually recommend you do is you set some sort of state to help you with this. For example, local exploding enum or something like that. And it will be a table that is like not exploding, and it will keep 0. And then exploding, and that will keep 1. And then I think there was the last one for if it's done exploding, like done exploding. That's equal to 2. I'd actually recommend you do this instead, just to keep things simple for you and for your future self. Because if you're going to continue working on this, then having something to manage it is the smartest idea you can have. However, once this course is done, I'm done with this project as well. So I'm not going to add it. To me, it's not necessary. While we're here, let's set the explode duration. Explode duration. And I'll just set this to 0.2. You can change this later depending on what you think is the better time to explode. So the more you make it, the longer it will be exploding. Now we need to implement a function that once we want to explode, we can. So we can go here and say explode is equal to a function and just takes in self. And this will just explode in quotation marks our laser. Now we're not going to mess with the explode time just yet. Currently we just want to remove everything. But for right now we can say if self.explode time is more than explode duration, then end self.exploding is equal to 2. And this will just make it explode. And it will kind of allow us later to do some exploding animations. Next up, let's maybe go to Asteroids. So we can go here, we can open up Asteroids, and we can implement our stuff. First, let's take out debugging. We don't need that anymore. And now we should have something that wants to debug but can't. There we go. And we can change this to show debugging, and we can require globals like that. And boom. Now that that has also been done, we can now go to game.lua. And here it goes to Asteroids and it adds this. We don't need that extra one anymore because that was just for debugging. Debugging is now global. If you turn debugging off, everything will have debugging turned off. If you turn it on, everything will have it on. You don't have to individually go change which one has debugging and not. So now let's go to the player.lua and we can go to the way bottom where we are at. So right here we're getting the index and the laser. And now we want to check if the laser is exploding. So for right now, none of this really matters. We can just go if laser.exploding. So if the laser is exploding, and we're going to make sure if it's 2, then we can just say self.destroy laser. And this destroy laser, if you can remember from the previous video, it just destroys the laser. It's very simple. This is going to become a bit more complex in a second, but I just want to get the idea out. Next, we can go to lasers. And when we go to explode, we can just make it disappear. So we can just actually, for right now, remove that. We don't need that. We can just set the exploding to 2. Now, once it explodes, it's going to set the exploding to 2. So we should also go here and say if if laser dot distance, so it's the distance it has traveled, if it is more than the max laser distance, so actually this right here, so let's actually just go here instead, and let's just go and add and, because it already has the first part. So if it has traveled the distance of the max it can, and the laser dot exploding is equal to 0, so only if it's not currently busy exploding, then we can explode the laser. So we can just go here and change this to explode. And this can now be laser : explode. And it doesn't need anything. This destroy laser, however, needs self and index. So we will now actually see if it works. We'll move this explode up. So if it works, it should disappear once we run it. So shoot. It's gone. Okay, so it does work. We can now just make it work better because, as you can see, they do disappear. Alright, now that we know it works and it disappears, let's upgrade what we have. So with this explode, we can then say self.explode time is equal to math.seal to make it go upwards, explode duration times, and here we can just say love.graphics.getFPS, and there should be timer.getFPS. Yet again, I would recommend we actually use DT, but in this scenario, it's not too important. And we can divide it by 100. And this will basically say how long it has been exploding for. Then we can go here and say if self.explode time is more than explode duration, we can just put that there, and exploding is equal to 2 then. Now, as we know, if the explode time is more than 0, so if explode time is more than 0, it will set exploding to 1 for us, and then it will be busy exploding, and we can draw things here like it is busy exploding, like some nice things. Now, the nice things I do want to draw is maybe like a yellow and an orange explosion animation type of thing, and it will just appear once it's busy exploding. So let's go here where we draw everything, and we can just say if self.exploding is less than 1, so if it's not 1 or 2, if it's 0, then we can just do this, what we've been doing this whole time. Otherwise, if it is busy exploding, we can go else. Then we can say love.graphics.setColor, and this will be of the outer explosion, so the bigger explosion. And we can just say 1 for complete red, then 104 divided by 255, and then no blue. And you can also pass in the opacity in case they're pausing. And then we can set the color for the inner explosion, so the smaller explosion inside. To give an example of what I'm talking about, let me just go here. If I shoot, as you can see, it's paused, but as you can see, there's like a little orange part, and then inside of it, there's a yellow part. And that's what we're currently doing. We first did the orange part, we're now going to do the yellow part. And let's actually just copy this love.color. And yellow would be a bit more greenish, so 2, 3, 4. And actually gives it like a yellowish color. We're going to go here and say love.graphics, and we can draw a circle. Circle, and you could of course make this way more complex and cooler, but I think this is fine for now. Fill, and then self.x to give the x position of the laser, and then self.y to give the y position of the laser, and then we want to make it a special size. We can first just make it a 7, that's not very big, but the bigger one, and we can just go times 1. The bigger one, however, will be times 1.5. So it will be a teeny weeny bit bigger. So around 10, whilst this one here, this one will just be 7. You can even remove that if you want and just have a 7 there. But this would be 7 and this would be almost 10, maybe 10. But yeah, you could make this more like 2, and you could put this in a variable to make it a set size and you just add to it. But yeah, it's up to you. You can change this so it's not math, it's just a number that you put in there. It's up to you. Now let's go look here. If we run this, then at 62 instead of our laser, we have a problem. So right here, and this should not be and, this should be times, my bad. And now if we run it, we should not be getting any errors. Cool. It's not going to quite explode as we want just yet, because if it doesn't hit anything, we don't really want that explosion animation to happen. It should just disappear. Otherwise, it would be kind of weird if it just randomly flew and then boom, it exploded. Then that would be a bit weird. Cool, let's go to player. So first, this laser move, we don't always want to move the laser. If it's busy exploding, the laser should just stop moving. Otherwise, it's just going to hit an asteroid and keep on moving, which is a bit weird, but could be cool if that's what you want. So we are already doing the whole explode thing here. So let's go here to where we say exploding is equal to 2, and let's add another if statement above it. And this one can be if it's 1. I mean, not 2, but if it's 0. So if it's 0, then we just want to move, because then it's not currently exploding. So we can just go like this. But yet again, we sit with the problem. It can move and it can explode on the same time. So we can just go here and say else if. So it's either this one, else this one. But if it's not 0 or 2, it's not going to do either of these. So if it's 1, it's just going to stand still, and it's not going to remove the laser from the screen. Because here it removes the laser from the screen, and here it moves the laser. But if it's 1, it's busy exploding and showing us that orange and yellow, so we don't want to then move it or destroy the laser just yet. Alright, now let's go to main, and here maybe an update. I'm just going to hide this. We can now go and go 4, and we don't need the index, we just need the laser, and we can just say player.lasers, and here we go laser colon, or we don't need to explode just yet. First we need to calculate the distance. So if, and then we can just calculate distance, which is coming from that global file, so require globals, so that's require distance. We then go laser.x, laser.y, so this is the first one, this is where we are, and then we need to go, or then we need to add where we're going, so the asteroid, asteroid.x and the asteroid.y, and this will calculate the distance between the two. If it is less than the asteroid.radius, so if this right here is less than this radius of the asteroid, so if it has entered the radius of the asteroid basically, then we want to laser colon explode, so then we want to explode the laser. Let's see if that works. And that's going off screen, and there we go. Pew. And it is, although it's not doing much. it is there. So we give it a shot again. As you can see, now if it enters or almost enters, depending on how the circle is positioned, then there we go. Now if we were to turn on debugging here, so if we were to open up globals again, and we were to make debugging true, we could see where the laser will explode. So the red circle is where it will explode. So it won't necessarily explode on this part right there. It will explode once it hits the red circle. Cool. Now once we do this, we need to also destroy the asteroid. So let's go here to Asteroids, and we can add another function right underneath move. You can also call this explode. I'm going to call it destroy because you're destroying the asteroid, but it's not necessarily exploding. So destroy is equal to a function, and this takes in self the asteroid table. So this asteroids table will be provided to us. It is to basically get the asteroid we want to destroy. You could put this somewhere else, so you don't have to make it part of the asteroids. In fact, it would make sense if you don't make it part of the asteroids, but it would also make sense if you do. It's up to you if you make it part of the asteroids or not. But then we also want the index of the one we want to destroy, and then we want to take in the game as well, so the game state. And I'll show you why we'll need all of this in a second. First, let's just remove it. So table.remove, and then from the asteroids table, the index. So these two we're passing in. So let's quickly remove game for now. Now, if we have this, we can then go here. Let's include game. It's not that big of a deal adding it here. Then here we can say asteroid : destroy, because if it's here, then that means the laser has penetrated the asteroid, so we need to destroy it. And we can say asteroids, then the ast index that we're getting here. So this is the table, and this is the index. And then you can just pass in game as well. Game, which is right here. If we save this, then the asteroid should also be destroyed once we hit it. As you can see, it's gone. We'll do it again. And then my player is gone. Very annoying bug. I go here, shoot, gone. Now we want to split the asteroid up into multiple smaller asteroids. So let's go here to asteroids, and where we say destroy, we can then go local min asteroid size, and this will be the minimum size an asteroid can get. And you say math dot seal, and you could put this right here. You could put it like up here. That will also be perfectly fine. I'm just going to do it here because why not? And we can say asteroid size, so the current asteroid size we have, divided by 8. You can change this to fit you however you think would be best. Then if self.radius, if it's more than min asteroid size, then we want to basically split the asteroid in half. So table.insert asteroids table, so into this table right here, an asteroid object with the position of self.x, so the current asteroid x position, self.y, self.radius, and then the game.level. We can just go here and say self.radius. If we go up here to draw, or not draw, but here, we're taking in x, y, the size, and then the level. And then here we could make another one, and now we have 2 new asteroids. Now, if you wanted to, you could make this you can go another step and add another asteroid, but only once one of these asteroids has been destroyed. So then it splits up into 3 smaller asteroids. So once the second smallest asteroid has been destroyed, you split it up into 3. So the big asteroid, that splits into 2, which are smaller asteroids. And then this will also split into 2, but you could make it split into 3 if you're not too lazy. However, I'm going to leave it as is because I'm fine with it as is. If we run the game and we shoot, there we go. Now it's split into 2. There we go. Now that's also split into 2, but you could make it split into 3 if you think that's better, and it will be more challenging. We go here, we shoot. Now there's 2, and then you can destroy the rest. And then here we go, and the pew 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 pew, gone. And yeah, that is the basics of adding collision detection to our game. Now, we're not going to implement quite everything just yet. We're going to implement the basics of destroying the player. But a lot of the things that we're going to also implement will come later along with different parts of this tutorial. So things will maybe be coded out for the future's sake, whilst other things will just be left for later. But yeah, so to give an example of what we'll be doing, we go here, we fly, boom, there we go. So first, let's open up the globals. I want to add another item here. So destroy ast for asteroid. Now, you could put this inside of the asteroids object, and I would encourage you to do if you want to. However, this global object will make it a lot easier to manage this in the future, since we will be using this destroy asteroid in multiple files. Cool. Next up, we can open up the player. And it will be a lot like our laser course with collision, but this won't just be for the player. So a lot of the things will stay the same, but just a bit modified for the player. For example, local explode for explode duration, and that would be 3. So this is how long in seconds, in this scenario 3 seconds. Then we can go here and we can say explode time, so how long it has been exploding for, so we'll make that 0. Exploding, so if it's currently exploding, we can make that false. And unlike with the lasers, we don't need a third item in exploding. It can just be either it's exploding or it's not exploding. We don't need a third one. Since usually what will happen is, if it has finished exploding, unlike with the laser where it just disappears and you can just shoot another laser, here if the player has exploded, then once the explosion finishes, we'll start a new game. Or not a new game, but just we'll put the player back and we'll respawn the player basically. And we'll do that in a future tutorial. Cool. Now first thing we can do is we can close this, we can close this, and we can draw the player exploding. So right here before the thrusting, because we don't want to thrust or move or things like that if the player is exploding. So we can say if not self.exploding. So if it's not currently exploding, then we want to do all of this. And here we can just say we can just say end for now. It's fine. And we can indent this. So if the player is not currently busy exploding, allow the player to thrust forward and to move around and whatnot. However, if the player is exploding, then do something else. So draw something else. And this will be very similar to our laser, what we have drawn here. So this right here. So we can actually copy that. It will just be modified a bit. And we can paste it here. So first, we want the largest circle to be just pure red, just to give it more intensity, because the ship itself is much larger and much more complex than a laser. So we want the ship's explosion to also look like it means more, because it does mean more than the laser. The laser explosion disappears faster and it only has like 2 colors and it's very small. Here we want it to be rather large and to have more than 2 colors to show, hey, this is some big thing that exploded here. This can stay the same. However, this time we can use self.radius instead, because we now have a radius to work with instead of just a dot. Same here, we can say self.radius and then just ×1, or we can remove it and it doesn't have to say ×1 at all. Then here we can say 158 to give it a nice little color here. And then if we were to copy this, paste it here. And in here, we can say 2, 3, 4. This will be the smallest one, and it will be 0.5. So you can see how they scale in size now that we use times, and now you'll understand why we use times, to help it scale without us having to do much. And this is how it will look once it explodes. We'll take a look on how that looks in a second. Currently, let's actually just allow the player to explode. So let's go to the move player section. I'm just going to hide this draw. Then the move player section, this whole part here, we can just say if not self.exploding, so if the player is not currently exploding, then we can do everything and then paste that in there. And we can just indent, and there we go. So if the player is exploding. Now you can set if the player is exploding by going self.exploding is equal to self.explode time. Could you please autocomplete? There we go. If that is more than 0. So this will return true or false. So if the explode time is more than 0, then the player is exploding. Cool. So this will only execute if it's not exploding. However, take note that we don't want to actually stop the lasers. So this whole section here for the lasers, we can move that to underneath the end of this if statement. So this one right here, it does not hold the lasers. The lasers can still move and stuff. If the player explodes, the player explodes. But the lasers are not affected by it. We can then save. And then finally, we can implement an explode function. So that's a function, takes in self. And now we can just say self.explode time is equal to math.ceil. We can then specify explode duration times love.timer.getFPS. There we go. So this will explode the player for us. We can then go here to globals. Not globals, my bad. We can then go here to the main file. And here where we have an update, we can go to when it's running. So right here when it's running. Then we have our move player first. Then we do our asteroid stuff. Then here in the asteroid stuff, we can go if the player is not exploding. So player.exploding. So if the player is not exploding, we can copy this line of code for the laser like that. We can paste it here. And this will allow us to check if the player has collided. However, we don't need this for loop. So we can just remove that, unindent. You have a calculate distance, but this time instead of the laser, it's the player. So the player X, player Y, and then player explode. And in here, we also want to go, and then instead of saying asteroid destroy, you want to say asteroid or destroy asteroid is equal to true. And this is in our globals file, destroy asteroid. If this is true, we want to destroy the asteroid. However, we don't need to set that here. We're only setting it here if the player specifically explodes into an asteroid. And you will understand more about why I did this in the future, or why we are doing this. Then here we can say else, so if the player is exploding, then player.explode time is equal to player.explode, oh gosh, I can't type. Player.explode time -1, so it will decrease if the player is exploding. Then after this for loop, we can go if. So if we want to destroy the asteroid, then you want to set destroy asteroid to false again, because we're destroying the asteroid. And then we go asteroid destroy. And we can just actually copy this whole asteroid destroy thing because it's the same code. Now, one reason why we are doing this right here and not this here as well is because here there are multiple lasers that's going to try and destroy the asteroid. So if two lasers collide with different asteroids at the same time, we're going to have a problem, because what is it going to do? Destroy asteroids is true. So what? If you understand what I mean here, because if two lasers collide against two separate asteroids, but destroy asteroid is true, it's just going to be incredibly confusing. Anyhow, then there we have our ast index and we have our game, and then here we can move the asteroids. Now let's run the game and see if we explode. Boom, and yep, the rest of the asteroids are moving. However, if we go and we fly against an asteroid, we can still see our player. We don't want that. We don't want to see our player. So we should go here to player, and we should make sure we got the if-else statements correctly. So if not exploding, then everything is just held in. I mean, this is for the moving, it's not for the drawing. Okay, let's go to draw. Now, let's see here. If not exploding, then we can do everything in here. However, if the ship has exploded, then let's see here what's happening. Alright, I see. So here we already have a bunch of things, but this is only for the thruster. We need to include everything as well. I kind of missed all of this. So let's just go like this. And we can just cut. And we can go here. And we can just say paste. So now we'll not only just not draw the thrusters, but we'll not draw anything else while we are exploding. So if we go like this. And now if we were to try and hit an asteroid, we can't see our player anymore. And there we go. We've implemented collision detection for the player. And hello everyone, if you're enjoying this tutorial, please leave a like and subscribe for future tutorials. In this tutorial, we'll be adding lives to the player. So once the player explodes, instead of the game just ending, they have a few more lives they can spend before the game is completely over. So let's get started with that. First, I want to give you an example of what we currently have. So if we were to go here and say Love2D, this is what we currently have. There goes our asteroid off screen. So it should appear right about there somewhere. Yeah, and boom. We explode. And we just kind of continue. Just very boring. However, when we explode, that shouldn't happen. Or when we hit something, that shouldn't happen. In fact, this should happen. So this is an example of what we'll be doing. So as you can see at the top, our player lives are there. When we hit an asteroid, the player lives, they go red, they disappear, and we start in the middle of the screen again. And we can use up all our player lives until we are no longer there. Once we are no longer here, then game ends. The last asteroid does not explode once we hit it. That is to prevent a bug. But you don't have to worry about that bug because I'm fixing it here for you anyways. But let's get started. So, first we want to now take in the num lives. So how many lives the player should have. Then down here we can just say lives is equal to num lives, or by default it can be free. So if you don't pass in a number of lives, it will be free by default. Next up, let's draw the player lives. So maybe right here underneath draw, we can say draw lives. This is a function that takes in self and faded. Cool. We can copy a lot of things from this player draw. So if you do not mind, I am going to copy basically everything from here because a lot of this code is copy paste from what we already do in draw. Because first we set the opacity. Depending on if it's faded, the opacity will change. And in here is where it fades a little bit from what we do usually against what we want to do. But we'll still keep a lot of this. For example, this right here, we want to keep this. So let me just delete this part here and this laser part as well. We can keep this polygon. And this color, we can remove the debugging because we won't be doing debugging on it. And we can also remove all of this. And now we have a bunch of the code already given to us because we have already coded a lot of this. Nice, let's just indent this to there, that's much better. Now, first we want to say what color our lives should be. Because if we go back to this example I have, and I can just move it over. Now as you'll see, if we have 3 lives, then it's white, the same color as the ship. If we hit an asteroid, then it becomes yellow. And if we hit an asteroid again, where we only have 1 life left, if I don't miss the asteroid, which I did again, my aim is terrible. And now it will be red, because, hey, you should watch out, buddy, you only have 1 life left. And that's what we want to do here. So we want to set the color depending on the amount of lives the player has. So first we can say if self.lives is equal to 2. So if they have 2 lives, then we can copy this right here, paste it there, and we'll modify it in a second. Then we can say else, and this will also contain an if and an else. So we can go like this. And then we can just copy this and paste it here. And we can remove this. Now, if they only have 2 lives left, we want to make it 1, 1, and then 0.5. And this will make it a kind of a yellowish color. If they have 1 life left, then we want to make it red. But not completely red, just a little red. So it will be red and then 0.2 green and 0.2 blue. And in here, if they have 3 lives, so if they have 3 or more lives in this scenario, because this is 2 and then 1, if you want to add like 5 lives, you can maybe add more colors, or you can just make them all white until it hits 2 and then it will change color. Anyhow, if they have 1, it will be red, and if they don't have 2 or 1, if they have 3, it will be white. Now in the draw lives, we need basically to get the X and Y positions, or to give it a default X and Y position. You can make this like a more globally state one, like put it here, or even put it here. It doesn't really matter too much. In this scenario, I just want it here at the top of the screen. So I'm going to do an easy local X pos Y pos is equal to 45 and 30. So X would be 45 and Y would be 30. So 45 from the side, 30 from the top. Then we can create a for loop. So for I in 1 to self dot lives, so the amount of lives we have. And we want to basically draw 3 lives. So we can just plop that in there because the lives are the same shape as the spaceship. And we can go if we are exploding. So if self dot exploding, then if I is equal to self dot lives, so the amount of lives we have. So we don't want this to happen if we have less lives on the screen than what we currently have, or more, you know. Then you want to basically make the heart completely red. So love.graphics.set color, and then 1, 0, 0. So basically, once we explode, then it should change the color of the spaceship to pure red until the explosion is over, in which case it will switch to whichever colors are here. Cool. Then down here, since we can't just draw the spaceship on the same position or at the same position everywhere, we need to specify a few things here to make the lives go on different locations. Because if we don't, then the lives here, there won't be 3 lives. Like I wish I could show my cursor here, but there won't be like 3 lives there. There will only be 1 and 2 others on top of it. So we need to specify where to position it. So instead of self.x here, we can go and say I, so the current index we are on, or the current position, times x position. And this will give it its wanted x position. And then as for the self.y, since the y will never change unless you make it go in a x direction instead of or in a y direction instead of an x direction, then the y will never change. So y pos. But if you wanted to, you could make the hearts go from top to bottom instead of from left to right. It depends on what you want. Personally, I think going from left to right is perfectly fine. But once you have done that, then boom, we are basically ready to go. Now, we also need to remember that we don't want these to change angle with the spaceship. You could, there's nothing wrong with it. It's just if you make it change angle with the spaceship, then that it could kind of make the player a little bit confused about, like, while he's playing and suddenly he sees the spaceship hearts moving as well. It could be cool, but it could be very distracting. Personally, I think it's too distracting and I'm going to remove it, but you don't have to if you think it's a cool feature. Instead, we can go here, select all of these, and remember this view angle we created here at the top. That is the default angle our spaceship is always at. So we can just specify view angle instead. So now it will always face 90 degrees and never change. But if you wanted to change, then you can 100% do that. I just don't care to make it change. Cool. Next, before we continue, I would like to go to globals and make sure this is here. Just to make sure that is there. So if you forgot about this, just put it there. Nice. So next up, we can just go to the main file and let's draw our lives. So let's go here and we can say player : draw lives. And if the game is paused, so game.state.paused. Because if the game is paused, we want it to be faded. And here we go. That shouldn't be an and symbol. My bad. That should be a times. Okay, now let's try it. There we go. So now our lives are right up here, as you can see. So that's nice. Currently, if we hit an asteroid, nothing's going to happen. We're just going to kind of die and then respawn and then hit them again and again and again. We don't want that to happen anymore because we now have lives. We want the player lives to decrease and the player to restart from where he was or she was. So let's go to the top and let's see. And this is not the right file. We go to menu and here where it says explode time and then what the explode time does, we can go and say if player.explode time, if that is equal to 0, then we want to go if player.lives -1 is less than 0, meaning if the player doesn't have any lives left, then game : change game state to ended, because if the player's amount of lives -1 is less than 0, meaning they have like -1 lives left, then end the game. And we should make this less or equal to, because, yeah, just because. But you could make it less than 1 if you wanted to. Because let's say the player has 1 life left. Now they hit an asteroid. Now 1 minus, or now the player lives, changes to 0. And 0 minus 1, that is -1, and that's less than 0. So in return, it should change the game state to ended. Because if the player has 0 lives left, then we don't want the game to continue. And then we can just say return, because we don't want this to continue the loop, or to continue this loop. Nice. Otherwise, just always go player is equal to, and then a new player, and then the player dot lives -1. And there we go. So now the player will always have 1 less of a life once they hit this, or once they finish exploding. And I should save without formatting. Now if we run this, and let's see what happens when we hit this asteroid. We lose a life. And we start back at the screen. The reason we started back at the center is because we create a new player, and when we create a new player, the player by default is in the center of the screen, because that's what we hard coded here, in a sense. We basically said, hey, once we create a new player, put them in the center X and Y. And that's what's happening here. We're creating a new player and storing that player in the old player variable. So don't get too confused here. We're just creating a new player object, storing it in here, but it kind of has a lot of the old player stuff. By that, I just mean the lives. So yeah, now if we hit an asteroid, we go, we lose a life. Now we have less lives. We hit another asteroid, we lose a life. Let's hit another asteroid here. And there we go. Now the game has changed to ended state. Okay, meaning it's basically over. Now, I still want to do a few more things before we continue. So here, if destroy ast, we can now go if and then else. Now inside of the else, we can now put this, and then this if statement can check player.lives -1. If that is less or equal to 0, then we want to go if player.explode time, if that is equal to 0 as well. Then we want to set this here as well. So basically, if the player lives is less or equal to 0, basically the same check we did here. However, this check will not execute quite as quickly, because this one will execute after this check. So this check may be false, then this executes where this check could be true, but it executed after. So see, this executed after this right here, so after the check. So player lives here could still be 2. Then we go here, and then player lives is 1. Because remember, code goes from up to down. So we're doing the same thing here, but now it's here at the bottom, and since it's going up to down, it will trigger this. And then we check if the explode time is equal to 0, then just do everything as normal. However, if the explode time is not equal to 0, then just don't do anything at all. The reason for this is once we basically finish the game, once we basically get to the last asteroid and we hit that asteroid with our player, it can cause a few issues. And this will just cause, or this will just fix a bug in the future. But you don't have to worry too much about this. Just put that there. We save our game, we run our game, and now we fly, we hit, we respawn. We wait for our targets to come back, we fly, we hit, we respawn. And now for the last one, we fly, we hit. It doesn't get destroyed immediately, and that is exactly what we want, because that could cause errors. Because let's say that's the very last asteroid before we go to the next level, and then it wants to go to the next level once we hit it. But once we hit it, we have our last life there, it's not going to be a good match. Because let's say we only have 1 life left, and there's only 1 asteroid left. Once we hit that asteroid and we lose our 1 life, it wants to go to the next level, and this is in the future once we implement levels. But if it wants to go to the next level, and we just lost our last life, that's going to cause a few errors. And so we say, if we hit against an asteroid with our last life, then it's game over. Then we don't get that point or anything like that. In this tutorial, we want to add a menu to our game. So to give an example of the menu we're going to create, we go here, we have our little player circle. We have a quit, we have a settings, and we have a new game. If you click on quit, it will quit the game. Settings will be your homework, so clicking on settings will not do anything. And then clicking on new game will start a new game. Then let's go here. And then once we reach our last life, it will give us a game over screen, but we have yet to implement that. But once we finish implementing that, then after the game over screen, it will take us back to the menu screen, and that is what we want to do. Okay, but this tutorial is going to be pretty long, so we won't be doing the ending screen just yet. So first, let's go here to the game.lua file. And let's go to the top. And here where it says state, I want to change all of the other states to false and the menu state to true. So by default, the menu state will be true. Meaning, once we basically start up the game, it will give us the menu state. Not currently, but it should give us the menu state. Cool. Next up, let's create a new component. So component, new file, and then button.lua. And this will be the buttons we want on the menu screen. Unfortunately, the menu screen is legitimately just buttons, so we have to do this before the menu screen. We can just say local love is equal to require love, and then local text, because we're going to need text to display the buttons, is equal to require components dot text or slash text, depending on if dot text doesn't work for you, you can go slash. Both of them work for me. We can now create a function and call it button. It will take in quite a few things, so we'll get to that. And then return button. So let's get everything already ready in here. Let's just say return and then in there. Now a button will take a lot of things. First, once we click a button, we want to execute a specific function for that button. We don't want to implement that function inside of the button itself, because if we do that, then it could cause a little bit of a problem with us needing to basically for every scenario code a function. So it's better to pass in a function and then to execute that function on button click. So we can say func for a function we want to take in. Also the text color of the button, the button color itself, the width of the button, the height of the button, the text on the button, where the text should be aligned to, so the text align, the font size, and I know this looks like a lot at the moment, but believe me, we'll go through all of them slowly. The button X position, the button Y position, the text on the button's X position, and then the text on the button's Y position. Cool. So now we have the basics of a button here. Now first, let's say local btn text for the button text is equal to an empty table, and we'll get back to this in the future. Then our function is equal to the function passed in. Or if there's no function passed in, we can then say or function, and we can just remove this end, or we can just not remove it, but just bring it to the end of this statement. So one-liner function, print, and we can just print this button has no function attached. So basically, if they save or if they click the button and they didn't add a function to it, it will print out to the console, hey, there's no function attached to this button, you can't click it. Next up, I want to position the text of the button. Now, if you remember from the previous tutorial or from the previous game we made, where if I were to go here, as you see our buttons, they have a little space here. But if you could remember from the code we wrote for these buttons, is that the text in the button is positioned relative to the button itself. Meaning, if we position a button here, then and we say the text is 10 pixels to the right, then it's going to be inside of the button by default 10 pixels to the right. Meaning the text isn't going to be 10 pixels from the border of the screen. It's going to be 10 pixels from the border of the button. If you can't quite remember what we did here, I do recommend you maybe go back to the files and just go check on how we created that button. And maybe that will bring back some flashbacks. But it's not a big piece of code we have to write for that. So let's quickly do that. So if text y, so if the Y position was provided, then btn and then text dot Y will be equal to text underscore Y plus button Y. So plus the Y position of the button, because it needs to be the amount we give it plus the button. Otherwise, we'll have to manually calculate, if we want it on the center of the button, where the center of the button would be relative to where we already have it. So we anyways have to do this later on if we want the text to be inside of the button. And you can still make the text outside of the button even with this method here. You just use minus or just a massive value, depending on what you want to do. Anyhow, let's continue because it's a big file. Then we can yet again just go like whoop, go like this, and then do this, but without this. Now you have a choice here, and let me just go back to my here. You have a choice. You can either do this if-else statement, or you can go here and say Y is equal to, and then button Y, and then you can remove this part here. This will work just as well. So it's up to you what you want to do. However, I'm going to use this else statement here. You can then copy this, and now you can do it for X. And in here you can just change this to X. And there we go. We have just as quickly added our X and Y positions for the buttons, or for the text on the button. Now let's go here and we can just say text color is equal to text color. Or if they didn't specify text color, we can just make it white. So R is equal to 1, G is equal to 1, and B is equal to 1. Like that. And we can do the same for button color. So button color is equal to button color, or, and we can just copy this one here. However, the difference will be is that by default the button color should not be white, because the text is already white. So if they didn't enter the text or the button color, you want to make sure that the text is still visible, since the button would now be black. You can swap these two if you want to, but yeah. And we can go the width of the button is equal to the width we enter, or 100. And then the height of the button is equal to the height we enter, or 100. The text is equal to text, or, and you don't have to specify or with any of these. I'm just doing it for in case I want to leave something out, or in case you might want to leave something out in the future. The more customized this is, the more things you can later on leave out. Anyhow, and then no text added. So if no text was added, we can just put that there. Or you could force it, it depends on what you want. The text X position is equal to the text position passed in. And we're not using this text position here quite yet, but you will see in a second where we use that. Or we can make it the button X. Or if they didn't specify at all, we can just make it 0. We can do the same for the Y text position, where all the X's are just Y's. And we can go here and say the button X position is equal to the button X position, or 0. And then the button Y position is equal to the button Y position, or 0. Cool. And then finally, we need to use a text component that will put the text on the screen for us. And we already have a text component that's been imported right here. And every button will have its own text component. So we can just say text component is equal to text, and then we can just pass in all our values. So we can say text btn text.x. So here we use the button text, but here we specifically use the X and Y given to us. And we can of course do the same, but for Y. And as you can see, also our documentation is here, which is very nice. And this is some documentation we did a while back. So here we go, and as you can see, we did a bunch of documentation, and now the documentation appears as I'm trying to edit this. So that's pretty neat. So now we know we need the font size, and the font size is passed in. And then also whether we want it to fade in, which is false. We don't want it to fade in unless you want to add some animation. Fade out is also false. The width, and then the text align like that. And then finally for the opacity, we can just pass it 1. We don't want to change the opacity. However, if you have buttons in your game, you want to make this a dynamic value. So value passed in as a variable and not just one. So it depends on what you want to do. If there's buttons in your game and not just in the menu, so when they pause and you want it to fade out when you pause, then making this an actual variable would be better, because you can change the variable later. Let's draw the button, because I actually want to get the button on the screen. So draw is equal to function self, and we just add in our comma. Then here we just say love.graphics.set color, so the color we want the button to be, and we can go self dot button color and then just specify red, and we can do that for all of the colors we have. So let's do that. And there we go. Now the color will be set to what we want the button color to be. Then we can draw a rectangle. So love.graphics.rectangle. And we can just say fill this rectangle. Or don't fill it. It depends on what you want. But I would like to fill it. Since it's a button, it makes sense to fill it. Self, then the button X. Self.button Y. Self.width, and then self.height. And this will draw the button for us. Next up, we need to do the same, but instead for the button, we need to do it for the text. And we also want to reset the color back to white. So here we can go here, but instead of button color, we now go text color. And then we can just say self.text component dot draw, or just colon draw instead, and this will draw the text component for us because it already has its own draw function. Cool. Now that's the basics for the button. We'll be getting back to this a little bit later in the tutorial. I just want to get the button on the screen right now. Next we can go and we can create a new file in the states folder called menu.lua, because it's a new state we have. And then you can require love, so local love is equal to require love local button, and it should be with capital B, is equal to require components.button. And then we can say function menu takes in nothing yet, and then we can just return a table, and we can return menu, and this will return a menu for us. Now we can just take in the game and we'll get to Y, and then the player and we'll also get to Y. Next we want to draw the buttons, and the buttons are pretty big, so local, and let's just draw one for now. Buttons is equal to, and then here we say a new button. The function we have, we can just say nil for now, because there's no function. Then the text color, which can be nil, and then nil again for the button color. The width can be love.graphics.getWidth divided by 3, and it will give it a nice, rather smallish width. And then the height can just be 50. The text can say new game. It can be aligned in center. I need to make that lowercase c. The text size can be H3, or the font size. The button X position can be love.graphics.getWidth divided by 3, and it will kind of make it a little bit in the center. And then love.graphics.getHeight, and this is for the Y position, and this can be times 0.25, and it will kind of make it go a quarter way down. Okay, so these are our buttons we have. We'll add more a little bit later. So here we can just say draw as a function is equal to function taken self for and then underscore button in buttons. So for every button we want to draw it, and so we just call button colon draw. Cool. We have just created our menu. We'll get back to this a little bit later. We can go all the way up to load. And now we don't want this start new game anymore, because we don't want to start a new game as soon as we or as soon as we boot it up. We want to go to the menu first. So you say menu is equal to menu game player. So just pass in these two into the menu. So the menu has to be below the player and the game. Now here in the love.mouse pressed, we can just add a global scope variable. We can go here, else, and just say clicked mouse is equal to true. So if the mouse has been clicked, we'll use this later, but we don't have to worry about it now. It's just so it exists. Then we can go down here, and where it says if game state is running, we can go all the way to the bottom, and we can go else if game.state.menu. So if it's the menu state, and we can say clicked mouse is equal to false by default. And we'll get back to this a little bit later as well. And then finally, here in draw, else if game.state.menu, and we just say menu colon draw. Now when we run the game, we should be able to see a button on the screen. Okay, so it was the first attempt, so okay, we haven't imported menu yet. That makes sense. So we can just go here, say local menu is equal to require states.menu. There we go. There we go. So we have our first button. It just looks like text because the button color itself isn't a different color. We could, if we wanted to, change the button color to be something different. So here is our menu, where we set the button color, which would be this one. We can go R is equal to G is equal to 1, and in blue is equal to 0. Now this should give us a yellow button. So there's the button. I just made it the same color as the background to kind of make it more mystic, so it kind of looks like there is no button, but there is actually a button. We can just say nil back here again. And we have just created our first button. Now let's draw our cursor or mouse. Because if we go here, we can't really see our mouse. So we can just go if not, and then game.state.running. And we're not putting this inside of this menu checked state here. We're putting it inside of a not game state running. The reason for it is because sometimes we want to see the cursor even if the game state isn't necessarily running. For example, on the game over screen, we might want to see the cursor. In the settings screen, that's maybe another state, depending on how you code the game. You want to still see the cursor. In the paused state, you still want to see the cursor. So it depends on what you want to do here. Here we're just saying if it's a running state, remove the cursor, because we already have the player on the screen. We don't want the cursor as an extra annoyance. And we can just say love.graphics.circle, and we can specify fill mouse X, mouse Y, and then 10. If you want an extra nice kind of challenge, you can draw the player cursor the same way you draw an asteroid. So then the player cursor is an asteroid. That can be pretty cool. Or you can make the player cursor like the spaceship as well, but then you move over with your mouse. It depends on what you want. Personally, for me, this little circle here, that's all I need, as you can see here. So it's a nice little circle that just shows my cursor. Now let's finish implementing the button, because it's a pretty big thing we got to implement, but we did the biggest part, so it's not that big of a deal now. So first, I would like to add a function to make it easier to change the button color. Now I want a way to make the button color not only settable outside of setting the button color on create, but to also make it easily settable anywhere in the game. So we can say set button color is equal to function. We take in self red, green, blue. Then here we say self dot button color, and I'm just going to copy this because this is quite a thing to type out. We can go here, say that is equal to, and we just say red, green, and blue respectively. There we go. Now it's very easy to set the color. We just say set button color and we specify the number. We don't necessarily need to specify the RGB anymore. Next, we want to do the same but for the text color. So I'm going to copy this, paste it, and instead of saying button color, we can say text color. Red, green, blue, but instead of button color, we can say text color. Easy. Now, below the draw, we can also get or set a few methods here to get the position of the button and the position of the text. So get pause. You could also make this get button pause. It depends on what you want to do. But saying get button pause will kind of work with all of these, like set button color, set text color. So saying get button position would be smart. Pass in self, and we can just return self dot button x and self dot button y. We just separate them by a comma, so we're getting two values from this function, two of them, not just one. So take note of that. We can then go get text pause, and we can actually just copy and paste this, to be honest. So get text pause, and instead of button x and button y, we say text x and text y. Cool. We have just implemented a ton of functions that could be useful in the future. Only two more to go. I also want a function that once we click the mouse, like once we click, it should basically execute the function we have passed in here. So down here, you can just say click is equal to function, takes in self, and we can just say func. So it will just execute the function we have. Doesn't do anything special. That's all it does. It just executes that function. Cool. And then the last one is just check hover. So we want to check if we're hovering over the button. So if the cursor is currently hovering over the button. That is equal to a function that takes itself the mouse x position, the mouse y position, and then the cursor radius. Then we can just do this. I'll just paste it in, but I'll explain it. So you first get the mouse x and then plus the cursor radius. And I have explained this quite a few times, especially in the first tutorial where we did the balls. Basically, if a circle, or we have a circle, but we want to add the radius to that circle. In this scenario, since the button X is here, we want to add a radius to it both ways. That is why the button X here has the plus radius and then the button X here has the minus radius. If you haven't seen the previous tutorial where we did build a game where we like play around with balls, then I do recommend you go watch that tutorial, because it is quite a good intro to this tutorial as well. So I don't have to re-explain this right here, because that just does everything the same as what we did with our player back then. So we just check if the mouse X and Y is above a button X or and Y. If it is, we return true. So here's the X and then here's the Y checking. If it is, we return true. Otherwise, we just return false. Cool, and that is all there is for the button. Next is the menu. Let's finish up here. So let's go here and create a bunch of functions we might want to do. So local funcs is equal to a table. First we have our new game. So this is when they click the new game button. That is equal to a function. And this function just goes game, colon, start new game. And we pass in the player. And that is why we needed the player and the game passed in. We also want a quit game function. So if they click the quit button, which we'll put in a second. So quit game is equal to another function. And then love.graphics. Not graphics, that should be event. My bad. Dot quit. And this will quit the game for us once we click the button. Cool. Now we have our two functions we want to use. This button here, I'm going to copy and paste it 3 times. First here with this nil, I'm going to pass in funcs dot new game. Take note, however, I'm not passing in brackets. I'm not doing that. I'm just passing in the name. No brackets. Take note of that. And here at the bottom one, you can just say funcs dot and then quit game. Yet again, no brackets. Okay, then with this button here, we can change the text here to settings for the settings button. And since all of the buttons will be positioned below each other, the x-axis, so this get width part right here, can stay the same. But since they're pushed below each other, we can change this right here to 0.4. And that will make this button here a tiny bit more below this button right here, which is the new game button. And in here, of course, we can say instead of new game, we can just say quit. And instead of 0.25, we can say 5.5. Nice. So we have just created our buttons and the functions that go with them. Now let's see if they get drawn. And there we go. New game, settings, quit. Now we need to do a few checks. So once we hover over a button, we want it to change color to red. And if we click a button, we want to execute a specific function. So let's go down here. And first we can say focused. That will be in empty string. And then we can create a function called run. And this function just takes itself, and if we have clicked, we can then get the local position of the mouse, so mouse X and mouse Y, which is equal to love.mouse.getPosition, as we return both the X and Y position. And then we can go for name and button in buttons, so the buttons we have here. We can check if button and then check hover, which we have just implemented. We can pass in the mouse X and then the mouse Y. If you wanted to, you could have just made this mouse X Y already implemented inside of the check hover, but here I just pass it in because why not? And we can pass in 10, and this will be the cursor radius we have. I recommend you make this a variable instead, that's maybe global or passed in or something like that, because if you ever want to change the radius of the cursor, then you have to come back here and change it as well. So I recommend you make it like a variable and maybe pass it in here or something like that. Anyhow, so if the cursor is hovering above the button, we can just say if clicked, and we get clicked passed in here, then button colon click. So we want to execute the button function we have. And it's itself.focused, and this is basically if the button was not clicked in a sense, but it's not inside of an else, is equal to name, or we make it equal to name, and you go button and then set text color to 0.8, 0.8, 0.2, and this should also be 0.2. As we'll give it a nice reddish color when we hover over it. Else, we want to say button set text color 111. Currently this focused, we are not using it. We'll use it a little bit later, but it is there for once we want to use it. Cool. The menu has now been coded. But we are never executing this run yet, so we need to go and execute this run. Now it is pretty simple. We can just go here to main.lua. Here we say mouse clicked is false. We can just say menu :run and then mouse clicked or clicked mouse. There we go. And just like that, we have implemented the menu. That was like the last line of code. However, if we hover over it, we're not getting anything yet, so something might still be wrong. However, the buttons work. So if you go here, click quit, it works. If you go here, you say new game, it starts a new game. So the buttons work. However, the color is not changing yet. And right here, where we have this love graphics set color, this should actually be self.text component :set color. Which if we were to go to the text component here, it has a function called set color where it sets the color for us as well. So it has its own color function. We can then take this, what we have here, and we can paste it in here. That is why it didn't go the color we wanted it to go to. Now we have our button colors as well. If we click on settings, that will do nothing but just print out some text. If we click quit, that will quit the game. And then finally, if we say new game, it will start a new game where we can crash and we can shoot and whatnot. Alright, that was a pretty big tutorial. Well done if you sat through the whole thing. So in this tutorial, I'll be telling you all how to install LuaRocks on Windows. Now, as far as I know, there are 3 ways you can install LuaRocks on Windows. The first way you can do it is by getting the executable, the .exe file, downloading it, and then just using that. However, it doesn't work for me, so I'm assuming it also doesn't work for a lot of you. Another option is to compile it from a source, meaning you have to take the source code for LuaRocks and you have to compile it yourself, which I don't want to do, and I doubt that anyone else would want to do. Now the third option is to use Windows subsystem for Linux. So this is basically where you have a type of Linux on your computer. And I'll be showing you how to not only install or set up Windows subsystem for Linux, I'll show you how to work with everything you need to do in order to install everything you need to use for LuaRocks. Now to make sure we know how it works, I created an example which we can use if I will full screen this. So here we have a main.lua and this file sits here. Right here, so there's main.lua and there's text.json, which is inside of my documents. Now here, we just read a file. As you can see here, just ignore this part. We read a file, and then we take that file, which has JSON inside of it. You don't need to know what JSON is. You can just copy and paste this into your own text.json file. Anyhow, then we decode it into a Lua table. So we take the JSON and we convert it into a Lua table. And then we access the content inside of it. And we're doing all of this using the Luna.json module, which we installed through LuaRocks. So let me give you a walkthrough on how to set everything up. First, you need to enable Windows Subsystem for Linux, or WSL. You can just say, turn Windows features on or off. If you click on that, you should be prompted with something such as this. Just scroll all the way down until you see this Windows Subsystem for Linux. If it is not checked, then check it. So mine is currently checked because it is already turned on. So you need to check yours if it's not already turned on. Then you can say OK, and it will install it for you. This will take a few minutes, so just give it some time. After it has installed it, you want to reboot your system so it can complete the installation. So you want to go power, and then restart. It's going to say it's updating, but all it's actually doing is installing Windows Subsystem for Linux. Now, once your system has rebooted, you need to install Ubuntu. Luckily, you can just go to the Microsoft Store, so Microsoft Store, right here, Microsoft Store. And in here, you can just search for Ubuntu. I've already searched for it. There it's gone. Ubuntu, like that. And then you can just scroll down until you see Ubuntu 18.04 LTS. You can click on that. And here it will say Get. You just click on Get and it will download and install Ubuntu for you. Once this has been completed, you can just scroll down here and you'll notice this right here. So this is the command you use to start this Ubuntu system. Now I'm going to copy that, so Control C. And then we want to open up either the PowerShell or command prompt. So either command prompt or PowerShell. I'm going to use command prompt so I can look cool. Open that up. Now, to make sure you look like a real hacker, you have to say color O2. There we go. Now what you can do is you can start up your Windows subsystem for Linux by right-clicking. Right-clicking will paste whatever you have inside of your clipboard. In this case, I copied this, so it pasted this. And this will start up Ubuntu for me. Now, if it's your first time starting up Ubuntu with the Windows subsystem for Linux, then you'll have to enter a username and password. This can be anything you want, just keep it simple so you never forget it. Then once you're here, it's pretty simple. First, you want to sudo apt update, like that. Press enter. It will ask you for your password. You put in your password, and it will commence to get all of the latest packages it has. Then you want to say sudo apt update, and this will update your Linux system you have. Now, I just did an update, so I don't have anything to update, but it will prompt you yes or no to update all of your packages. Just say yes. Once you've said yes, it will update your Linux system to its latest version. Now that you have this, you want to install Lua and LuaRocks. So you can just say sudo apt, and just for in case you don't know, you can also say apt cache search, and this will search the repositories for what you need. In this case, if I say Lua 5, then here throws out everything I can download. Now you can choose between Lua 5.1, 5.2, 5.3, and basically 5.0. I want to get Lua 5.3. So I'm going to say sudo apt install Lua 5.3. And I also want to install LuaRocks. I can just say LuaRocks. Once you do this, it will ask you to install it. You just say yes, I already have it installed, so it's not going to do anything. Now, once you have this installed, you can start executing your code. So make sure that right here, you have this code and this JSON file. Make sure you have these, because this is the example we're going to use. Now currently, I am not inside of my Windows machine. I'm inside of Linux. So to get into my Windows machine, I can go cd and then a /, not a /, but a /. This will take me to my root directory. If I say ls, it will show me all of the folders I have inside of this folder. You can just go into cd mnt for mount, and in here you'll see all your drives you have. So I have the C drive and the D drive. To show you an example of this, if I open up my file manager, go to this PC, then this is my C drive. As you can see, there's C, and here's the D drive. Now the C drive, we can go here, and as you see, there's the C drive. To go into that C drive, we can say cd C, and then a /. Now we want to go into users, and then here we can just say cd users. And take note, I'm using a capital case U here because this users also has a capital case U. Then here is Cherise the Brain. You can go into that. That is my current user, who I am. Then here we can also go Cherise the Brain. Then here, to find where my things are, yours might be inside of documents, inside of desktop, inside of downloads, inside of music. Wherever you put your files, you have to go. Mine is inside of OneDrive. So here I also have to go into OneDrive. And you can press tab to let it autocomplete for you. And in here, you'll notice we have a documents folder. If I go into documents, then you'll see I have a Lua folder. And this is where my Lua stuff are. Now I can just go here and say cd documents and then Lua and press enter. Now if I say ls, I should see a main.lua and a text.json. So right here, main.lua and text.json. Now once you are inside of here, you'll see these two here. To run this Lua code, you can just say Lua 5.3 and then main.lua. If I run this, I get Jack, and that means I executed the code inside of this main.lua. To see what's inside the file, I can say cat, which means read, and then main.lua, and you'll notice it's everything I just had inside of VSCode. Luna.json requires Luna.json, and then all of this. Now, one thing I did forget to tell you is how to install Luna.json, because I've showed you how to install LuaRocks. To install Luna.json, you can just say sudo LuaRocks install Luna.json. And let me just resize it a bit so everything's on screen. Oh, so here we go, sudo LuaRocks install Luna.json. And this is how you install any package in LuaRocks. You just say sudo LuaRocks install Luna.json. You press enter, and there we go. So now it should be installed. And now, of course, if you try and run it, it will run your things. To uninstall a package from LuaRocks, you can say sudo LuaRocks. It should be remove Luna.json, and this will uninstall a package. Now, if I were to try and run this code, it will tell me it doesn't know what Luna.json is because I have uninstalled it. And then yet again, to install it again, I can just say sudo LuaRocks install Luna.json. And just like that, you can use LuaRocks. Now take note, whenever you want to run something, you now have to run it inside of your Windows subsystem for Linux, meaning this right here. You cannot run it from Windows, not as far as I know at least, because Luna.json and LuaRocks are both installed on Linux now and not on Windows. This is, to me, is the easiest method around this LuaRocks installation issue we're having. Today we will be implementing the user score system. Then, say start new game, you'll see we have now two score systems there at the top. Once we blow up an asteroid, the score increases. Go here, we blow up the asteroid, it increases, and in here we no longer exist. So you just boom, and let me just boom. Cool. Now when we go back in, I think the score is no longer there. We'll implement that later. But the idea is, once we have the score implemented, the score should stay as it is, and then we will have a high score and a current score. The high score will be implemented in a different video. It's not that complex, so we'll probably do it near the end. Cool. And just as a comparison, this is what we currently have. Move this up here. We say new game. As you can see, we don't currently have any score to speak of, which is unfortunate. So that's why we'll be implementing it right now, because that's one of the things that really makes a player more happy to see, is if they play a game like this and they have a score, and they try and beat their score every time they play the game. Now, let's go to our globals.lua. Now, I'm going to assume you have LuaRocks installed. If you do not have LuaRocks installed, I believe you can just Google LuaRocks. Yeah, there we go. And then you can install LuaRocks. LuaRocks allows you to basically just install extra packages or extra files for you to use in your programs. So let's say you want to work with MySQL, which is something you use to work with databases. Then you can go to LuaRocks and you can download this MySQL package, and now you can work with MySQL in Lua. Or if you want to make a chat app, then you can get this Lua sockets, which allows you to basically chat or create a chat app. Now I'm going to assume you have this already installed. And if you don't, you can just quickly go and install it. Just pause the video, go and install it. It would be probably as simple as it was to install Lua, if not easier. Now, if you have it installed, make sure that you have the following in your path. You need to have LuaRocks in your path. So this should also be in the installation. If it isn't, you just have to implement or add it. You just say $, and in brackets, LuaRocks path -- bin. And this will allow LuaRocks to work. And you have to add eval here at the front before this. So if we just copy this, then you have to go eval. And every time you want to use LuaRocks, you have to do this. What you can do is you can say, you can go into your bash RC, and this runs every time you start up your terminal. And let me just run that again. Now if we go down here, and actually it's at the way bottom, so let me just full screen that. So here we go there. So this is inside of my bash RC file, which runs every time my terminal starts up. So every time my terminal starts up, we make sure I can use LuaRocks. So I recommend you do the same if you're on Linux. Now once you've done that, LuaRocks should work. Now to install what we want to install, we need to type LuaRocks install and then Luna.json. This package will allow us to work with JSON, because I want us to save our file in JSON format. And you don't need to know JSON, I'll explain it along the way. A lot of people would actually prefer if you were to encrypt the save file, but I'm not going to go through all of that effort. It's such a basic game. That could be something you do on your own. But you might want to encrypt the save file so a player can't spoof how much they really got. For example, let's say they really only got 5,000 points in the game. Then you might want to encrypt the file so they can't just go into the JSON file and change that 5,000 to 50,000. But that's out of the scope for this tutorial. So we can just say install. And let's see here. And I do not have write permissions. I'm just going to go sudo and then try it again. You might want to use -- local if you have the same problem. I'm just going to go sudo just to keep things simple. Now once you have this installed, you should be good to go. Now let's go up here and we say local Luna.json is equal to require Luna.json. And we can use it just like with Love, because we've installed it. So now we have this option here to use. Now we can create a function, and this function will be called read.json, and it will read a JSON file for us. And in here we can just pass in the file name, because we might have multiple JSON files we want to read. So this is just for future proofing. You don't have to necessarily add a file name here, but just in case you add another file that you wanted to read, then it easily reads that file for you. Now I recommend having all our files inside of a specific folder. So right here, we can create a new folder, and we can call it src for source content. This can be like your audio and your files and your images and whatnot. In this case, we can just say data, and that should be a folder, data folder inside of the source folder, because this is where all our data files would go. Preferably encrypt your data files, because this is usually things the user should not be tweaking. And in here we can just say save.json, because this will keep the save file or the save data. And then all we have to do is we have to use these curly brackets, and then we just have to say high score like that. Or if you want, you can also use an underscore like that, but preferably don't use a space. That's not very good. So use an underscore or a capital case, but not a space. And you can just say 0, and this will be the score the user has. Save that, and you don't have to open this file for a long time. Cool. Now that we have that file, we can specify the file we want to read, so the file we need to open. So local file is equal to IO for input output dot open, and we pass in the file path. So you can say src. So that would be this src file or folder. Then you want to go into the data folder, so /data, and then / because we want to access this save.json. We can then just go .. file name, and then .. because you might not want all of your files to be in .json format. You might have multiple formats. .json. Now this is just how I did it in a script, but because this is saying read JSON, you can just as well not have this here and just let them enter JSON. But because I just want to enter the file name, for example, save, I just say that, then it will automatically add this .json for me, as you can see here. The end result will then look something like this. And all I had to do was enter save here, and it will produce this. And then of course here we just have to specify we want to open it up in read mode. Below that we can say local data is then equal to file : read, and we can just say we want to read everything. So star and then all. This will read everything inside of this file. And we can say file : close, because we don't want the file to stay open. And in return luna.json .decode, and we can just say data. Now once you have done this, everything should be still working fine. If you want to test it, you can still run your code of love. And make sure everything starts up, which it should. Cool. Now next up we can go to this game.lua file, because we now want to add the high score to the game, because we can now read this JSON file we have, but we want to have it display the score here. Now this JSON.decode here, before I forget, basically just converts JSON, so this right here, to a Lua object, so a Lua table. Now down here we can say score by default is 0. So by default, when you start the game, you get 0 as the score. This is the initial score for the game. And now here at the top, we also want to import save data, because now we want to read this file, this JSON file. Then we want to pass in the save data into this game here. If you want to, you could load the high score and all of the save stuff inside of this game here. But for me, it's better to rather do it outside of the game, just to keep things simple. So if you might have different functions you want to pass the same data in, then you don't have to make multiple functions in each one of those. You can just pass it in here. But we'll get to that a little bit later. Then you can say high score is then equal to save data dot high score, and this here is just a table. It's just going to contain high score for the moment. If there's nothing there, we want to say or 0, so it will default to 0. Next, we want to go a bit down here to where it says draw, because we want to update the draw. We can go up here and say local opacity is equal to 1. Then if faded, then here we just want to set the opacity to 0.5, and now we can just work off of the opacity, so we don't need this if statement here anymore. We can then just unindent this. Actually, this can still be inside of faded. Why not? Because this should only be displayed if we're currently faded. Because only if we're faded, we're being paused. That's the only time currently the game is ever being faded out. So this can still stay in an if statement, now that I think about it. And because this should be above everything else, it should be at the bottom of this drawer. If it's at the top, everything else is going to be above it. So it should be at the bottom. We can then go text to create new text we want to display. And you can just say colon draw. Then this text we want to say score. And this will be the default score the players see like when they start up a new game. Colon space and then add the self.score. Then you can position it -20, 10, and I don't think that's positioning. I can't actually remember what is everything inside of this text here. What are we doing? Okay, so first, oh yeah, so that is positioning for X and the Y position. Cool, okay. Then the font size, that will be an H4. We can say false and false, and the false and false is just for this fade in and fade out because we don't want it to fade in or out. Then we want to wrap with the line and the opacity. So the wrap width will be the width of the window. So love.graphics.getWidth. And then we can say right and then faded and opacity or 0.6. Now this is a little bit weird, but basically if it's faded, then show the opacity we have. Otherwise, just default to 0.6. And I believe you can actually go here into the Lua virtual environment and just test it out. So let's say we have X, which is equal to true. And we have 1, which is equal to, let's say 0.5. And then 2, which doesn't exist. So you can just say 2 is equal to 0. Now, if X and 2 or 1, we get 0.5 because 2 does not exist. But if we were to say 2 is equal to 1, then we get 1. So if X is true, which in this case if faded is true, and this right here has a value inside of it, then display this one here, so opacity. Otherwise, if this has no value inside of it, and this is false, then display this. So that's for that. Now we can copy this, and we can do the same for high score. So here we say high score. And now here, instead of dot score, we can say dot high underscore score. We can then make this 0. Yet again, 10, because it's going to be the same height. We can make it H5, because this shouldn't be the main attraction. The main attraction should be your score, so it's going to be a little bit smaller. Before we go, that right should be a center. And you can also change that 0.6 to 0.5. Cool, and that should draw it. So let's just save, and then let's run it and see if it works. Because that should theoretically draw it. Ah, here we go. Attempt to index local save underscore data, nil value. You know why it's giving us that? It's giving us that because inside of the main.lua, if we go up here, we are not passing a value in here. So we don't have a high score. I'm just going to say 0 for now. And let's run it and see what we get. Ah, we still get a value, or still a problem. And my bad, this should be a table. High score. There we go. And that should be an equal symbol. There we go. Now it should finally work. New game. Now we have a high score, which is a little bit faded out because remember, the main attraction is actually the player and the asteroids. And then the score is also a little bit faded, but it's bigger because you might want to see your score more than what you see your high score. Alright. Now, one thing before we continue, this right here, quite unnecessary because all we need to do is we just need to get the data from globals. and we are already requiring globals. So all we need to do is, let's say, it can be maybe like the second thing it does. Local save underscore data is equal to, and we can just say read JSON and then save, because we want to read this file. And you can just take this save data and pass it in here. Or if you really want to save space, you can just do, whoops, my bad. You can just do that. But I like doing this just to make it more readable. Now let's make sure that works, because that should read the file for us. And then once it has read the file, we should see that value. So let's go up here and just run it. Okay, high score is 0. Let's keep a look out for that. If we change the high score to 900, what do we get? Do we get the same output, or did it change? Because it should be changing. New game, and there we go. Now we get 900. So we have successfully created a save file and read from that save file. Then last but definitely not least, we now have to modify the asteroids a little bit. Because when you blow up an asteroid, your score should increase. So let's go right here, and we can say if self.radius is more or equal to asteroid size, then, so the radius is more or equal to the basic asteroid size. Of course, that's a little bit big, so we want to go divided by 2, because asteroid size is from left to right, whilst radius is halfway. Then game.score is then equal to itself, so game.score plus 20. And game now has a score on it. If we go here, you can see there's the score, plus 20. We can then go else if, and then we can go self.radius is less or equal to the min asteroid size. Then we can do the same thing as this, but because this asteroid will theoretically be the smallest asteroid you can get, we want to make them get a lot of points for destroying the small asteroids, because they can be difficult to shoot and they multiply, so they can also be very difficult to dodge at the same time. And then finally, for the medium-sized asteroids we can just say else, copy this, and instead of 100, we can say 50. And then this isn't something that's going to really affect us too much now, but we can also go if game.score is more than game.highscore. Then we want to say game.highscore is equal to game.score. Now this right here is basically whenever the player plays and their score is higher than the high score they have, then the high score will also increase along with their normal score. Kind of to tell them, hey, you are getting a new high score. Good job. And this here will of course just add a score. And we're already drawing the score to the screen, so we don't have to worry too much about that. We're going to just say Love2D to run it. Move it so everyone can see. Start new game. Shoot. You'll notice both of these, the high score and the score, increases because the score is higher than the high score. And of course, the more we destroy, the more we gain. Now, take note of this last part we added here. If we make the high score, let's say 100, then if we go back here, we say start new game, and we shoot an asteroid. My aim. As you can see, the high score didn't change, but the score did. And the high score won't change until our score is higher than the high score. Then you can see the high score is starting to change. Cool. And that is implementing a basic save or score system for our game. So to give you an idea of what we'll be doing, here we go. We say start new game. Just wait for that asteroid to come back. And then one last time for our last health right here at the top, our last life, we crash. Oh gosh, missed it completely. And then we get a nice fading game over screen. And it fades out. And after it fades out, we get new game. So first of all, I would like us to go to this menu file right here. Or not menu, I meant to say main. And here at the bottom, where we say game.state.menu and game.state.running and paused, whatnot, we want to add one more else if. We want to go else if game.state.ended. So the game state has ended. Then we just say game : draw. Because it has to now draw the game ended state, but game will already know what state it is. Cool. Now currently, this won't really do much if we were to run the game we currently have. And we were to test it out. Here we go. Oh gosh, missed it. This one has a bad collision. Then as you can see, we just get a dark screen. We don't really go anywhere, nothing's happening, because the game over state doesn't really have anything to draw yet. So let's actually add that. We can open up our game state, and we can start here at the top. Underneath high score, we can add screen text. And a screen text is just a table that will display the text on the screen once we go to game ended state. This will remove it and add it and whatnot. Then we need to add another variable here saying game over showing. And this is for the animation, so we know when the game over is showing and when it is not showing. So we know when to switch from showing the game over state screen to showing the menu state screen. So that can be false by default. Next here in change game state, we can go if self.state.ended. So if the state has ended, then we can call the self game over function. Now this game over function is what we're going to create now. Basically, it's going to do all of the game over stuff for us. So let's go here and say game over. That's a function which takes in self. And first we can set up the screen text, or the text that should be on the screen. So self.screenText is equal to a text component which contains the game over text, which will fade in and out. You could also maybe do the same and then also display the high score and the player score, also fading in and fading out or whatnot, something along those lines. That could also be a very smart idea. However, we're going to keep it simple and just do the game over screen. Just game over and then poof, done. We can say 0 love.graphics.getHeight times it by 0.4 to kind of get it in the middle, in the center, because you should remember how fonts are used. It's not necessarily starting in the middle of the font as well. It starts here at the top. So every letter has a top point and it starts there instead of in the middle. So you should just take note of that. It can be size of h1 because it should basically take all of the attention. It's the most important. And say true love.graphics and then get width and then center. Now if you're wondering what any of this means, you can always just go back to this text file right here and just look at what all of these mean. You'll notice our fade in and fade out right here is now set to true. Nothing else is basically set like this. So this is the first time we'll be really using this fade in and out functionality. Then after we have done that, we can just say self.game over showing, and we can make it equal to true because it's currently showing the game over. If it's not showing the game over and the game state is ended, then we should know that we want to switch from game state ended to game state menu, because it's not showing game over screen and the state has ended, so there's no point in showing it anymore. Now currently this won't do too much. Then right here inside of the main.lua, we can just reduce the amount of lives the player currently has. So player, and it takes the lives, so num lives, and we just make that 1. Now if we run it, we should be able to see our output. Now it should work. We say start new game. We uninstall live.exe. And boom. That is all we get. So not really anything just yet. So let's go down here. Because currently I didn't really think about it, but this doesn't really draw to the screen. So we put the text there, but we never actually drew the text. So let's go do that inside of this draw function. And let's go right underneath faded. We can then say for index text in pairs self.screenText. And we can say if self.gameOverShowing, then, and now here we want to draw all of the things while the game over is showing. So self.gameOverShowing is then equal to text colon draw self.screenText, so it's going to draw the text that should be on the screen, and then we can just say index. If we're wondering what's going on here, we can go here to text. If we go to draw, we take in the table text and then its current index. You'll notice return true or false. That's how we know if we're supposed to show it or not. If it returns false, it's not currently drawing anything to the screen. If it returns true, it is drawing something to the screen. And if you plan on adding more things here, you should just modify this a teeny bit so it can be able to do this more dynamically, because currently it's good for one thing, but if you have 2 or 3 things, it's not going to be that great. Anyhow, then you can say if not self.gameOverShowing, then, so if the game over is not showing, then self colon change game state, and we're going to change it back to the menu state. And then otherwise, if the game over state isn't showing, then we can just say else text draw self.screenText and an index. So this will basically start it off. It will start the draw. So yeah, that is about that which we'll need. I don't think we'll need any more. So let's try and run this and see what we get. If we just drag this here so everyone can see, start new game and end, then we start getting a fading out game over screen. Thanks to everything we have already implemented and why I did so much work at the start of the game, we don't have to do a lot now because we've already implemented fading in and fading out. And that is for the game over screen in Love2D. So in this tutorial we'll be implementing new levels as well as making the player invincible. Now after this tutorial the game is going to be a little bit broken, but we will be fixing that in upcoming tutorials, so don't worry too much about that. Now to give an example of what we'll be working with, what we'll have by the end of the day, I just move this here. Now when we start a new game, you'll notice the player blinks, and if I try and go into this asteroid here, nothing happens. That is because of our new invincibility we added. So when we start a new game or when the player dies, then they finally become invincible and they cannot be hurt for another while. And this is very useful because let's say you have 20 asteroids on the screen. It can be very difficult to avoid them immediately once you respawn. So if you're invincible for a few seconds, not only does that give you some time to clean up the screen, it also makes sure that you just don't immediately die once you respawn. Now to make sure that this works, if we crash in here, we'll actually explode. Then now we can try and crash into things again, and we won't. As for new levels, we can just shoot these asteroids, and I'll show you all the new levels. And one more here, right here. There we go. So now we have level 2, and there are now 2 asteroids. On level 3, there will be 3 asteroids, level 4, 4 asteroids, and so on. But it becomes more challenging because each asteroid explodes into multiple more asteroids. So it will become more challenging depending on how everything goes. Now, a bug you might encounter here is, let's say you die at level 2 here. So just give me a second. There we go. If I crash against something, it tells me it's game over. But once this game over screen leaves and we want to start a new game, then you'll notice we're kind of still in the middle of a game, but not the same game. It's kind of weird. Now, this is normal. We are going to fix this. In fact, if you want to, you can try and fix this yourself before the next tutorial. But it's just normal because we're going to play around with some of the code and it's going to cause this to happen. Okay, so let's try and implement that. Let's go to our state and open up our game state. And let's see here. Where are we now? We are now at draw. Okay. Then here in start new game, we're going to add a few new things. So at the top, we want to go if player.lives. So the player lives is less or equal to 0. Then you want to change the game state to ended. So this will kind of fix a few bugs, but it will also make sure we don't just start a new game, because every time we level up, we basically start a new game. So if their lives is 0 or less, that means the game has been or should be ended. So let's go here and we say self : and then change game state to ended. Else, if that's not the case, if they still have lives left, then their game state should be set to running. This means it won't be going to the menu state, for example, or to the paused state. It will go right to the running state. And now we can remove this one right here because we don't need that anymore. Then we want to say how many asteroids we want to spawn. So we can say local num asteroids, and that can be equal to 0. And here we have our asteroids. And now let's say they do level up. We want to display the level on the screen, even if it's level 1. If we run this, new game, it says level 1. So even if it's level 1, we want to display this on the screen. So we can then say self.screenText is equal to text. And in here, we can just pass in all our required parameters. So first, the level we are in, level. That should be a level with a space, and then concatenate that by adding these 2 dots and saying self.level. So getting the current level. We'll say 0 love.graphics.getHeight, and we just times that by 0.25. So it won't be quite in the center of the screen, it will be a little bit above the center of the screen. And we can just add a comma there. We can then say h1 for the text size, true, true, love.graphics.getWidth, and then finally we want to position it into the center of the window. Okay, so currently we also have another problem we have to look out for. Every time we start a new level, there's a small possibility that once we start the level, the asteroid might appear on the player. So we don't want the asteroids to spawn on top of the player. We want the asteroids to spawn anywhere around the player. So to get this, we want to create an infinite loop. And this infinite loop will basically determine when and where everything should be spawned. So let's go create a for loop first. And say for I becomes 1. And until I is num asteroids, so the number of asteroids, plus self.level. Then we want to go local, and in the asteroid X, so these we have here, and we want to say local ASY for asteroid Y. I do believe since we're not really putting anything next to them, we could possibly just go like this, and this should be fine. But just for convenience sake, I'm going to do this. And then at the end of this for loop, we want to insert into the table, just like we usually do. However, this time we won't need to specify a specific size. We can specify the asteroid size, because then we have our specific asteroid size we want to spawn. We can then remove this. And in between this local and this table insert, we want to create an infinite loop that will reposition the X and the Y until it is no longer on the player. So we can say repeat until. And we want to repeat it until the calculate distance from player X and player Y. And we want to say the asteroid X and the asteroid Y. And if that is more than the asteroid size times 2 plus the player radius. So we're checking if the distance between the player and the asteroid is more than the asteroid size times 2 plus the player radius. So it means if the asteroid can currently damage the player was not invincible. Then you want to regenerate this ASX and ASY. So let's just put that here, and let's just put that in there as well. So it will run at least one time, and then you will try and figure out if it should run again. And it will continuously rerun this code until the asteroid is no longer on the player. So if the asteroid is no longer on top of the player. Now this isn't really required, but I do want to just go on top here and say require globals, because we are now using a function that's inside of globals, but it's not really required. Okay, cool. So it's not really a guarantee we're going to see this change, because we haven't really seen it in the past. So it's not really guaranteed we'll even see it now. But if we run our code, it should work and nothing should be broken. Let's go like this, say start new game. Okay, and as you can see, everything still seems to work. But now, the difference is the asteroid will always spawn a relatively far distance from the player, so that they have like a little circle they at least have to themselves. Okay, I also see here we only have 1 life left, but that was for development. We can remove that later, it's not really required now. Next up, we can open up the player so we can add the invincibility to the player. So we're going to know how long the player can actually be invincible depending on how many times it has blinked. And this will also indicate that the player is currently invincible. If I were to just show the example again, you'll notice the player blinks. And at least to me as a gamer, it says, hey, this player is currently invincible. Nothing can really touch it. And once the blinking stops, you're also no longer invincible. So here you can say how many times you want it to blink. So local usable blinks. And this will be the amount of blinks you wanted. In my case, I only wanted to blink 10 times. But then times 2. We're adding 2 to it because of how fast the blinking is compared to how long the player is going to be invincible. Okay, so let's go down a bit. Then let's go right above the lasers. And we can say invincible is equal to true. So this is if the player is currently invincible, if we cannot touch the player. To make that invincible, not invincible. And here we can say invincible seen, and then we can make that true as well. This is if the player is currently grayed out or not. So you'll notice we go from white to grayed out, from white to grayed out. This will say if the player is currently grayed out. And here we can say time blinked, and we can make that equal to the current usable blinks. So this is the amount of times the player can blink while immortal. Cool. Now let's actually implement the design for all of this. So let's go to draw flame thrust, and let's see here. Right above everything, we can create an if statement, and we can call it self.invincible scene. So if we currently are in the invincible scene state, then we want to say table.insert into color 0.5, and that's being passed in right here, so the color, and we're just basically setting it to 0.5, which is half its opacity. We can close this function again, and we can go to draw, and this is where most of the things are going to happen. Let's go here into the else, or not the else, but the if statement here, and right underneath debugging, we can implement if the player is currently invincible and what should happen. So if self.invincible scene, then you want to say love.graphics.setColor 111, and then faded and opacity, or 0.5. So this will basically give us our default faded / opacity we want, or we'll just default to 0.5. Cool. And in here we can just say else, and we can copy this line, paste it here, and we can just move this line up. We don't need to copy or paste any lines. And then we'll have this instead. Next up, we can close this function and go down to maybe the move player right here. We then want to take in dt, and this is the time between the last frame and this frame, for anyone who may have forgotten. This will allow us to calculate when the player should blink. We can then say if self.invincible, then we create an end here, self.timeBlinked. Make that equal to self.timeBlinked plus, actually minus, dt times 2. So this will first take the dt, times it by 2, and then take what we have, our current time blinked, and subtract it from there. We can then go on every uneven blink and make the player fully visible. So on every uneven one, for 1, 3, 5, the player will be fully visible and not grayed out. To do that, we can say if math.seal, pass in self.timeBlinked, and then modulo it by 2. And this is an easy way to see if something is an even or odd value. So in this case, if something is an even value, it will be true here, because 2 modulo 2 is 0, 4 modulo 2 is 0, 3 modulo 2 would be 1, because there's 1 left. We can just say self.invisible scene, make that equal to false. Otherwise, we can say self.invisible scene and make that to true. Then we can set if the player is invincible and make it false if the time blinked has ended. So if self.timeBlinked is less or equal to 0, so if the time blinked has ended and there's no longer any reason to blink, you can just say self.invincible and make that false. Otherwise, if the player currently isn't invincible, we can just set self.timeBlinked equal to usable blinks. So we're basically resetting it. And then self.invincible scene becomes false. That's about that for the player. And I don't believe it will be working just yet. So if we run it, the player will most likely not be blinking. Yes, because we even haven't passed in dt yet. Okay, to pass in dt, we can go to the main.lua file. And right here where it says move player, we just pass in dt, which is provided to us by Love2D. And then in here, where we say if not player.exploding, we also want to now go and not player dot invincible. Because if the player is not invincible, we are allowed to calculate the distance and make sure that the player is or is not exploding. But if the player is invincible, we don't want to do that. Cool. And let's see here. Right before this else if, we can go if the number of asteroids is equal to 0. So if there are no more asteroids left, we can increase the game level. So game.level is game.level plus 1, so it's going to increase by 1. And then game start new game. And we can pass in the player, and that will basically generate us not only a new player, but a new game for the new level. Great, now if we save this file and we run it, say start new game. Now the player will blink. If we try and hit something, we can go straight for it, and you'll see the level fade in and out. Now when we destroy this asteroid, it should increase the level because there will be no more asteroids left on the screen. Can go here and just... There we go. So now it's level 2, and the asteroids also spawned very far away from us. So there's no chance that once we go up a level, an asteroid will spawn directly onto us. Cool. Now let me just increase my life here so we can make sure if the player does end life, we can respawn without a problem. Let's go here and wrong one. Start new game. Okay, we can go through this asteroid. We can shoot up this asteroid and go to the next level. The level, let's try and go to level 3 just to make sure that all leveling systems work. Thanks to how we built the game, implementing levels is fairly simple. It's auto-generated, so come on, you can do it. Come on, there we go. Yeah, so now there's level 3. If I hit something, okay, then my hitboxes aren't the best. Okay, now we're invincible again, and we can fly right through stuff without getting destroyed. Until we are no longer invincible, where we'll explode if you try and touch something. Cool. And that's the gist of it. Now, one thing I did want to show you, but I kind of forgot in the previous tutorial, is kind of to show you an example of how we created the spawn before we get to the actual video, is if we were to go to the, I believe it would be anywhere like in a game or something, or just we just spawned the amount of asteroids. Yeah, so here is the num asteroids. Now when we play the game, if I go love dot and we start the game, new game, then as you can see the asteroid spawns far from us. But how do we know in the previous tutorial what we implemented really works, that the asteroid will never spawn on top of us? Well, when we go here and we change this to maybe 100 asteroids and we run it again, new game, as you can see we have like a little radius around us where it wouldn't touch us. Same with if we were to start a new level, it will spawn them all around us instead of at us. So if we make this 500 for example, and then we run it, then as you can see there's a little radius where they won't spawn on top of us. Also, I believe that level 500 is impossible. If someone plays this game and they get to level 500, then please show me how you defeat it, because that would be very interesting. Alright, so yeah, that is just what I wanted to show you, just to make sure you know that what we implemented actually works. So first off, one thing we have trouble with is if we actually start the game right now, and we just wait to unimmune ourselves. Well, wait, we can like start a new level and whatnot. Okay, now we explode. Okay, that's fine. Let's continue. Okay, now I explode again. Now we have 1 life left, and then I can show you what I mean. Alright, so now when I crash into this asteroid, which I just missed, and it says game over. Now when we start up a new game, you may have remembered this bug from a previous video. maybe new game, then we kind of continue flying off where we left off. So we just continue. If I die here, then it's just going to spawn me back at this exact location in the next game. Therefore, we should create a reset game function. So let's go into main.lua, and right above the love.load. And this could also be in globals if you wanted to, or you can create a utils.lua file or whatnot. But here we can say function reset, and this will just reset everything for us. And then here we can just say end. So first we can read the save data. So local save data, that is equal to read JSON, and then we can just put in our save.json, or in this case just save, we don't need to specify JSON. Underneath that we can then create our player, and that will just spawn a new player or create a new player object with 3 lives. We can then go game, and we can create a new game object. Save data, we can just pass that in, and then create a new menu object, which is equal to menu, and you can just pass in the game and the player, and then destroy asteroid, we can make that equal to false. Now this destroy asteroid, you might have forgotten about it, but if we go to our globals.lua, and we can actually keep this here, then you'll notice here, destroy ast. Just so you know where we are coming from. And here we're just making it false again, in case you may have forgotten where this is. Then after that, you basically have created a reset function. So what we can do now is we can remove this, as well as this right here, and we can just say reset. Because this player, game, and menu and destroy asteroid are all global because they don't have a local in front of them. So they can still be used once we use this reset. So now we're going to reset the game once we start it. And whenever we die, we want to reset the game again. To do that, we can go down to where update is. We can scroll all the way down till here where it says game.state.menu. Then we have our menu run click, and then our mouse clicked, which is false. Then here we can check if not reset complete. And this is a global variable, but actually we want to make it local to this file, but global in the file. So we can go up here and we can just say local reset complete, and we can make that equal to, and you might want to make this underscore complete or like this, depending on how you name it. When I scripted this video, it was probably like super late at night, and here I have like underscores, and here I have camel case. You should just stay consistent, but I did this late at night, so I'm not consistent anymore. Anyhow, this will tell us when we want to reset the game once we're in the menu state. If it's true, we can just call reset, and then reset complete is true. Then here we can say else if game.state.ended. So if the game state is ended, we can say reset complete is equal to false. So if we do die, then the reset complete will become false. Then once we go into the menu state, it will reset the game for us. Alright, we can now just save and test this out. This should make sure that once we restart the game, we don't just continue. I'm going to just decrease the amount of lives I have, because 3 is kind of unnecessary. So let's just make that 1 for now. But you could keep it 3, I just don't want to wait forever to be able to die. Alright, so let's see what happens. I crash. The game is over. Now what should happen is I should spawn in the middle of the screen again. So new game. Middle of the screen, level 1, only 1 asteroid. So we have basically successfully reset the game. Cool. We can now just change the player lives back to 3. Save that. Next we can go to globals. Now here we want to write JSON. So we already have read JSON, but now we also want to write the JSON. So I'm going to copy that, paste it, change it from read to write. We can also get the file name, but then we also need to get the data we want to write. Now we are going to get a table and we want to convert that table into JSON so we can store it inside of our save.json, because this may look like a table, but this is actually JSON. Okay, so to make sure it works, we can also print it out to the screen if you want to, but we are anyways going to see how it looks once we put it inside of the save.json. So you could print it out to the screen, or you could just look how it looks in the save.json. Okay, so now we can have our local file and we want to open it, and it's going to be the same file, but this time we want to open it in write mode instead of read mode. Then we want to go here and say file.file::write. And the only reason I'm getting these yellow lines is usually because you'd want to check if this file is nil or not first. If the file is nil, you don't usually want to try and write to it. So if you want to be safe, you can first check if file is equal to nil, then, and then you can just like return or something. Anything here would work. Or you could just do this if the file is not nil. So if it's not nil, then you want to do this. And as you can see now, the yellow lines are gone because we know file is not nil because we checked for it first. So yeah, that's just something you want to maybe take note of. I'm not going to do that right now, but you could. There's nothing wrong with it. It's actually better practice. I'm just not going to do that right now. We can then say luna.json.encode. So first we used decode. Decode converts JSON into a Lua table, whilst encode converts a Lua table into JSON. Then here we can just pass in data, which we get here. They want to close the file, and then the function is done. We don't need to return anything. And this will write to our JSON. To make sure it works, we can actually just, yeah, that's already zero, so we don't have to change that. We can now go to game because we want to save our high score. So once we boot into the game again, we have our high score there. So we can go to the top and we can create a new function called save game, which is equal to a function that takes in self, and it just does write JSON, and then the file name, which would be save, and then the Lua table. In this case, we want to save the high score and just self.highscore. And this should save the file for us if we get a new high score. Now, it won't just call itself. We need to still call this function. So here in game over, for right now, we can just say self:/save game, and this will save the game for us. Let's try and run this and make sure we actually get that. So we can open this save.json so we can see what happens. We say new game, current high score is 0. But if I were to just go up here, you'll notice my high score also increases, but now we need to make sure it saves. So just give me a second and let's blow up. Now you get a game over. Our high score is 1110. Okay, we need to see and make sure that that high score is what we see. If I say quit, then as you can see, it updated our file. Now the high score is 110. Okay. Now I'm just going to decrease my HP by going here and just saying make it 1. Just so I don't constantly have to wait forever in order to finish the game. Now let's say we only get 1 score here. And as you can see, our high score is 110 now. And our score is 20. So our high score and our score are 2 different things at this moment. If we crash, we get our game over screen. And we go to our save.json. you'll notice our high score didn't change along with it. That is because our high score here never changed. So as long as this high score doesn't change, the high score we save will not change either. That is why we could just go here, and we didn't have to do any checks before, because we already do checks to make sure that this high score doesn't go over the normal score unless we get more. For example, if we go here, our high score is 1110. If we try and beat that high score, okay, so my high score increased as well as my score, as you can see, since my high score has been surpassed. So now both of them will be increasing, and once I explode, then the high score inside of save JSON is also updated. So you'll notice that the high score only changes once the score is higher than the high score. And that is that for today's tutorial. This will be your final Love2D tutorial. However, to all of you who made it all the way here to the very last video, well done. You have all done such a great job getting here. And with one last step, you can finally continue on your road to being a game developer. Now before we continue, because I know a lot of you probably missed out a few pieces of code here, or might not know what to do after you finish this, you could skip this part if you want to, because it's not that important. But here we can just bring this over. So all of the code is on GitHub, and this link will be in the description. So if you miss anything, you can just go here and you'll be able to find it. All of the code we have up until now. Now when you go into Lua and then into Love2D, you'll have the Asteroids game folder, and that's what we are building. And we are at number 15, so you can get number 14's code if you have fallen behind, or if you just want to get a few things that we'll get to in a second. Once you finish this course, and you don't know what game to build next, I do have a few things I want you to try and do on your own, and also point a few out during the gameplay whilst I show you what we're implementing, what you could also add. So here is a lot of things called homework, and you don't have to do this, but if you do this, you will learn how to build a game on your own without my help, which is very useful because I won't always be there to hold your hand while we code a game together. Sometimes you'll have to do that on your own. And this is where it can start. There's a lot of things you can do. Create a settings page. Because if we look here, we have a settings button, but it doesn't do anything. So you can implement that settings page. That's what I want you to do. You can add more sound effects, which we'll be doing in this video. You can add a better design to the menu. Add mobile support. Add items to the game. So let's say you want to give your player better guns. So let's say after every third asteroid they destroy, maybe a random gun will spawn that they can, if they hit it, then instead of exploding, they will equip the gun, and then they can shoot better lasers than what they currently have. Which could help them, like once they get to like level 500, if they have a very powerful gun, it could be an easy game. You can add more enemies because currently it's very basic, but you could add, like in the original game, an UFO that will occasionally also jump in and maybe shoot the player or just try and hit him. And then you should also try and destroy that UFO. You can improve the performance because currently it's not really focused on performance. If you have a very powerful PC, you won't even notice it. But after this tutorial, if you have a low-end PC, you might notice frame drops going till 30 FPS, if not lower. And last but not least, or not yet, but you can also add a better pause screen. And then last but not least, you can add multiplayer support. This is something that can bring you very far in the future. You can go and get yourself a Lua module the Love2D module or just Lua module, and you can start trying to code your game that two people on two different computers can try and play the game together. It's going to be a very difficult thing to do, but if you get this right, you can make any game and you can make it multiplayer for more people to play together. And the multiplayer game is usually a bit more successful than the single player games, because multiplayer games you can play with your friends. So here's a bunch of things you can do, and we'll go through a few extras in the video as well. Now in this video, we'll be adding background music and sound effects. I want you to go here to our GitHub page, go to number 15, which is the last one. Then you'll notice here inside of source, we now have a new folder called sounds. Go into sounds, and here you'll also find all of the sounds we will be using in the tutorial. And you can just open all of them. And then you'll notice there's a download button, and you can just download them all. So you click download. And did it start the download? Yes, there it goes, it downloads. And just download all of them until you have all of the sounds. There you go. Once you have all of this, we can just move this back to a different screen. We can then open up our file manager, and here under source, we can create a new folder called sounds. And we can then go here to downloads, where our things should be. And we can just copy all of the sounds we just got. And we can just throw them in here into the sounds folder. And there you go. Now you might have to rename a few of them, because the names are now incredibly long and tedious. So just go here. There we go. Oh, I didn't do anything. There we go, okay. And just rename all of them. Alright, now you'll notice we have two types of sounds here. First we have OGG and MP3. This is just to show you can use multiple sound types. But usually you'd find people using OGG and MP3. And a lot of people also use WAV or WAV. Now I just chose OGG because I think that's what I got when I downloaded these here. You can also play them if you want to. I would play them, but I don't think you'll actually hear it now that I think about it. Alright, so I quickly fired up a different screen recorder, so if the quality might be a little bit low, that is just because I'm using OBS instead of my simple screen recorder as usual. Now, we can actually hear how this sounds. So if we actually go here and just say open containing folder, we can hear how all of these sounds. So the background music. Yeah, then we have the explosion asteroid. So that's when an asteroid explodes. Then when the player explodes. And of course you could change these sounds to be something else. I just went online, did a quick Google search for free music or free sounds, and I just downloaded the first one I saw. So you could definitely change this if you want. That's how laser will sound. Then an option select, like selecting a button. Then the thruster. Then the thruster but louder. Yeah, I couldn't remember why I had both of these, but we'll try and find out right now. Alright. So now we have the sounds. Next up, we can go to components and create a new file called sfx for sound effects.lua. And like usual, this will go local love is equal to require love. And we have our function sfx, which will return a table, and you can just return sfx. Alright, so first we probably want to select the background music. So let's go up here and we say local BGM, or local BGM is equal to love.audio.new source. And remember, if you're wondering about any of this, this is on the Love2D documentation. So just go to love2d.org, I think, and then you'll find the documentation which explains this as well. Then we should select the background music. Now we can say src, then sounds, and then bgm.mp3. So src sounds bgm.mp3. So we just selected it. And then we want to set the mode to stream. Stream is when you have long audio tracks like background music, for example, that's going to continuously play for a long time. So let's say it's 30 seconds or longer. You probably want to use a stream. Cool. Then you want to go BGM, go to the next line, BGM set volume, because the volume will be very loud, but you could change this depending on how you like it. And I'm going to set mine to 0.1, which would be very soft. But the volume will be very loud, but if you want it louder, you could make it louder by just increasing this number. Then BGM set looping to true, and this will make sure it loops continuously over and over. So once the background music ends, after it's like 30 seconds or whatnot of playing, it will start playing it again. Cool. You might think this is annoying, but a lot of games actually do this, where you just play the background music over and over and over again. And usually people don't find it too annoying unless the background music itself is an annoying tune. Cool. Now we want to link all of our effects, so all our sound effects. So you can go local, effects, and this will be a table just to make things easier. It doesn't have to be a table, but I'm going to make it one. I'm going to copy this line of code, just remove the local, change BGM to ship, explosion, and make that equal to everything here, but we're going to change this to this explosion player .ogg, and we're going to change from stream to static, because static is better for these shorter audio tracks, like that's 5 seconds long or 10 seconds long. If there's very short, then static would be better. We can then just add a comma here and then copy paste it 4 times. There we go. Then this can be asteroid instead of ship. And then of course we just change from explosion player to asteroid. Keep it static, whatnot. Then this we can change to the laser. And here I'm spelling it with an S, because here I figured out you actually spell laser with an S and not a Z. So just in case you want to know. But if you want to stay consistent, because if you linked your laser with a Z, you could change that to Z. And then here we say laser. Here we can call this select. And then option select. And then thruster. Which will of course be thruster but loud. So if you think the thruster is too loud, you could probably go for normal thruster. But this is just for making it a little bit louder, because I think this normal thruster is probably a little soft. Cool. Now first, when we play an effect, we should have a true or false value to say if an effect has been played. So fx for effect, and then played. We make that equal to false, because by default nothing is being played. Then set fx played, and this will basically just set this fx here to true or false. You don't have to use a function for it, but I'm going to use a function for it because it's just a bit safer. We're gonna go function self and then has played, and then just self dot s for fx played equal to has played. Now we want to create a function to play the background music when we want it to. So we can just go here and say play BGM for background music. That's a function, takes in self, and we can check if not BGM is playing. So if the background music is not being played, then end. So this right here just checks if the background music is currently being played. So if it's going dee 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 in the background, then BGM play. So if it's not playing, we want to start playing the background music. Cool. Now we need two more functions. First one is to play the effects. So if we want to play a sound effect, and then the other one is to stop a sound effect from playing. So let's first do stop sound effect because that's the easiest one. You can say function takes itself and then the effect. Then if effects, and then we want to pass in the effect. So this right here will go to the effects and see if we pass in like a ship explosion string or an asteroid explosion. And then it will try and select that one to see if it currently is playing. Which if it is playing, then you want to stop the effect from playing. So we can just copy this and then say stop. As simple as that, and that will stop the background music from playing. Next up is to actually play the effect. Now playing the effect is a bit more complex because we have so many effects. We can just say play fx is equal to a function that takes itself the effect we want to play and in the mode we want to play it in, and I'll explain this in a second. Now we will have three different modes. We'll have single, and the single mode is when we only want this effect and no other effects to play. Then we have slow mode, and this will just play the effect as normal. And then we have the else, which will just stop this effect from playing if it's already playing, and then start playing it again. Alright, so let's implement that. So if mode is equal to single, and it might sound a little bit confusing right now, but you'll understand what I mean in a second. Then if not self.fx played, then so if the effect is not being played right now, then self:set fx played to true, so we want to set it to true. And then if not effect currently is playing, then we want to go effects at effect play, and this will play the effect for us. So basically this is a sound effect that's only allowed to be played once. That's why it's single. Next up we want to do the slow mode, so else if mode is equal to slow, then if not effect, so the current effect is not being played, then effect, and then play. Now usually you don't actually have to do it like I'm doing right here. It's just I like to have a little bit of variety in my effects. They shouldn't all just be generic. There should be like different versions of it. For example, single, where it's only allowed to be played once. Slow, where it's allowed to be played, but we first check if it's currently being played, then we can play it again. And then finally, last but not least, where we'll stop the effect and start playing it again. Okay, that can be any other command other than slow. So else and single, of course. Self stop fx, and it will stop the effect, like just like here. And we can just say effect, and then effects at effect, and then play it. Cool. And that is the sound effects file. It could be much bigger, but I like to keep it a little bit simple for right now because you might want to expand on this later and you don't want it to be too complex. So let's start by going to the main.lua file. And here in reset, we can just go sound effects is equal to sound effects to create a new sound effect object. And of course we should import it. You can either use dot or slash notation. As you can see, I use both of them here as an example. So sfx, and we can just go to components dot sfx. Now when we load the game, we want to start playing the background music. So we can just go SFX and then play BGM, and it will start playing the background music for us. Cool. And let's play our game and see what we get. And as you can see, we get background music playing for us now. Alright. So that is for the background music. Next up, let's go to the menu here and let's just pass in sound effects for all three of these. SFX, because we're going to add sound effects to all three of them. And we just change the player lives to 3. Player also has another player object being created here, so we can just pass in SFX here again. There we go. And we'll later on change that in the player itself. Now first, let's go to menu, which should be here in states. And first we can take in the sound effect, so SFX. And then here where we go to run, when we check if the button is being hovered on. If it is being hovered, then you want to go SFX : play, or play, and then FX for the sound effect. And you can say we want to play the select and single. Alright. So it should be able to run if it's not going to crash because of those nil values. As you can see, it kind of plays. However, we need to also add another line of code right here inside of the else statement. So if self.focused, so the one is currently focused on, is the same as the name, then we can go SFX set FX played to false. Because if you could remember, if we go here to SFX and we go to single, then here it sets it to true, but here we check if it's already false. Now we are manually setting it to true or false depending on the context. So we don't want it to play multiple times over the same button. So we're saying single here, and we have to reset it to false here if it has already been played before we are allowed to play it again. You could remove this if you want to. It does help make everything just work fine. Now go, as you can see, you can now go over all of them and you can do it multiple times. Cool. And as for the menu state, next up, let's go to the game state. And all we need to do here is just where we create this asteroid, we can just also pass in SFX for sound effect. Because the asteroids will also have sound effects for once they explode. And before we go asteroids, we can go player, which would be inside of objects and player. And first we can take in sound effects. And then first, here with the shoot laser, I believe, because that's when we want to play a shoot laser sound effect, we can just go SFX, play, FX, and then just the laser. And since we're not passing anything in, if we go here to SFX, that means it will stop the effect if it's currently playing and then start replaying it. So let's run that and hope it works. As you can see, now if I were to spam the button, you'll notice it just keeps on playing. Because the sound effect is so short, you don't actually hear the sound effect getting cut in half, basically. So if you spam it, you're not going to hear that sound effect being cut in half, which it is currently actually doing. Next up, we can go back to player and just go to move player. And in here where we say if self.thrusting, so if we're currently thrusting the player forward, we want to go here and just say SFX, play FX, and we want to say specify the thruster, and then slow. And slow, of course, if we go here to slow, it will just check if the effect is not currently being played, then it will just start playing the effect. Alright. And we can do the same here at the bottom, but now we can just say, if we're not currently thrusting ourselves forward, SFX stop, FX thruster. Cool. Let's see if that works. Oh. That's weird. Let's try it again. So at 30, we're trying to index a nil value. So right here. Okay, so thruster seems to be a nil value. Also, it seems we haven't taken an SFX here in game, so you can just also take that. And let's see here. You know what? I spelt incorrectly. There we go. Now it should work. Okay. Alright, you'll notice every time we now thrust, it makes a nice sound, and it stops once we stop pressing the W key. Cool. Then last but not least, we can go to Asteroids. We can go to the top, we can take in sound effects. Then we want to play an effect once we destroy the asteroid. So in the destroy function, once here, when we resize and whatnot, we can just pass in the sound effects as well, because we're creating new asteroids. And then at the end, before they remove, we can just say SFX, play FX, and then we can just say asteroid explosion. Then if we run it and we shoot an asteroid, we should hear and there we go. So now you hear that every time you shoot an asteroid. And just like that, we added sound to our game. And believe it or not, that actually took me a whole day to implement on my own. Just because we did it pretty fast doesn't necessarily mean it was very fast. Anyhow, and that is the end of the Love2D crash course. Thank you all for watching. It was a very fun experience doing this with all of you. Now, before we go, I might want to give you a little bit extra homework if you're up for the challenge. You might want to make this on the background to make it look cool, have the asteroids be flying in the background. Wouldn't that be cool if you're here in the menu state and it does that? Alright, and if we go to new game, you might want asteroids to explode when they hit each other. Wouldn't that be cool as well? But then, of course, the player score doesn't necessarily have to increase, but it could be pretty neat if two asteroids were to hit each other and then explode into more asteroids. And yeah, that's about it. You can also try porting the game to Android, which I have not really tried, but it would be a pretty difficult challenge, and if you get it right, then you can make Android games for yourself and for your friends. Now, you might be wondering, now after you've finished Lua and Love2D, what next? What should you be looking forward to doing next? Well, in this case, there are a lot of opportunities for you. Option 1 is you can start building your own games. You now have the fundamentals and the knowledge to build your own games. Option 2 is if you want to maybe look at learning a couple more things. I do make more tutorials outside of Lua and Love2D, such as PHP, NIM, Afrikaans if you're into that, AWS, and many more, even Python. So if you're interested in learning another programming language, take a look at my channel. There's a ton more for you. You just search up Crash Course. And Bob is your uncle. Here are a bunch of crash courses for you. If you're still looking forward to learning more about Lua and more about game development, I do have ideas in the making for more game dev tutorials. One left I'm still doing for Love2D, and then a couple I'm now focusing on with potentially Roblox and Godot. But we will get to that in a future course. So feel free to subscribe if you want to stay tuned for that. Otherwise, I do have many other tutorials you could follow. If you want to continue with game development, you might want to look at something such as Default. Now, Default is a game engine that, as far as I could remember, uses Lua. So if you're looking for something a little bit more your style, so maybe you're okay with not using Love anymore and you want something a bit stronger for maybe 3D game development, then Default may be what you want because it supports Lua. If you're looking to develop games in other languages, Godot is also a really good choice because Godot does not only support C++, it supports pretty much any language you throw at it thanks to it being open source and having such a large community. And to be honest, it's pretty awesome, so I would recommend to maybe take a look at it, potentially use a Lua plugin and try and code Lua with it if you want. Thank you all for watching. I hope you enjoyed this course, and I will see you all again in the next tutorial.